see if that worked. I had this set up to, that might have went live. I had this set up to, oh, where'd it go? Oh, there we go. Okay, we're live. How do I just let people in? It's like a waiting room. I thought when I did this, I thought it set it up so that everyone can just get in, but apparently not. That's okay, I'll do it manually. Welcome everyone. So I'm just gonna wait a while for kind of people to get in. So we were just kind of chatting, or I should say this is the Learn, Go in One Day workshop. So this is targeted both at people who have never programmed before, and this is your first experience programming, but it's also targeted at people who maybe know another programming language and want to learn Go. All right, someone else? Yeah, I thought when I set this up, just people can join, but apparently not. So I'm just gonna wait a little while for people to join, and we'll see how that goes. Okay, good. Cool. Hey, how's it going? So I stream a bit, and when I first started doing it, I found it very awkward, right? So like the reason I have a screen in front of me, my camera's over here. When I first tried streaming, I tried looking directly at the camera, and I found it very, very strange to stare at a lens. And what I found is more comfortable is if I look at a screen and I see people, and it's like I'm talking to a real person. And I find that much more natural and much more easy to do. I find it like actually quite difficult to just stare at the lens. So I'll be staring here, but I am looking at you. I'm looking straight at you, if you're sharing your screen, that is. But yeah. And like I was actually studying like the video industry for a while. I mean, like a long time ago, I started studying in like the 1990s, but more recently I started studying it again in 2018. And I talked to a bunch of managers and talent agents. And one of the things they told me is that, you know, if you do video, there's three things. If you don't have them, like a lot of people won't watch you, right? So the first thing is like you need good audio, and hopefully my audio is good. I've got a shotgun mic pointing at my face. The second thing is a purposeful professional background. I don't know how professional it is, but like I've got like, you know, an interesting display. I've got these colored lights. I don't know if you notice they're changing color. So it's something interesting to look at rather than just my wall. Maybe I'll do something better later on. And then the third thing was having a good camera. So I've got a Micro Four Thirds camera sitting just over here on a table, which you guys can't see, but so I got that set up for this. So I do stream from time to time. This is also my office now that I've been working from home due to the whole COVID stuff. Yeah. Oh, there's another person. Let me let them in. I really thought I made it so everyone can get in whenever they want, but are they in? Okay. Oh, there's another one. So we're just waiting for people to show up. I think there were 81 people who RSVP'd to this. Being on, you know, this group video chat, I think is the best place. If you want to ask questions, you can do that. Now, everyone's auto-muted, and you know, it's just like, you know, people might have fans on or there's background noise. If you want to talk, hold down your space bar. That's a way to do it. So if you hold down the space bar, I think for most people, we should be able to hear you. So anytime you want to ask a question, do interrupt. Like you don't have to wait. Interrupt. If there's something you don't understand, like maybe I went too quick, maybe I explained it poorly, or whatever, ask the question. There's probably like 5 other people who are thinking it too, just didn't ask the question. So interrupt whenever you want. So I'm just waiting for people to arrive. Okay, there's a whole bunch in here. There's about probably as many, maybe a little less, watching the stream. Okay, good. Okay, I'll wait another few minutes and then we'll get started. Yeah. So what I was saying before, I've been programming for 15 years. I think the first language, or not 15, sorry, 25 years, more than 25 years. I actually underestimate how long I've been doing some of this stuff. It's a function of getting old, I guess. So there's some things I think it was like 3 years ago, and it ends up being like 8 or 9 or something like that. But yeah, I started programming like it's at least 25 years, maybe longer. I don't completely remember. I remember I was like a lot younger. I think I was a teenager at the time. I don't think I wasn't preteen. Definitely wasn't preteen. Although I did do stuff like when I was in elementary school, there was a language called Logo, and what it was is you had this little thing they called a turtle. It was a little triangle, and you made it move around. It drew pictures. So I guess that's a kind of programming that I took when I was in elementary school. And then, like I was saying before, we started streaming. When I was, I guess it was in the 90s. I was a teenager at the time, but a friend of mine, he had a video game, and it was on a PC. So like video games kind of, I guess in part, kind of got me into programming. I think, I don't know if it's still true, but at least it was true like back in the day. Like this is before like, you know, the .com boom, and before computers became a really big deal, before people were using like most people were using the internet. Like internet existed, just almost nobody used it. Not like today where it's ubiquitous. But you know, I was into video games like a lot of teenagers are. And a friend of mine had a PC, and he had this one game, Dune 2, D-U-N-E 2, not D-O-O-M, which was made by id Software, but Dune 2. It was, I don't know if it was the first. Hang on, let me let some more people in. Oops. I don't think Dune 2 was the first real-time strategy game. I think there was one before it, but they might have kind of made these independently. But it was the first well-known one, and it's what got me into programming, I think. So, you know, the friend of mine had Dune 2. I really liked the game, and I persuaded my parents to get a PC. So this is like a long time ago. They bought the PC, and it was quite expensive at the time. I mean, your phone's way more powerful than that thing. Probably the calculators you can get now are more powerful, but I was able to convince my parents to get one, and, you know, I played the game, I loved it. And what happened is, you know, I bought a book. I was like, okay, I want to learn about the computer. So I bought a book, and I started reading the book, and the last chapter was on programming. And it was programming in this language called BASIC, QBasic, actually. So I started doing that, and I was like, oh, this is pretty cool. And it even came with, you know, it came with some basic programs. It had some games on there where you could draw stuff, which I thought was pretty exciting. And then, you know, when I went to university, I was taking mathematics, and I just started taking, you know, programming for fun, like in the school. And I took a language called Pascal with a P, P-A-S-C-A-L. And when I was doing that, I went and taught myself assembly language. I taught myself C, and I just started taking more and more courses on this stuff. Oh, someone else is joining, so let me let them in. Yeah, I started taking more and more courses on it. I did a lot of math. Like I was doing 4th year math, and then I kind of like did a switch where I started doing a whole bunch of computer science. I ended up being like in university for more than 4 years for my bachelor's, just because I did math and then I did computer science. And some of this was, it was before kind of like the computer industry boomed, before we had the .com boom. I think a lot of people, when they take courses, they kind of, you know, they try a whole bunch of stuff, and if they're good at something, you know, if they find it easy, they like it. If they don't find it easy for whatever reason, it could be like, you know, a bad teacher or something like that. If they don't find it easy, then it's boring, right? Which is kind of interesting. But for me, you know, I always found like math and, you know, computer science, physics, chemistry, I found those easy. Go to English class and I struggled. Like I struggled so much, like in those courses. They're actually quite difficult for me. Like I remember there was one, okay, this is in 12th grade. So we were reading a book, and we took a test on it, and the last question on the test is, what do you think about such and such? And, you know, I wrote down what I thought, and the teacher marked it wrong, and I was like, well, how can you mark this wrong? I told you what I thought. It's like, do you think I lied about what I thought? It's like, well, that's not what I meant. It's like, well, how am I supposed to know what you mean? There was another situation, like I needed some English courses in university, and, you know, I had a heavy course load. Just let me let someone else in. I had a heavy course load, right? And I was only able to fit certain things in there. And what I ended up picking for the English course I needed was poetry. And I know you look at me, you think natural poet, but I ended up taking poetry, and like we took the course and we like kind of work in groups and we read a poem. And I started, I read the poem, and then there was a test after that. We all did the test separately. And there was one question on the test: what color do you feel? And I was like, what? What color do you feel? I asked the teacher, I was like, I don't understand the question. What color do you feel? Just write down what color. It's like, I don't know. I just like picked a color at random. And what I didn't appreciate or wasn't aware of was that some people associate colors with emotions. I had no idea. So I failed that test. But after that, I learned the mapping that the teacher had between colors and, emotions. Like, red is mad, blue is sad, and et cetera. So, like, I know it's like probably common knowledge for most people in here, but like I was completely unaware of this. But I learned it and I passed it. It just, I guess I found it a bit frustrating. Like when I did math, like it was like there was an answer, right? Like I could figure out the answer. But when I did English, it's like, okay, this is confusing. But yeah. So I mean, I think I kind of self-selected into this just because I kind of found it easy for myself. But like some of the stuff, I think some of it's just like sometimes the path you take or maybe the teacher you get. There was one student we had. I'm associated with the school, by the way, but there was one student we had, and he wasn't into, like, he was into business, but he wasn't into like math or programming. But he came and took a programming course with us, and like he was good. Like he is really good. Like he's a machine. Like seriously, he's a machine. He picked up the stuff so fast. And I kind of talked to him about it, and I was like, well, why didn't you go into this stuff? And what he told me is that, like, he had one math teacher, right? That like I guess like for whatever reason, like he wasn't able to learn off him. And ever since then, he's been turned off by anything technical, right? Just like one time, one little thing, right? And it could be like, not for his case, but it could be for others. Like maybe there's stuff going on in your life, like maybe, family issues, like maybe someone passes away in the family, or, maybe you're a bit older and you have kids and you have all that responsibility goes. Sometimes, just getting distracted or having something else that kind of brings your attention can, like, distract you from learning the stuff. But not only, it can affect you like down the road, right? Which is kind of interesting. Okay, so I'm just gonna check a bit. So I think we'll start in 3 minutes. So I'll just like wait 3 minutes and then we'll start. But I'm glad to see everyone. Yeah, so for the people joined, this is the Learn Go in 1 day workshop. And as I was saying before, I tried to design it so that, because I think there's going to be a bunch of different people who are coming to this. Some of the people coming to this is the first time they've ever programmed. And I've tried to design it so they can get a lot of this course. But also, some of the people coming to this, they know another programming language, they just don't know Go. And I've tried to design it for them too, and everyone in between. So, for the people who have done another programming language, this is probably going to cover some stuff that, you're familiar with already. But that's absolutely necessary for the people who have never done this before. I've also tried to make this so that you don't need to install anything on your computer. So there are some online tools that allow you to program online, right? You can just go to this URL and you can write code and you can test it out. Now, typically, like from day to day, if you're working as a software developer, that's not how you typically work. You typically have a bunch of tools installed on your computer, and you use those to write your software. Another person, I let someone else in. But it can be quite a chore to install that software. And given how many people are here, I was trying to avoid, like everyone having the problem. So we're going to focus on programming in Go. And I'm going to teach in a way that you can use these online tools. If you were able to install the software yourself, that's fantastic too, but it's not required. And there's 2 tools we're going to use, and we'll get to that once we get into the lesson. But there's 2 tools we're going to use. It was funny. Just before this, I had my laptop kind of die. I was like, oh, this is like the worst timing. I had that happen once before when I was traveling. I think I was going to Korea at the time, and my phone died. And I don't, at least at the time, I didn't know that many people in Korea, and having a phone is absolutely necessary for me to communicate with like anyone, right? So that was, I had to just go buy something. I had that happen one other time. I had my laptop die, and I ended up with like what I have now, which is the one that died a bit. But I got it working, which is great, because I thought I'd have to run over to the store and get a new one. Okay, so I'm just going to get set up, and we're going to get started. And just give me a sec. So I'm just going to clean up my laptop a bit, so there's not a lot of clutter. So let's see, I'm going to switch my screen. So I've got this thing where I can switch between screens. Let's see if I do this right. No, that's not right. That one. Okay, there we go. And then I'm going to try to go full screen. So I got to figure out how to do that. How do I go full screen? How do I go full screen? So this? Probably not this.
Guess you gotta hit share, no?
Share? This one? Well, what I want to do is I want to be the only one. Oh, maybe speaker view. Speaker view. And I should be the speaker. Okay. How? It's a little blurry. Huh. Okay, that's actually quite blurry. Maybe, how can I fix that? All right, technical difficulties, people. I think what I'll try. Okay, so maybe I can go share screen. And then if I share.
Are you sharing screen on Zoom too? Because I don't think you're.
Yeah, it's what I'm going to try. Okay, do you guys see that?
There you go.
Everyone see that?
Perfect.
Okay,
Yeah,
good.
that's better.
Let me just check YouTube.
Better.
Okay, seems okay. Okay, so welcome everyone. This is the Learn Go in One Day workshop. There's if you want to connect with me, I have a whole bunch of stuff from different places you can connect with me. My name is Charles. I've been. Well, I'll get into who I am in a sec. But yeah, let's do that. So, oh, hang on. Should be able to switch this. So who am I? So my name is Charles. I've been programming for over 25 years. Originally, I was self-taught. What does that mean, self-taught? It means I read books and magazines. So this was back before the internet was common for most people. So back then, if you wanted to get anything about computers, you had to usually get a magazine or buy a book. Eventually, I got a formal background in computer science and mathematics with a bit of physics. I've been in at different companies over the years. I've been doing this for quite a while. So some past companies. Oh, hang on, someone else joins. Let me admit that person. Oops. Some of the past companies are like Coho, Hootsuite, you probably know that if you're local. Electronic Arts, and then there's Trulioo, one of the companies I was involved with. We sold it to Microsoft. Etc. There's lots of them. Nowadays, I'm involved with CompSci Academy and Spark and Railtown Ventures. And if you want a full bio, it's something more like that. I also have I have a website if you want to read more about me. It's changelog.ca. But I've been around for a while. I've worked at big companies. I worked at small companies. I've created a whole bunch of companies over the years. Some people know, some people don't. Some of them we sold to large companies. So I've been doing this for a while. Okay, just so you know, I'm involved with Comp Sci Academy. For those that are interested, we do have a 12-week boot camp, and if you're interested, that's a sign up URL. It's actually a Google Forms thing, but I figured that's easier. Online, I usually go by Reaver, Reiver, but if you go to reaver.github.io/go-bootcamp, if you're interested in that, you can sign up. So if you want to continue learning this after this workshop, or whatever. Okay, so let's switch lesson. Okay, so it's a little better up on this, so I'm going to switch to the lesson on that big screen instead of doing my laptop. So just give me a sec while I kind of fix this. So how does that look for everyone? Can everyone read that? Actually, can you see? You might be seeing the wrong thing, because I can see in Zoom. I think you're looking at the wrong thing. So let me just switch that. Put it back. And then I'm gonna do screen share again. Can everyone see that? Can everyone see the notes? Is it legible? If you want to talk, you'll have to unmute yourself.
I think so, yeah. The preamble, who am I?
Yeah, you can see that? Okay, great. Okay, so we've already gone over who am I. So let's just scroll down. So I'm just gonna I'll talk, but I'll also have these for people who maybe it's a little difficult to understand me. So like I said, this workshop is for both people who this is the first time programming, but also for people who have programmed before, maybe know another language, and they want to learn Go, and everyone in between, right? There's people who maybe they've tried a bit on their own to learn some programming, and they're looking for something to kind of help them learn more, right? And this workshop's for all of you. So let's go over some meanings, because there's probably you've heard a bunch of these words, but you might not be familiar with them, what they actually mean. So one term you'll hear a lot is source code, right? So source code is basically what we'll end up writing. It looks like this. So this is some Go source code. It's very simple. Hopefully you can see me moving the mouse. Often source code is shortened to just code, right? So when someone says code, they mean source code, right? And source code, it kind of looks like English sometimes. It's meant to tell the computer what to do, but it kind of looks like English, sort of. Why do people write code? Well, people write code to tell computers what to do, right? That's why you do it. You want to tell the computer what to do. It could be for example, think YouTube, right? Or you're using, you might be on Zoom, or you might, be playing a game on your mobile phone, or maybe you're playing a game on a console, or maybe you're flying a drone, right? Or maybe your car, even has computers in it. You're telling those things what to do. The programmer tells that thing what to do, and you do it in a programming language, usually. Okay. So in this workshop, what we're going to do is we're going to write instructions to tell the computer what to do, but we're going to do it in Go, right? And there's different ways you can do it. Our code is Go, but you could use other programming languages, and that would be a different language you use to tell the computer what to do. The people who write code, code being source code, the people who write source code, there's different names for them. There's a bunch of different names. Some people will try to make up different meanings for each. In practice, they tend to mean the exact same thing. So one of them is computer programmer. So computer programmer is one name for someone who codes. Often that gets shortened just to programmer. A fancier name for it is computer scientist. There's also software engineer and software architect and software developer. There's even software development engineer and coder. There's some older versions of these names. You don't hear these much anymore, but there's also computer analyst and systems analyst. You don't hear those much anymore, but these are older names. There's some that I've heard more recently, but they don't seem that common. One of them is software scientist. Another one is cyberlord. So these are different alternative names for people who write code, people who write source code. And if you do this, or you end up doing this, you'll be these things. People just pick different names. Like I think the most popular one right now is software developer, but it wasn't always. Okay, so the act of writing code is programming. So when we write that stuff, like I showed you above, that's programming. It also gets called coding. So coding and programming are the same thing. One thing to be aware of, often computers do not understand code directly. So if I just gave my computer the code, it's not going to understand it. What you need to do is turn the code into a program, right? So when you turn the code into a program, that program will contain instructions the computer will understand. So although we write it in Go, and people might write it in different languages, the computer understands a very different language. It's a language that's a little more difficult to write instructions in. So a lot of people write it in a programming language like Go, so that they don't have to work with that low-level language, just because it makes it easier in many different ways. So a program, it's something that tells a computer what to do, and there's different things you can tell a computer what to do. For example, like it could be Twitter, like the Twitter application you might have on your phone is a program, right? If you have a flying drone, right, the flying drone has a computer on it, and the thing controlling it to fly and all that, is a program, right? There's programs all over the place. Now, if the program is something that's meant for a regular person, right? Like say, your children or your parents, assuming they're not software developers, if it's meant for regular people to use, like the Twitter application, or a video game that you're playing on a console, right? Or like a graphics program that you're using to draw, that kind of program is called an application. So an application is a program meant for a normal user to use. Application is often shortened to app, right? So when you hear about apps, it's just a short way of saying application. And an application and an app is a program meant for a user to use. Some examples of programs that are not meant for normal user use, for example, like directly, you might have heard the term Android, right? It's like for Android phones. Well, what is Android? Android is a program that runs on some phones that you're not going to use directly necessarily. And it's a class of program that often gets called an operating system. If you're more of a fan of Apple hardware, then you probably use iOS, or if you have a desktop, you might have used Linux. Some people call it Linux, Windows, Mac OS, right? Those are examples of applications those are examples of programs that are not applications. Okay. So yeah, there's different kinds of programs. Like if you've ever played video games, those are programs. If you have a modern car, it probably has a bunch of computers in it. Those are programs. If you have a drone, there's a program on there. Even stuff like, here we have mass transit called SkyTrain, and there's the thing driving the train is a program, right? So there's programs all over the place. Probably more place you expect. Your microwave probably has programs on. Your oven does. Like all the modern stuff does. Okay, so how to learn? So when we do this, we're going to have, I'm going to show you a bunch of source code. And you could copy and paste it, but I don't recommend it. The thing I would suggest is that you type it out. And the reason you type it out is you want to get, I guess, what you call muscle memory. You want to get in the habit of kind of typing that out, and you want to learn what it's like to type out a program, right? And what I found is that it helps with learning this stuff. It helps with memorization. And if you just kind of like look at it and don't type it out, you'll probably forget it. If you just copy and paste it, you'll probably forget it. But if you type it out, it's a higher chance you're going to remember it. Okay, so one of the secrets to success with programming, actually with learning in general, like either learning to code the first time or learning to become a good software developer, like becoming very, very good at programming. And it's the same secret for both. It's perseverance. So what I mean by perseverance, it's persistence in doing something despite it being difficult or the reward, being delayed, right? And one of the reasons, for example, that software developers get paid so much is that they're willing to spend time in a program to figure it out, right? And for example, like, some of the problems that you might face as a software developer might take hours to solve, or days to solve, or weeks, or months, or even years, right? And I'm not exaggerating, right? For example, if you're a software developer working at, say a new company, and you're creating new technology, it might take months, even more than a year, to create that technology, right? More typical though, like if you're getting tasks, let's say in a more established company, like at the very least, you're going to take hours, like if not maybe days or weeks. So that's normal. That's very, very normal. And what does that mean even for learning? That means that, if you don't get it, figure it out in the first try, don't worry, that's normal. Keep at it. The reason, one of the big reasons software developers get paid so much is they're willing to spend this much time to figure out the problem. That they get very difficult, very hard problems, and they solve it, right? That's the thing. So don't give up. Like if when we go through some of these exercises, you have some trouble, that's okay. That's okay. Just keep at it. Like that you're willing to keep at it, and keep at it until you figure it out. That's what will make you a good software developer. Okay. So another thing to point out, there's different ways that humans, all of us, that we learn things. One way is from learning from other people, and that's a powerful way to do it. Our culture that gets passed down from generation to generation exists because of that. But you can't learn everything from that. Another way to learn is by trying stuff, making mistakes, and learning from those mistakes. For example, say you wanted to learn to play basketball. It's unlikely you could learn to play basketball just by reading a book. What you need to do is you need to get a ball and you need to start dribbling. And at first you're probably not going to be good at it, but eventually, you'll get decent at bouncing around and maybe using both hands and putting between your legs and putting behind your back, and that takes time. And what happens as you do this? Well, you make mistakes. Right? Like at first, you can't dribble. It keeps on bouncing off your knees. You can't hit it twice in a row. Same thing with shooting. And eventually you get better from all those failures you have, all those mistakes you make. And sometimes you could even suffer from some of these mistakes. Like maybe if you're a guy and you bounce it and you try to put between your legs and you don't quite clear the under part, you might suffer a bit from hitting something. But this is normal. This is how you learn. This is a big part of how people and even other animals learn. You learn from failure. You learn from mistakes. You learn from suffering. So don't be afraid to fail. Don't be afraid to make mistakes. Don't be afraid to suffer. This is normal. This is how you learn. Okay, fantastic. So now we're going to get into Go. And with Go, and I'm glad I took some screenshots. With Go, we're going to first look at a function. And what is a function? In this case, this function is an instruction. It's telling the computer to do something. And what we're going to do is look at this function, and this function is going to output stuff. It's going to put stuff on our screen in a sense. And the reason we do something, because it's easier to kind of learn this if you can see something happen, right? Okay, so the first thing we're going to do is we're going to look at the development environment we're going to use for a bit. And this development environment is called the Go Playground. The Go Playground, everyone. And this is, I think, the easiest way to get started. And what it is there's a URL you can go to on the web, and it's http://play.golang.org. So everyone, I'd say you have your computers in front of you, it'd be a good idea for you to go there. Play.golang.org. play.golang.org. So play.golang.org is what we're going to use first as our development environment. Now, it does a lot of things. It doesn't do everything we need. And when we need to do some other stuff, we're going to switch to another one, but we'll cover how to use that too. So this is play.golang.org. By the way, if anyone has any questions, please unmute yourself and ask them. I've auto-muted everyone just to keep background noise down. You can unmute yourself if you're on PC. If you hold down the space bar, you will unmute and we'll be able to hear you. If you're asking questions and I don't act like I'm responding, you're probably still muted. Okay, so play.golang.org. And when you go there, you're going to see some code in there. right? There's already some Go code, which is fantastic. So it lets us kind of get started. And if you go there now, what you'll do is you'll see this code right here. So you see at the top, it says package main, there's imports, FMT. FMT is short for format, I think. I always call it format. And then over here, you see the main, and there's some format dots, PIRNTLN. That's short for print line. And there's some text, hello playground. Okay. So if you're there in your computer, and I encourage everyone to go there, what you want to do is you want to click that run button. And if you can see my screen, there's that red arrow pointing up. That is the run button. So if you click that, and you should all click that if you're there, and if you haven't gone there yet, it's play.golang.org. You go there, the code will already be there, and you click the run. And what will happen after you click that? Well, after you click that, you'll get some output. And the output, it's easy to miss, but I'm going to show you where it is. You can see the red arrow. If you can see the red arrow, the output is there, right? So we have, hello playground. So that's interesting, right? Like we have that code. It's like kind of a very basic, like Go program, and we got some output by clicking the run, right? And remember when I was talking about before, like we have source code. The computers don't understand source code. We have to turn into program. What kind of happens when you click that run is that behind the scenes, this Go playground will turn that source code into a program and then run it. And it makes it so you don't have to deal with all that hassle, which is nice, especially if this is the first time you're doing Go. You can just focus on the Go. Excellent. So let's pay attention to this code a bit more, right? Like the important point, like for now, what I'm going to say is we want to ignore most of this. We basically want to pay attention to that, format.println, the FMT dot, PRINTLN, right? We want to focus on that. And if I scroll here, you can see, here's that format println. And, pay attention to the output. Like, what was in the output? In the output, we had hello, comma, space, playground. Okay, excellent. And if you look at that print line, that's the exact text in there. It's between these quotes, right? But you see the output, hello, comma, playground. And here's that code, right? And, well, what does that mean? That means that this command, format println, it's going to print a line, right? So hello, playground. That's excellent. So what we want to do now is we want to change this code, right? This is a good way to start. Like, so we had the code program in there, we plus the run, something happened. Excellent, something happened. We're a Go programmer now, right? But we want to get better at this. So what we want to do is we want to edit this. We want to change this to something else. And for us, we're going to change format.println, and right now, by default, it has hello, comma, space, playground. We're going to change it to hello world, right? So I usually, like when I write my first program, I always do hello world. So hello, space, world, exclamation mark. And it's the exact same code, it's just that's the only thing changed. And you can see here, that's the change. Now, I'm going to do this. I'm going to do this change, and hopefully you'll do this with me. You'll type this all out, okay? So I got to move the mic away from my mouth because my keyboard is over there. Actually, let me close this, and I'll just move the keyboard over here. This is a little easier. I'll do this. And hopefully you'll tell me if you can't see this, because I can't see what's on the stream or in Zoom. I can only see what's on my things I'm sharing. So I'm going to go.play.golang.org. And hopefully everyone sees that. Let me make that bigger. Let me make that bigger so people can see that. Hopefully that's good enough for everyone. And we have this. Now, if we were to run this, we're going to see output at the bottom. And you see remote. Oh, there we go. Hello, Go Playground. Or hello playground. And now what we're going to do is we're going to change this. So the hello is fine. And what I like to do is I'm going to change this. So I'm going to change this to world. And do this with me. I'm going to change this to world. And then I'm going to click run again. And what do we expect? I want this output to change. That's what I expect. I expect the output to change. So I'm going to click run. And it changed. Fantastic. We've done something. That's excellent. Right? That's a huge start. We now know how to output a single line of text. And whatever I put in here, right? Like I can change this to other stuff. Like for example, like I might change it to apple, banana, cherry. And then I click run. Bang, look at that, right? The text in here, I put the text in here, I ran it, I got it here. Excellent, excellent. Now, of course, this is the Go playground. The output is going here because it's kind of like a website to make things easier for you. If you had this, you were writing typical Go programs as you would do if you're writing typical software, it wouldn't appear like on a web page like this. But this is an environment that we can kind of get started with this to make it easier. So it's fantastic that we have this. So I'll give everyone just maybe a few seconds, like they're trying it out. I'll just kind of pause a bit, and like hopefully like you'll all kind of open up play.golang.org, and you'll type hello world, and you'll click run, and you'll get that. So I'll just wait a few seconds while people do that. If anyone has any questions, please do ask. But I'll just give everyone a few seconds to kind of try that out. Okay. So let's move on a bit. Oops, wrong one. So we've done that. So now we've learned in Go, right? Of course, there's a whole bunch of stuff in that program that we haven't gone over yet, and we'll go over that eventually. We've gone in Go where we know that this format.println, right? That format.println, it does something, right? And if we have this exact program, we change anything in here, right? This thing between the quotes, that'll change what we output. So that's fantastic. Okay. So now, okay, well, what happens if I want to change to something else, right? Well, anything I change there, it'll output it, right? Like, so for example, like, what happens if instead of saying hello worlds, we want to say hello, whatever our name is, right? And, my name is Charles, so I'm going to say hello, Charles. And, what would I expect when I run this? Well, I would expect it to, output hello, Charles, and it does that. So let me just go here. Let me go here to the Go playground, and let me type that, right? So I'm gonna, get rid of that, and I'm gonna type Charles, and I'm gonna type exclamation marks. I like exclamation marks. So I'm gonna click run, and then there we go. Hello, Charles. And that's excellent. It's done what we want. Fantastic. So everyone, please do also try that yourself. Go to the Go playground and get it to say hello, whatever your name is. If your name's Joe, put in Joe. If your name's Robert, put in Robert. If your name's Elizabeth, type in Elizabeth. And please go ahead and do that. Oops. Please go ahead and do that, and I'll give you a few minutes to do that, or not a few minutes, a few seconds. So I'm just waiting while people kind of type that in and give it a try, which is good. Okay, so moving on. So like I was saying, this function, you probably use this a lot, right? This function, formats.println, right? So, I mean, it's not spelled format.println, but like that's how I read it. FMT, I read as format, and then there's a period, a dot, and then, it's println, print, then ln at the end. But I read that as println. So, it prints a line. That's what it does. It prints a line, and we've seen this a bunch of time. So, let's get a little more advanced. So what happens if we add two of these print lines, right? And that's interesting, right? For the people who've never programmed before, we can add multiples of these, right? What's going to happen if we add two of them, right? So I'm going to do that. And I'm just going to copy this text just so I don't misspell anything. But so I'm going to go to the Go playground, and maybe I'll change this back to hello world. And then what I'll do is I'll write another one, formats.println line, and then I need these quotes, right? I got to put these quotes here. That's important. And then I have the text. I'm your friendly neighborhood Golang. And if any of you are older like me, you might have watched a cartoon called Spider-Man, a very old version of Spider-Man when you were a kid, and that was involved in it. So I'm gonna hit run, right? Because I write the code, it doesn't do anything automatically. I gotta click run to make something happen. And when something happens, it's gonna happen at the bottom. In the space here. So I'm going to click run, and there we go. So what do we see here? Okay, we had two format print lines, right? So each of them have 2 different lines. You can see in the output we have 2 lines. That's fantastic, right? There's one line at the top, and the top line says hello world with exclamation mark, and the bottom line, the second line, is I am your friendly neighborhood Golang. And we expect that, right? Because we have 2 print lines. The hello world was first, the I am your friendly neighborhood Golang was second, so we expect them to come in that order, right? And because we put 2 of them, right? Because we put 2 of them, we get 2 outputs. Fantastic. And we can see here in the notes, we have that, right? So that's fantastic. Okay, so what do we think is going to happen if we put 3 of them? What's going to happen if we put 3 of them? So most of you are probably guessing, I'm going to see another line, right? It's going to depend whatever I put in here. If I put that, and I click run, I expect a 3rd line. There we go, 3rd line, right? So however many of these that I add, I'm going to see that, right? So this, like, often when you start learning to program like this, you want to output something first. You want to see something happen, because if you don't output something, you don't know if anything's working or not. So we're approaching this by first learning how to output stuff, right? And later on, like, when you write code, if there's ever a problem with your programs, one way you go about trying to figure it out is you output stuff, right? Like, did it go into the part of the code I wanted? What's in this place I stored something, right? And you would use something like this to see that, right? Okay, so that's great. And we did that, and we put a 3rd line, and we solved that. Okay, so now we're getting to the point where we're going to do an exercise. We're going to do an exercise. And this means that all of you are going to get a chance to code. And what we're going to code is we're going to write a program, and that program is going to have 7 lines of output, right? So when we have this, you can see there's 3 lines of output, right? So you're going to do 7 lines of output. So 7 format print lines. And what's each of those lines going to have? Well, anything you want, right? Anything you want. So please spend some time to do that, and we'll come back, and I'll reconvene. So I'm gonna give you 5 minutes, or maybe I'll give you 5 minutes. I'll give you 5 minutes. I'll also give you a chance to rest if you finish up quick. I'll give you 5 minutes to work on that, and then we'll come back and we'll do the next part. So. So remember, 7 lines. I'll just... And if anyone has questions, do feel free to ask.
How about comments?
Comments? Comments are good too. Oh, do we have comments?
No, I had a comment to make, which was remember that you can hit the share button on there as well, and it gives you a link to the playground that you're working on. So if somebody finished this and wanted to share it with people. Right.
Good point.
Someone just asked on YouTube if you're looking at the YouTube comments.
I will be. I'm just right now looking at the comments here. Although, yeah. Just looking here. I'm gonna look right now. Okay. So I think there's another minute. Okay, so time's up. It's okay if you didn't get that, by the way. But we're gonna like keep on going. Okay, fantastic. So so hopefully everyone was able to make some progress with that. Okay, so we did that. So the next thing, we're also going to focus on format print line. So there's another type of thing that you can do in format print line. The other thing is you can put multiple strings, right? What are strings? These are these things between the quotes, right? So for example, we'll come back to this. Just let me close this, move this over. For example, and I'll just get rid of these ones. When we're here and we run this, we have 1. And what I can also do is I can put 2 things here, right? I can put, how are you doing, right? And what I've put here is like, what we call these texts between the quotes, these are called strings, right? So it's like stuff you would maybe write on a piece of paper, right? Or type out like anywhere. Often it's meant for humans to read, but you can have 2 of these, right? And you separate with a comma, right? And if I was to click run, what would I get? Well, I get hello world's what I got before. And then, there's how are you doing? And if you notice, there's kind of a space here. And I don't have that space, here after the exclamation mark. I don't have it before the how. But because these are separated by a comma, I get that space, right? Okay. So so that's how that works. And we can. Oh, yeah, someone's asking a question. By the way, if you want to ask questions, it's probably easier just to unmute yourself and talk, because it's a little easier to see that. Okay. So that's an important part. And like the reason I showed you this, the reason I showed you that is because later on you're gonna need this, right? But I want you to make you aware that you can put multiple of these. Like I can put as many as I want. Like really, I could put like. Again, I could put apple, banana, cherry, right? And if I put that, what do I expect? I expect that to appear, at the end of that. So if I click the run button, then it's apple, banana, cherry. And fantastic, right? So it does what we expect. I can keep on adding them. And eventually it's going to be too long to see on the screen, but I can keep on adding them. Okay. So that's good. That's good. And what I want you to do now is I want you to write some code, right? And the code is going to output 3 lines. And on the first line, you're going to just have like one of those strings. On the second line, you'll have 2, and your third line you have 3, right? And what by those things, I mean like this line has 3, right? So if I wanted, one with 2. I would have, 2 or something like that, right? So make a program with 3 of these format print lines, right? There's 3 of them. There's 3 of them. And the first one you want 1 string. The second one you want 2. Third one you want 3. And remember to put a comma between those strings. right? And once you're done, click run and make sure it works. You always want to run it to make sure it works. And I'm going to give you 5 minutes to do that. And I'm going to look to see if anyone commented on YouTube while I do that.
One comment here, when you give time for us to work on an exercise, it may be helpful to leave it on a screen that has a clear explanation of what the exercise is.
Okay, good point, thank you. Is that legible? So we're doing this one. Hopefully that's legible. Yeah, thank you, Drew. Thank you for whoever left that comment. Oops. And just for the hint, remember that you're going to have 3 print lines, and the first one's going to have 1 string, the second one's 2 string, third one's 3 strings. And a string is these things with quotes, double quotes. And when you have more than one, you need to separate them with commas. And after you write your code, you want to click run. If you see a bunch of red stuff here, there's an error, and that's normal. That's very normal. Like software developers get errors all the time. If you have an error, try to fix it. If you can't, unmute yourself and ask. It's normal to have trouble with this. So another couple of minutes.
Oh, there's a comment in Zoom from Praneeth asking, "Hey Charles, it would be nice if you give some intro about Golang and why choose it and market for it."
Okay, sure. Yeah, so like I mentioned before, I've been programming for 25 years or more probably. And if you count every language I've ever programmed in, it's probably something like 40 or 50. If you count languages I program more than, say, a year for each, it's probably more like 12. Go is my current favorite language. Go's my current favorite language. And I think like there's different reasons I kind of like it, but I think part of it is, you know, when I was starting off programming, and you know, my preferences kind of got set by what I was exposed to when I was first starting this. I was a C programmer, and to me, Go feels like a modern C. Go feels like a modern C, and that's part of what attracted me to it, at least initially. Another part of it is that Go's compiler is quite fast. This is actually some history you're probably not aware of, but you know, back, let's say in the late 90s, early 2000s, you know, there's a lot of people doing stuff like C++, maybe Fortran also, and you know, some of these programs that people wrote, you know, the source code, were huge, right? And it could take sometimes like 45 minutes to compile your program. So you wrote the source code, you wanted to run it, you wanted to see if it worked or not, and it took you 45 minutes, right? Like if, for those that maybe are familiar with C, like if you edit a header file, for example, that's insane, right? Like as a software developer, you need to be able to make changes, try to run it, see if it worked or not, then make changes to correct that. And if you can't do that kind of rapid back and forth where you know, change it, try it, change it, try it, change it, try until you figure it out, it's like, it's extremely frustrating. It's impractical. And around that time, people kind of switched over to what are called interpreted languages. So these are programming languages where you do not compile it, you do not like create a program out of it, and you have another special program kind of like read the source code and run it. Now, they're a lot slower. As compared to like something like Go or C or C++ or something, because you know, something's reading the source code and kind of like, you know, doing, you know, executing the program. Actually, there's no program, executing the source code. But you didn't have to wait 45 minutes to compile it. And there's certain languages like that got popular. One of the big ones like that had a big impact on creating the internet was PHP. But other ones, like there's JavaScript, there's Ruby, there's Python, there was Tickle before, but I think the person behind it kind of like stepped back from that. But there was these languages that you know, kind of like took over a lot of stuff, and it was a lot of it had to do with that, you know, like running the program, like making a change and running it just could take forever, right? And if you go back, like I think like 7 or 8 years, you know, I was doing interpreted programming languages like a lot of people were, and then I tried Go. And like the reason I tried Go is because the language I was using at the time, one of the libraries it had, and the library is kind of like a tool you kind of bring in, like kind of like format, like we have this print statement kind of format. It was something like that, except it let me do other stuff. It had a bug, and what I mean by bug? Something didn't work. And when I needed to solve this problem, so I was like, okay, let me try something else. Let me try using another language. And I picked Go, and I was able to solve the problem using Go. But I noticed some things. Like first, Go was way faster than the interpreted language, and that's expected, right? The other thing was that taking the source code and creating a creating a program out of it was lightning fast. It was as fast as interpreting, you know, the interpreted language. And like at that point, it's like, okay, I don't have to wait 45 minutes for this thing to run, right? To compile, to build the program. I can just like make the change and do it. Like this is as fast as you know, using an interpreted program. Like there's no point in using an interpreted program, right? Because like I don't have that wait anymore. So I switched, right? And the thing is, like it doesn't have to be this way, but with a lot of interpreted programs, they do things in a certain way, right? For example, like they don't have kind of like types in this. They do have types, but they don't have in the way that a compiled program will have. Like we've talked about strings, we haven't gotten to types yet. So this is more for the people who program another language. They don't have types yet. You know, you get a little safety if you have types. Also, like I found, like if you compare Go to say, and again, this is for people who program, if you compare it to like C++ or Java or C#, a lot of those languages, they kind of have a class hierarchy you have to build. It's a way you kind of model your problem. Like for example, like, you know, let's say I'm working with people, or maybe I have a veterinarian service or a zoo, and there's animals, and I need to like represent the dog in my software somehow. And there's a way you would do that in C++, in Java and C# with this class hierarchy, and you might also use what are called interfaces. And I don't like modeling stuff that way. Go does something, it almost does something. It does something that's almost what's called duck typing. And what duck typing basically means, if something, like the saying, if it looks like a duck and it quacks like a duck, it's a duck. I don't have to tell people it's a duck, right? Where in like say C++ and Java and C#, I have to, like, the person that kind of like modeled the duck, they have to like tell everyone this is a duck, right? It's not enough that you can quack and it has feathers and it, it looks like it and everything else. You have to say, no, it is a duck. In Go, if it looks like it, it just is that thing. And I found I like that better. I prefer that, way of kind of modeling, the worlds when I write software a lot better. Not everyone's going to like it necessarily, but like just given my experience, like I tend to like it a lot. People often talk about what they call, Go's kind of concurrency stuff, which is actually really cool. But like I found the kind of like near duck typing. I actually wish it was full duck typing, or what in Go they would call interface kind of oriented programming. Maybe I love that, right? And if I was to ever to switch something else, I would demand it has it. It also has some other cool things, like it has this defer construct. That's pretty cool, and some other stuff. Its library that comes with it's okay. It kind of shows its age, because I think they kind of built it at different times. There's a bunch of inconsistencies. There's things that maybe aren't the ideal way of doing it, but like it feels like batteries are included for the most part, right? Like some of the stuff you'd kind of hope someone else would do, you do. But although like I've been doing this for a while, so I tend to like my own. I tend to prefer to write my own libraries from scratch, but like that's not for everyone. I mean, I've been doing this for like 25 years or longer. So yeah, I mean, like I think Go is a modern C, and I like C a lot, and I like the way you model stuff with kind of like duck typing-ish type thing. It's compiled. You have some types. There's some stuff I would have liked. You can kind of go further with types in different ways, but you can actually make that stuff. Like for people who program before, if you've ever heard of like option types and things like that, you can actually build those in Go. But you have to build it. But I built it, so I think it's okay. So that's kind of like the background for Go. But anyways, let's get back to the lesson. Okay. So before, like when we were talking about this, we were kind of pointing out, there was some, we had the program, right? Like if we go to the program here. Like we were focused on this stuff, and we kind of ignored all this top stuff and the bottom stuff. And, we just ignored that, right? We kind of said, okay, well, a Go program kind of starts with all this, package main, imports, format, func main, and then there's a curly brace at the end. And then, we just like basically we put our stuff here. And that's the way, like, at least for now, you can think of like how these Go programs work. You put your stuff in here, right? Whatever your code is. And, if you want to put, for example, like I was here, it's going to output that. If you want to put, like this kind of message, you can do that too. And, right now we've kind of just done format print line, right? That's the only thing we've done. We're going to get into other stuff. We've done strings, right? And the strings are these things you put a quote in. And by the way, if you miss the quotes, it won't work. Like it'll just complain of an error. Like that's an easy kind of mistake to make. But we've done this, right? And this is kind of like the way we think program. Now, eventually, we're going to get into like other stuff we can do there. But for now, we're not going to do that. Any questions? And please, like it's much easier if you just ask the question if you have a question. Just unmute yourself and ask it. But if anyone has any questions. Okay. So far what we've done is we've got into strings, right? And what we're going to get into is numbers, right? And really, like, we were going to be like precise. We're going to be precise about what type of numbers we're getting into. We're getting into integers, right? And in the case, at least with this, when we talk about integers, it's whole numbers, right? Like, you might like how many apples do you have? Well, I might have 1, 2, 3, 4, 5. Might have 0. Integers also, they can include negative numbers, so like -1, -2, -3. Like maybe you're doing accounting. It's like, well, how much money do you have in your accounts? I have 5. Okay, $5, right? Or maybe let's do cents because that's easier. 5 cents. And then, well, what if it happens? It's -5. Well, you owe us 5 cents. You spent too much, right? So so it's numbers like that, and you can see there's different kind of numbers. -1, 2, 3, 4 is a number. 742 is a number. Et cetera, et cetera. There's a whole bunch of numbers. So let's look at this. So what we're going to do now is we're going to take a look at what happens if we do format print line, but we have a number. right? Now format print line can take a whole bunch of stuff. So we're just going to type some of this, right? So I'm going to, oops, I gotta close this for a sec and move my keyboard. I've got like my laptop on my lap, but I also got this keyboard that controls the computer I'm streaming on, so it's a little awkward for me, but so bear with me. So we're gonna delete this, and you know I can put like 101, right? What happens if I run that? Oh, I get 101 down here. I hope that you guys can see that 101. And what happens if I put? You know, I can put other stuff. Negative, I don't know, 42. I run that. Great. Negative. I see the 101 and negative 42. And you know, I can put other stuff too. And the thing is, like, I can even like put multiple on the same line. Like we're doing another thing. I can put 1, 2, 3, 4, 5, 6, 7, and then I hit run, and there you go. And it's space separate, just like we saw with the other stuff. So that's fantastic. Oops, sorry. So yeah, so we have numbers, right? And that's fantastic, right? Because like a lot of times when you're programming, like sometimes you want strings, right? Like say you make a program, like if you ever use a program and asks you, for example, like, what's your name? And you fill in your name, that's a string, right? If it asks you what's your age, that'll probably be a number, right? Like what year were you born in, right? It's like, you might say, whatever it is, like 1991, 1984, 1972, 1924, whatever, depending on how old you are. So like there are times when you deal with numbers, right? And like technically, like here's a little thing I'll kind of show you. Technically, like what happens if I would write this? Like I would treat it like a string, right? I would do that, right? It would look the same, right? Like when you print it, it doesn't set a difference. But the thing is, like these things, as we'll see in a bit, when it's an actual number and not a string, numbers have a certain kind of power, right? They can do with them. Like if you've been through high school, you've probably seen you can add numbers, you can subtract numbers, you can multiply, you can divide, you can check is one number bigger than the other, et cetera, et cetera. So you can do all that with this type of stuff, right? So we'll get to that soon. So yeah, so in Go you have like a bunch of different operators. So addition is one of them, right? Like 3 plus 2, right? So if I came here, and let me just let me get rid of that. If I type, and the reason we're putting it in print, right, is because we need to see output, right? We put print so it can show us here. We want to see the result. So we put 3 plus 2. We run that. We get 5, which is what we expect. 3 plus 2 equals 5, right? And then, okay, so that's one operation. What's another one we expect? A subtraction, right? So if we come here and we type minus, right, what do we expect? 1, right? Because 3 minus 2 is 1. Now, of course, like remember we were talking about strings. Like, what happens if I put strings here, right? Like, error, right? We get an error because like minus doesn't work on strings, even though like the output would be the same. Like if I just put, like for example, I put 3 by itself. Like I'll put 2 of them. You can kind of see this. Even though like it looks the same when you output, it's a different thing, right? You can see there's 3, they look exactly the same. So with numbers, we typically, like a lot of the times, we'd want to store it, just as numbers rather than strings. So that's an important difference. Like a string with a numerical digit in it might look like a number, but it's not. It's text. The computer doesn't understand. Okay, what else do we have? We have multiplication, right? So if we come here and like a lot of times, like you might have like seen the X like kind of in school. Like that's not what a lot of programming languages use because most people don't have the multiplication symbol on their computer. So what we do is we use the star, right? And the star is on probably if you have a laptop or a keyboard like mine, if you press shift and then the number 8, you'll get the star. So if we run that, then we get 6. We get 6, right? And you can see 6 down here. So that's awesome. What else do we have? We have division, right? So let me put division. So division, like we don't have that kind of obelisk, the division symbol that a lot of people used to, where it's a horizontal line, a dot above and below. We use the slash. Right, we use a slash, and you've probably seen this in URLs if you ever type one out. So we run that, right? What would we expect 3 divided by 2 to be? So it kind of depends, right? Like if you've kind of done like say real numbers, right? You might say 1.5, but 1.5 is not an integer, right? If you did long division, if you remember that, right? Like 3 divided by 2 is 1 remainder 1, right? And in this case, the 3 divided by 2 gives you like that divisor. Actually, let me change it. Let me make it a little easier to see. So let's say it was 5, right? So 2 goes into 5, 2 times remainder 1, right? So we see the 2. So how do we get that remainder? Okay, so Go has a special operator to get that. So if we did it again, we have that. What you do is you put a percent sign, and it's weird. It's really weird to use percent because we think percent means something. I think the reason people picked it is that if you look at percent, it has a slash, kind of like this slash, right? So it's kind of like familiar. But if you do that, it'll give you the remainder. So if you divide 2 into 5, you'll get 2 remainder 1. So let's run that. Look at that. 2 remainder 1. Fantastic, fantastic. Okay, so we've done all that. Okay, great. So any questions, anyone? And I'll just check YouTube. Okay, so there's a question from Henry Chan. Curious what companies in Vancouver are using Go. Off the top of my head, okay, so Hootsuite is probably a well-known one here that's using Go. And Plenty of Fish, the dating sites, I think they have some Go there. Coho was in Vancouver, but it got the people who purchased it moved the company to Toronto. Spark is using Go. Community Fit's using Go. What else? The Segment, I think Segment's using Go. I think there's I mean, like, it's a newer language, so like you're not going to have as many companies using Go compared to say like Java, for example. But it's a language that's growing very rapidly. You know what happens usually, like how companies get a language? What happens is that there's usually like a first software developer, right? And that person could have different titles. Maybe they're a senior software developer that joined. It could be the CTO or something like that. And whoever that first person is, they decide what that language is going to be. So it's whatever they like, right? And if you're the type of person who likes Go, that company's probably going to be using Go, right? So there's a whole bunch of companies that I helped create that now use Go as a result. Yeah,
there were some other comments as well about other companies that are using it, like Salesforce, Demonware, Axiom Zen.
Yeah, those are good. Those are good examples. I didn't think of those.
Mozilla as well. SUSE has some offices here.
Yeah. There's quite a few. I mean, if you learn Go, I think if you're thinking about job prospects, you'll have job prospects for this. Yeah, I mean, like it's like I said, it's my preferred language now, and I can program in other languages, like and I mean, like, probably one I program in also, just because it's kind of more front end. Like Go is often like back end in its infrastructure. Is JavaScript. I program in that quite a bit. But one thing you can actually do is you can use Go for front end stuff too, using a technology called WASM, WebAssembly, which is pretty cool. So yeah, there's quite a bunch of places. Let me just check some of the other comments. Sorry, I'm just trying to. Okay, it doesn't want to pop up. Oh, sorry, I didn't want to do that. Yeah, so some Perry mentions for modern backend web services or system scripts, it's gaining a lot of popularity. Open source projects like Kubernetes, Prometheus, and Go. Yeah, I mean, there are MasterCard too. Let's see what else. Sorry, I have like kind of an awkward setup, and one thing you guys probably don't know, I smashed my elbow yesterday, and it's actually quite painful for me to use my left hand the way I'm trying to use it. Yeah, okay. Yeah, I mean, like I said, it's often a result of like whoever was there, whoever was first. Like, for example, the company. I mean, if you don't count the current companies I'm involved with, like the current company I built, or sorry, the previous company I built, Coho. it was actually quite interesting. Like we built like a neobank, right? Like, those modern online, banks. It was Canada's first modern mobile online no fees bank. It was, for me, it was interesting because like I've never built a bank before. So in the beginning I had no idea how to do it. I had to figure out everything. But Coho ended up being in Go. Like why? Because like I was the original engineer there, right? The original software developer there. And I like Go, so I picked Go, and it got programmed in Go. And like I don't know how old it is now. Like what is it? 7 years old or something like that. Maybe longer. It's now in Go, right? And that's the case for a lot of companies. Like there was another one. It wasn't just me. Like it actually started as PHP, but ended up switching to Go. This one company called Trulioo. It's more in kind of like the credit bureau space, identity space. But it's Go because like we started using Go, right? And that's the case with a lot of these companies. Okay, cool. Again, like any questions, please just unmute yourself and ask. Okay, so we've done some integer stuff, right? That's great. And like when we printed this, let me just close this one. When we printed this, I kind of did it like this, right? And I'll just put more. Like we'll kind of include all of them. We'll put 5 plus 2. Oops, 2. 5 minus 2. 5 times 2. Oops. Shift 8. And if I run that, okay, so you see at the bottom, like, 5 plus 2 is 7, of course. 5 minus 2 is 3. 5 times 2 is 10. 5 divided by 2 is 2, remainder 1, which is the next line. And, like, if I just look at the output, it's kind of hard to read, right? Like, it's hard to read. Like which one is plus, which one's minus? I kind of have to look at the source code. So one thing that we can do, and this is why I showed you this before, we can combine stuff, right? Like I can put a string here. For example, I could say, 5 plus 2. I'm going to do it like this. Gives me that. So what happens if I change that and run it? Look at that. So 5 plus 2 gives me 7. And actually, I guess I don't need space at the end. One thing I'll do, like maybe I can do it like this. I didn't want it to be confusing, but if I could put like this, 5 plus 2 equals 5 plus 2. It kind of looks weird, but when you run it, like this code over here will evaluate. So Go will like calculate 5 plus 2, and like you see it's 7, right? 7. And then this is a string, right? So like Go doesn't understand what's in here. It doesn't understand that you ran 5 plus 2 equals, right? And if I was to write a program like this to make my output easier, I would actually include all this, right? Like I would write, stuff like I could write 5 minus, 2 equals, then I hit enter, and then you see it. Or I can do it like this. I can just write it out like I did before. 5 times 2 equals, right? And I could even get more fancy, right? Like if I leave, let's say I leave those 2 there and I put another line. I put something like, 5 divided by 2 equals, and then I put 5 divided by 2, and then I put remainder 5. So this remainder thing, the name we give to this is mod. So they don't usually write 5 remainder 2. You can call it that, but they also say 5 mod 2. So if I run that, right? I don't know if you can see that at the bottom. 5 divided by 2 equals 2 remainder 1, right? So that's pretty sophisticated. What I do, I had a string, right, and it outputted that. Then I had a calculation, right, the results of a calculation. And then I had another string, and that results in another calculation. So I can mix and match these, right? And that's pretty powerful. So that is fantastic. So that's awesome. Okay, so we're going to do another exercise, right? What I'd like you to do is like you to write a program, and it's going to do a calculation. And it's going to do this calculation. It's going to add, 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21. So you're going to write a program that's going to output that, right? And I'll give you 5 minutes for that, and just so please everyone go ahead and just work on that. And I think after we do this exercise, we'll take a little break and we'll give everyone a chance to stretch. But I'll give you 5 minutes for that. Again, if anyone has any questions, please unmute yourself and ask.
Hi Charles, this is Pranit here.
Hi.
How are you doing?
Hi, I can hear you.
Yeah, can you hear me?
Yeah, I can hear you. Do you have a question?
Yes, yes, Charles. So I'm from PHP and JavaScript background. So I want to learn the Go. So what is the next step for me to after this basic coding? So do I need to learn any web framework like in PHP we have Laravel or YAE? Is there any web framework or and basically I've seen so many openings regarding the Go. They're asking about more microservices and Docker experience and combination of Go. So can you please guide us at what is the best way to build stack around Go? What is the best approach?
Yeah, so Go takes a bit of a different approach. Like if you really wanted an equivalent to Laravel, right, there are stuff like that, but it's not necessary to do that in Go. So one thing that Go has is it has a built-in package, right? So for example, like the same way we're using format, FMT, and exposes the print line function. Go also has another package, like it would be, net/HTTP, right? And in that HTTP package gives you the tools you need to create, like for example, if you were creating web-based APIs, which is, the fashionable thing to do nowadays. So you would basically do it in there. Go also has a package for doing JSON, right? So for example, like maybe you wanted to, for example, you were dumping some data from the database in JSON format, or you were like receiving an HTTP post or put or patch or whatever, and you were updating the database. Well, there's ways of both receiving and sending back JSON. So usually you would probably just use the built-in stuff. You wouldn't use Laravel per se, but you would use this stuff. So at the end, I can show some of this. I can show how to do some of this. And I think like, once we get to the end and once we get to the point where I start introducing Go maps and Go structs, that might be a good way to kind of see this. So do remind me at that point, and we'll kind of go over that.
There's another question we're getting on a comment on YouTube from Nestor, which is a question for Charles. What about numbers with decimal points?
Yeah. So Go does have that. It does have numbers with decimal points. They call them floats. Now, you have to be very careful working with floats. For example, they're not what you probably are used to in, when you were in high school and you learned like the decimal points. They actually make mistakes when they add, they subtract, they multiply, they divide. Like you don't get the answer you expect. And one of the problems is sometimes, when people are working with money and they might say, I want to store $1.50, right? Or $1.10 or $1.20 or whatever it is, right? And they think, oh, I'll just use a float, right? And they'll do some calculation and they might add two numbers and they expect the answer to be 1, and it's not, right? It's not the answer they expect. Usually, like if you're doing, unless you're doing, say, machine learning or you're doing physics simulations or something like that, you should probably stay away from floats. And I think it's bad because I don't think most people realize how dangerous floats are for many applications. So yes, Go has it, but you need to be very, very careful about why you're using it, because it is inexact math, right? Like, for example, like this isn't actually the way the error you see, but it's an example might be like 7 plus 3 is not 10. It's like 10.001 or maybe 9.999 or something. Like it's actually 7 plus 3 will work. But there's combinations of numbers you can add, and it won't give you the right value. And for example, if you're dealing with money, if you don't get the right value, people will be pissed. They'll be really pissed, and your company will probably might go bust. So yes, it does have it, but it doesn't have good things built in for, like, if you want exact math, like with money or something else. Maybe like, it really matters. You need to get the exact value put in for maybe measuring oil in a tanker or something like that. You can create them. It's a little more involved to create them yourself, or you can do other techniques. Like often when I store money, I don't store dollars, I store cents, right? So if you're using, like, I'm in Canada, so the Canadian money system, which is a lot. So, like, 100 cents equals $1, right? But I store everything as cents as an int, and then that way I always have exact math. So I have kind of workarounds, and I wish like all the people who make languages, they had an exact math decimal point stuff, and they dealt with the stuff for you. Go doesn't, and almost no language does. You usually have to construct this yourself, and I think a lot of people just use floats by accident, and they get themselves in trouble. So yes, it does, but you shouldn't use floats. Yeah, you were thinking of banking. Yeah. I mean, like, for example, like the bank I created, like, we did not use floats. Like, we definitely did not use floats. I basically stored everything as cents. But yeah, I mean, like, if you're an experienced programmer, you could construct this kind of stuff yourself. But if not, just store everything as an int. Cool. So I'm gonna, we've been at this now for an hour and a half. I'm gonna give us a 10-minute break, and then we're gonna come back. So I'm just gonna set my alarm. So right now on my time it's 1:32. So I'll just set it for 1:42, and we'll come back. So I am gonna step away from the computer just for a bit, but I'll be back. Actually, I think I saw a question. Let me check the questions before I go. So I mean, this is going to be the chance if anyone needs to go to the washroom or wants to grab something to eat. Let's see. One main difference is that Go is compiled with the used packages, including the backend. Yeah. So Go does it does bring in the packages. There's also a Go runtime. I mean, just like C has, but there's a runtime that kind of gets included. There's the package you bring in. Go's pretty picky about, like, if you try to bring in a package that you don't use, it'll tell you, and it'll tell you to remove it. Let's see. Okay, so we'll take a break for 10 minutes and come back. So I'm just gonna step away from the microphone for a bit, so I won't hear you if you say anything, but I'll be back. Okay, so we'll just get started in just a bit. Hopefully everyone had a chance to grab a snack or go to the washroom if they needed to. Okay, so we'll just get started now. So let me close this. You guys can't see what I'm closing. I have a laptop on my lap, and then now I put a keyboard on top of the laptop. Like, it's actually quite awkward what I have here. Since the COVID stuff happened, I ended up setting up a streaming station / office in my my apartment. And I have like a coffee table in front of me, and on that there's quite a large screen that I'm looking at. To my left is a micro four thirds camera with an amp onto it, and that kind of runs into this other device that lets me switch between video feeds and stuff. And that runs in a computer behind me. But like, there's like lights around me. There's a microphone stand. There's cameras. There's light. There's screens. It's quite involved. But you compose the shot so you don't see all that. Yeah, I mean, there's like the colored lights are coming from somewhere. There's a light up here. There's a light over here, and they kind of like shine on that. Okay, excellent. So let's continue. So one of the things we want to continue with is like when we looked at the program, right? Like when we looked at these programs. Now, I'm just going to like remove most of this to make it less messy, just so we can focus on the stuff we want to focus on, right? Before when we were talking about this, we always talk about like we pay attention to this, right? We kind of ignored the rest. We ignored all the rest of the stuff. Now what we're going to do is we're going to pay attention to this stuff. And in our case, we're going to pay attention to this part up here, the imports. And one thing you might have noticed is that this FMT matches that. That's interesting, right? So what would happen if we, for example, we got rid of that, right? Let's just delete this whole thing. How do we get rid of that? Ooh, error, right? Error. So this right here, this says the error's on line 4. You can see, like, if you can see the 4, it's highlighted in red. On line 4, there's an error. And what is it? Undefined format, FMT. It doesn't understand what this is. It doesn't know what this is. This import we had before, that brings that in, right? And that's interesting. That's interesting. And what does that mean? Well, one of the meanings of it is that there are other things we can bring in, other things that do things other than print a line, right? And that's pretty cool. Okay. So, right. So that format, that's the important thing. So let's look at something else we can bring in, right? Let's look at something else we can bring in. What happens if we bring in math, right? And by the way, like I've been talking about all this stuff, right? Like what is formats? Like how can I find out more about that? So here's a trick I do. What I do is, I go to a search engine, and we'll go to Google. And if I type in Golang, actually you can see that. Let me make that bigger. If I type in Golang and then I type, for example, FMT, look what shows up. Okay, there's this. I click it. I go here. And let me make that bigger so everyone can read it. So this is the documentation for formats, right? This is the documentation format. And if you're programming, if you're writing code, like you're going to spend a lot of time looking at documentation. This is how you figure out like what this stuff does, right? And it takes a little bit of getting used to. But let me just search for example, print line. Okay. Well, there's actually a few things to print line, but this is actually what we want. It's print line. If you look carefully here, it has F print line, and this has S print line. They do things are a bit different, but this is what we want. So I'm going to click on this, and I get taken here, right? And it says print line and print line formats using the default formats for its operand. Oh, it's really complex. Spaces, blah blah blah. But there's documentation here you could read, right? And it even has an example, which is awesome. And we open up the, oops, just move a bit, the example, and oh, it's got some code, which is cool. And I got a run button that I can click, and I click the run button, and it works, right? And it kind of works like the Go playground, right? Like some of these things have examples. And you see with it, it had like name, right? So we haven't seen these yet. These are constants in this case, but name, and then it has string, which we're used to, and then age, and we haven't seen that yet. And then a string, and then it just outputted it, right? And we also haven't seen these. That's pretty cool. So let's for example, let's look at math, right? So we're gonna go to search engine. We're gonna search Golang math. And then we get this result, and you can see like the Go programming language, and here's some documentation. So like you can see, like I brought in the math, and like if we just run this right now, like it'll give us an error. Like it says imported not used math. So we brought in math, we didn't use it. And Go will complain about that. If you want to bring in something, you got to use, or else you got to remove it. So we'll go to math, and let's find something. Let's find, for example, square root. So here's a function, square root, and it takes a number and returns number. If you've ever, like, if you remember this from high school, like the square root of 4 is 2, right? Like square root means like what number multiplied to itself equals this number, right? So if I ask for the square root of 9, what number multiplied to itself equals 9? Well, 3, because 3 times 3 equals 9, right? So let's use that, right? So we're going to use square root, SQRT. It doesn't spell it out as square root, it shortens it, SQRT. So we're going to go to the Go playground, and we're going to say, just do it here, print line, and we'll type math, right? Because that's the package. Now, just a word of caution, there are times when what's written in here does not equal the package name. People often try to make them match in some way, like either completely or, somewhat. But just careful, like what's here and what's here don't always match. But in this case, they do. Which just makes it easier. So math dot, because we have that math import, and then it was SQRT for square root, and then let's put 9, right? And let's remove this top one. Like we don't need that there. We're just going to look at this. So what do we expect? Well, 3 times 3 equals 9. So we expect this to output 3, right? So let's run that. There we go. And you can see the 3, right? And for example, like, I also know like the square root of 25 is 5, right? Because 5 times 5 is equals 25. If I run that, I get 5. Excellent. So what have we done here? What have we done? Well, one, we kind of like started to understand what this is, right? Like before we were ignoring everything but that. This is the only thing we were paying attention to. Now we started paying attention to import, right? And what does import do? Well, it brings in stuff. It brings in these kind of tools we can use, right? Like before when I was talking about, someone asked a question about, what frameworks you would use to do web type stuff, like, HTTP and JSON, all that. And I mentioned there was some stuff you can bring in, right? Like we call these packages, by the way. But there was some stuff you could bring into this. You would bring them in through like an import statement like this, right? And for us, we already had format, FMT, and that brings in print line, but we also saw when we go here, right? Like there's a lot of stuff in print line, in format, right? Like look at all this. Look at all these functions. They do stuff, and there's even some types. We haven't gotten to types yet, but there's some types, right? There's all these functions that do all these wonderful things we might use. We might use some of them, we might not, right? It kind of depends. But what does this mean? This means that other software developers went and wrote code for us that we could use to make our life easier, right? And sometimes we create our own things like this. These are called packages, right? Sometimes we create our own packages, maybe for ourselves, maybe for others. For example, like I've been programming for a long time, and even in Go, like I think programming in Go for like 7 or 8 years, and like I've created my own packages. I created my own kind of like functions and types and other stuff for myself. And like it saves me time sometimes. Like maybe there's something kind of like it's not like anything specific to what I'm building. Like maybe I'm building a bank, or I'm building a video application, or I'm building a game. It's nothing that really like it's the secret sauce for the game. It's just like a generic thing that programmers would use. For example, like printing line, right? And I might create a package out of that. For myself personally, I tend to put this on my GitHub account. So if you go, for example, to github.com/reaver, and you look at the repositories, like I've got tons of Go packages. And the reason is because, I noticed there was a problem. There wasn't a package for it, or maybe the package that existed in the Go library I didn't like. So I wrote my own. But I don't have to write it over and over again, just like we don't have to, write the code for print line over and over again, right? There's a print line here, we just use it. Write it once, use it over and over again. And you'll probably find as you do this, there might be some problems you encounter for which either there isn't an existing package for it or there isn't one that you like, and you end up writing your own. And you might want to use that, in the future as you do more and more programs, right? So anyways, we've seen that. And, going back to our code, right? Like we have also the math thing. So there's the other packages, not just format, right? We can bring in other things. And we took a look at math and we saw, for example, there's lots of stuff in math too, right? There's all sorts of stuff, right? So some of this you might recognize, there's hyperbolic trig functions, there's actual trig functions, there's, exponentiation. Before we were talking about floating point numbers and decimal numbers, this math package uses floating points. So this is the kind of dangerous numbers, right? Like don't use these unless you really know what you're doing. Right? For example, you might use these if you're maybe implementing some machine learning code. So like, some call it AI. Or if you're doing a physics simulation or something like that, you would not use these for money. Never use these for money. It'll cause huge problems. Never use this for money. You would model like just normal decimal points some other way. But anyways, we wanted to use one thing in here, right? We wanted to use the square root one, right? So, we found there's a square root, we clicked it, we went to the docs, et cetera, et cetera. And then we used that in our code and we used it inside here, right? And that's fantastic, right? So there's all these different things. And, if you go to the Go website, so Go's website is golang.org. And if you did it in a way where you didn't change the screen radically, hang on a sec. Let me just... there we go. So if you go to the Go website, there's a place you'll see packages, and if you want to go to the URL directly, it's golang.org/pkg. If you go to that, you'll see a whole bunch of different packages that are built into Go. They're built into Go, right? So these are like, batteries are included, right? You start programming this, you have all sorts of tools at your disposal. So there's tons of stuff, this is for certain storage file formats and compression. There's all sorts of like more kind of low-level programming stuff, encryption, cryptography, right? Not cryptos and cryptocurrency, but cryptos and cryptography. Database-related stuff for debugging, stuff for different formats like JSON and XML, CSV, et cetera, like just helpful stuff. Et cetera, stuff for HTML, images. So there's all sorts of stuff in here, right? And, as you learn Go, as you program more in Go, you'll probably get more familiar with more and more of these. And you might even like spend some time exploring this, right? Like maybe there's some useful, interesting, cool stuff in here that would make your life a lot easier. But for now, know this exists, right? So like what's the lesson, right? Like lesson one is that, okay, we're not just paying attention to this anymore. We're kind of figuring out what's going on here, what's going on with the imports, right? And before, we were always just importing FMT formats, right? And what did that do? Well, it brought in this print line, right? So we can print a line, right? We can output a line to the screen. And what we found is that, okay, there was docs for formats, and we go there, right? There's tons of stuff there. It's not just print line. There's tons and tons of stuff. And that's cool. And okay, we brought in formats, but we can also bring in other stuff like math, right? And we use math, right? We use that here, and we use the square root function. But like we looked at the docs, right? And that's great to look at the docs. There's tons of stuff here, right? There's a whole bunch of different things, right? So there's all these tools at our disposal that we could use to compose together and to add our own code to make, do whatever we want to do. And that's great. Okay, excellent. Okay, so I find, like doing stuff that's a bit visual is helpful. So what we're going to do is we're going to do a bit of drawing. And we're going to write some code to do the drawing. Now, just a word of warning. The Go playground acts weird sometimes. Sometimes when I run these program, it gives an error. Sometimes it works perfectly fine. I really hope it works perfectly fine. But so we'll see what happens, right? The Go playground's a bit finicky sometimes. So, like I said before, we're now used to using format, right? So we're going to use something else. We're going to use actually a package I wrote. And, the thing is, when you use kind of like these Go built-in ones, they get like really pretty names, right? It's really simple. Hey, math, format, right? When you want to bring in a package from somewhere else, often what you put here looks like a URL, right? And it really, really is a URL in a sense, right? And for us, what we're going to bring in is this, right? I'm gonna just copy and paste it there. So let me just get rid of math really quick because we don't use it. We're going to get rid of math, right? We're going to get rid of math. And I mean, we could leave math there, but I just don't want to confuse it because I don't want to have a whole bunch of stuff we're not going to use. And what I'm going to add is this, right? And well, what is this, right? Well, I wrote some code. And I put it on my GitHub. And what's GitHub? GitHub is kind of like a social, sort of a social network for programmers, right? And one thing you can do is you can create code and you can put it there, right? And if the code's sitting there, and it can really be sitting in any site that kind of exposes the code in a certain way. But if you put it there, then you can bring it into your program, just like this, right? And if we took that URL, right, and I just went to the web browser and typed that in, it's like, okay, well, I'll make it bigger. This is a GitHub page, and here's the code. There's a bunch of code here, right? And here's some docs. And even for this thing, it has its own doc, so I can click this, and let me make that bigger. So this is a package I wrote to do some drawing. Now, this package for drawing, it's very, it kind of it has things built in to work with the Go Playground. There are things you wouldn't need to do if you weren't using the Go Playground, but we are, so we will. So let's do something simple. Let's do something really, really simple. So we've been doing format print line. What I'm going to do is I'm going to remove that. We're not going to do format print. We're not going to do format anymore. We're just going to use this. And what I did is I call this package C80, right? So remember when I said with a lot of these packages, what appears here. Oh, sorry, it should be just like that. Sorry, no quotes there, no quotes. I said what's here is here. Well, I mean, you can actually make this anything you want, but people try to make it match because this has to be URL. I couldn't just name it this. I wish I could. I couldn't just name it this because I had to say where it was. And the convention most people do is they have the URL, and then when you get to last slash, you put go hyphen, right? Go hyphen, and then this part is what the package name is. Now this is convention. You don't have to do this. Some people won't do this. I choose to do it. Okay, so you have go C80, and what I want to do is draw. I want to draw. Okay, and this is kind of like the magic of the C80 package. You draw something. You draw something, and it's kind of like when you were using format, you have print line. So in this thing, you have draw. What do I want to draw? Well, it's a little more complex. You have to draw stuff. So let's start with something simple. So what we're going to do is we're going to type C80 die, right? So so if you've ever I don't know if you ever had maybe nobody's ever done this here because it's probably an older thing. In the past, people would take cloth and they would dye it. They would give it a color, right? And they would give the whole thing color. You would take some cloth, you'd make the whole thing purple or blue or green or whatever, yellow, and you would give it a dye, and it would all become that color. So in this case, what we're doing is we're going to color this thing. We're going to dye it, right? And for us, the dyes have numbers, right? So the color of the dye is going to have a number. So there's 0, 1, 2, 3, et cetera, et cetera, et cetera. And we do that, and then again, it's a little more involved. And this is because the Go Playground, I have to do this, right? So we draw. Okay, so what we draw? Well, we have some dye, and this is the dye, and this is basically the color that we're going to color the thing. We have some dye, and we're going to use dye number 0, right? And there's dye number 1, dye number 2, number 3, et cetera, et cetera. We use dye number 0, and we're going to draw it, right? Because anything we want to do, we want to put it out that we're going to draw it. And then because we're in the Go Playground, we got to reveal it, right? So hopefully this works, but let's run that. Come on, work. Oh, excellent, it worked. And what do we get? Hey, we get an image, right? And with this image, like die number 0, like it's actually color number 0. Color number 0 is black, and it just happens to be that. And just so you know, like the why it's called C80. The reason it's called C80 is when I made this package, I try to make it similar to computers, including video game console or arcade machines, that were common in the 1980s and also somewhat in the 1970s. So the 80 refers to 1980s, right? And the reason for this is, and we're not going to go into all this right now. This is something more we'd go into with the boot camp. But the reason to do this is because it's much easier to learn how to program the machine from the 80s than it is to program, for example, like a modern game. And like first you need to like walk before you can run. First you need to crawl before you can walk, right? And if you wanted to get into something like that, it's much easier to start with a machine like this, like a kind of like a way of programming like this, than it is to do like the full modern ones. Okay, so let's change this, right? Like what happens, for example, like if we change it to 1, right? And like if you remember back, like we were when we did the first programs, we had the format print line, and we had a string, right? We had the stuff between the quotes, and we changed that. And every time we changed it, the output changed, right? And let's do the same thing here. And what does that tell us? It kind of tells us like, okay, well we just put the draw here, we put the reveal here, we put the die here, and like this is the thing that matters the most right now for this code, right? Okay, well let's see what happens when we run that. So we're gonna go run that. Hopefully it works. Ah, crap. So that didn't work. That was the error, by the way, it was giving me before. I'm not sure why it's doing this, but just give me a sec. So let's just try running that again, and hopefully it works. Sorry. Yeah, this is one of the risks when you kind of do live demos. Oh, there we go. Great, it works. So what we get here? It's a big red rectangle, right? If you think of it like this is kind of like a computer screen, like say you had like a Game Boy, like if you remember those things, and they were a lot of them were like taller rather than they were wide. Or if you think of your phone's kind of like that too, right? It's the vertical, right? The up and down, that's a lot longer than the left to right, the horizontal, right? So it's kind of like that. So we've dyed the whole screen. We colored the whole screen. Fantastic. Okay, we changed to the 1. What happens if we change that to 2? What happens if we change that to 2? Oh, there we go. It's green. So die number 2 is green, right? And again, like all we did, like everything's the same. All we're doing is kind of changing this. Okay, that's great. So so that's, oops, sorry. So that's fantastic, and we've done all that.
I got 2 questions.
Yep.
First is when you import package, for every function that you call, do I have to use the package prefix, like C80 dot for every function I call?
It depends, right? So so in our case, the way we imported it, let me just go there. The way we imported it, we would, right? And that's usually the way that people do things, right? Usually the way people do things is that package prefix is always there. It's a bit annoying. There's a way around it. I do not recommend doing it this way, but I will show you what to do. So if you put a dot in front of this, you can get rid of that, right? And let's actually do that. So I'll put the dot there, and what does that mean? Well, I can get rid of the C80 here. I can get rid of the C80 here. I can get rid of the C80 here. And I click run. And hopefully I don't get that error again. See? So that worked. So like if maybe you wanted to do that, you could do it. Most people like tend to leave the package name. They don't remove it. It's a bit annoying, but it also gives you a sense of like where these packages are coming from in case you need to like look up documentation and whatnot. But yeah, you could remove them, but most people usually leave them there. Okay.
And the second question I have is when you're importing from GitHub, what is it doing behind the scenes? Is it downloading the entire package? And if it is caching it, how do I refresh it if, say, you change code on GitHub?
Right. So that gets a bit more involved because there's a lot of things kind of at play with that. Okay, so yes, there would be a pull from GitHub, right? And it kind of depends how you have things set up with how that works. Sometimes your environment might pull it. You don't necessarily have control over which version it's pulling, but it kind of pulls it and caches it. And if you use it, it'll just use whatever it pulls at that time. You can also, for example, pull it and include it as part of your source code, right? And like I do that a lot actually. I'll pull it, I'll put it as part of my source code, and that makes it so that what happens if someone has a package and they delete it, right? Like, okay, it's gone. Oh crap, right? Like, what do? You were depending on that. Another thing some people do, and this could make it so you include as part of your source code or not. Some people use a new system where you have a special file where you can specify the version of the package you want. So for example, like someone's working on a package, maybe they add new functions for it, so they fix bugs, but they could also make it incompatible with what you were doing. Like maybe the function was called something like think print line, like actually we have print lin, and then they rename it. It's no longer print lin, it's print line with I and E in it also, right? That's not going to work because that's not what's written in your code. So you can lock your code to a specific version. You might or might not want to include that package in your code. I tend to prefer to include the package in my code because I want control over it. I don't want the package just disappear. That's a bit more advanced than we're kind of going to go in today, but it's a great question though. Like, it's an important question because like once you start actually developing software in it, this will be very, very important. Does that answer your questions?
Yeah, it does. Thank you.
Okay, awesome.
One other thing to maybe add to the using the package name to prefix calling the methods from that package is that it helps to avoid collisions.
Right. That's a good point too. So let's say, for example, like we have C80 draw. What happens if there's another package that also has a draw? What do we do in that case, right? Well, there's a problem, right? Like Go can't figure it out. Well, you said draw. I don't know whether you mean C80 draw or this other package's draw, right? So error, right? What do you do? If you have those prefix, you can like differentiate between them. If you don't, well, you can't, right? Okay. So what have we seen so far with the colors? We're getting back to the dyeing now. So we had 0 is black, 1 is red, 2 is green, right? This is how like a lot of these older computers kind of went. A number equals a color. What happens if there's 3, 4, 5, 6, and 7? Like, what are those? Okay, so here's your exercise, right? What I'd like you to do is I'd like you to figure out what yellow, blue, and gray, what numbers are those, right? And I'm going to put the code back up, right? And let me just introduce something right now. So you can include text. You can include text in your code that doesn't do anything, right? It's not actually code. If you precede it with a double slash, and I'll show you what I mean. So if I want to keep this here so you can kind of see it. So what if I put that there? Well, it's not going to work, right? It's going to have an error because it doesn't understand it. Ah, crap. Well, that's not the error, but it has an error. What I need to do is, if I put like these things in front, it'll just ignore that line. It says, well, that's not source code. I'll just ignore it. And if we run it again, we get that. So it works. Great. So I'm gonna leave this here because this is kind of like what the code looks like. And what I want you to do, like we've already tried 0, 1, and 2, right? I want you to try other numbers. Just start going up, and I want you to figure out what yellow is, what blue is, and what gray is. Okay. So I'll give you 10 minutes for that.
So one thing that's kind of a question, I guess, as well. Michael T from Zoom had mentioned that he was receiving an error, not really an error, but rather the output was like a key map value, whereas image and then like a textual representation of what the image might look like. And he has a bunch of print statements prior to calling the C80 package, and I believe that's why if you comment out the rest of your code.
Yeah. So if you include, you can't output anything else. So this line of code here, this is something very special for the Go playground. And the way it kind of works is that on the Go playground, if you output in all capital letters image, and then a colon, so there's no spaces, image colon, and then you take your image data and you have to encode it a special way. For those that know it, it's a base 64 encoding, and you just output that, it'll display the image. If you output anything else, it won't work. It won't work if you output anything else. So you can't do, you know, format print line or anything else. You have to like just do this, right? So like Drew was saying, the reason your image isn't showing up is because you have those other prints. But this is kind of like a secret trick in the Go playground. I don't think most people know about this. Okay, so I've set the alarm for 10 minutes. So give this a try. You know, change that number, right? Like what we want to do is we want to play this number, right? Because like we want to change this number, and we want to figure out what number gives you yellow, what number gives you blue, what number gives you gray. So we'll just hang out and do that.
There's also another question from the YouTube stream, which is from UD. How does import work? Does dot import all the sub packages regardless of whether it's used or not?
Okay.
What's the impact of compilation?
So so what dot does is it just makes it so you don't have to put the prefix. So if it was println, I could just do, instead of doing format dot println, I would just do println. If it's like, you know, C80, I don't have to put C80 dot reveal, I could just put reveal. So dot just means you don't have to put a prefix, like essentially. When the package gets brought in, I think the compiler might optimize this, but conceptually it brings in the whole package, right? It brings in everything in the package. You don't say like, okay, I just want this function out of the package. There's no concept of that in Go. But you kind of get the package as a whole. Now, I think the compiler will, like when it compiles it, it'll kind of remove anything you don't use, I think. I'm not 100% certain, but I think it does remove that. But it basically, like conceptually, like it just includes that code as part of your code, as part of your program, and it just compiles it all. So that's what import does. That also means that if you have a package, you have to make the source code available. You can't just have a binary library, and that's why. So a lot of the package system in Go is source code oriented, which is good in a lot of ways. I mean, one of the things I like about Go, excuse me, one of the things I like about Go is you can kind of just like read the stuff to figure out how it works, and especially when you're getting started with Go or getting started programming, it's useful to see like, okay, I'm using this, for example, format println. How does it work? Right? I'm using like C80 reveal or C80 draw. How does it work? What does it do? And you can learn a lot by doing that. A long time ago, this ages me, when JavaScript first came out, you know, like there was websites that, or even like when I learned HTML, there was websites that had HTML, and I was like, oh, there's a web page. How does this work? And you could view the source of the page, right? You could like in, I don't know if it works now, but you could hit Control U on your keyboard, and it would pop up a window and show all the source code for the web page. And you can figure out how it works, right? Like in the same way, like with us, we kind of have something that works and we make a change. It's like, well, what happens when I make that change? Oh, look, you know, if I change this thing within die, it changes. Same thing when I was trying to figure out HTML and JavaScript. I was like, oh, look, here's a page that works. What happens if I change this? What happens if I change that? What happens? And just by like through trial and error, through like trying stuff, making mistakes, learning from those mistakes, or even like doing stuff that's successful, I can figure out how this stuff works, right? It gives me an understanding and it gives me an intuition for it. Yeah.
I got another question.
Yep.
So I'm a little confused because if I am importing a GitHub from someone else's repository,
yep,
like it's still a risk that he would delete that repository, right? So
yes.
If I have a production application, does that mean that I would always like what's that word again? Not clone, but
it's called vendor.
You know what I mean?
Vendor.
Yeah. Would I do that?
I recommend you do. There are a lot of people who don't. I think that's too big of a risk. I personally, I vendor people's stuff. I even vendor my own stuff. I personally vendor stuff within an application that I'm making. And I think everyone should. Now I know other people don't. I think it's too big of a risk. Even other things, like years ago, I used to do work for Electronic Arts, EA, this is video game company. And I remember like EA went down, or sorry, not GitHub went down. And what did it mean? Like EA software development at EA like basically like stopped like in a lot of ways because like everyone like you couldn't push a release or anything else because the build system was dependent on pulling on packages from GitHub, right? Because it didn't store any of them locally, right? And GitHub went down and stuff just stopped, right? And I thought that was brutal. And like ever since then, I've been like before I kind of like thought it should do it, but like ever since then, I was like, no, I'm doing it every time. Like it's too big of a risk. And the other one, like not even just GitHub going down, like we talked about, what happens if the author deletes it or renames it or something like that, right? It's gone, right? And your code's depend on it. Now, if you've been doing software development for a while, you could probably rewrite it from scratch. But I mean, like, how long? Like, if it's something pretty sophisticated, it might take you like a few weeks to rewrite it. You can do it, but like, do you want to go through that hassle? Maybe not, right? So I do recommend vendoring everything. Yeah.
So there's a couple more questions coming in. One from Ari on YouTube, which is asking, are we limited to only color with the draw in the function, or can we display multiple colors?
So with die, this part here, die, with die, you are limited to one color because what die does is it colors the whole thing. There are other parts to C80, and we'll get to that in a bit. There are other parts to C80 where you can draw on just a piece of it. So what die does is it colors the whole image, but there are other things in C80 that lets you like just color pieces of it. C80 does a lot of stuff that we're not going to cover in this. Like I said, it's something we would cover in the boot camp. But like, for example, like you can draw rectangles, and we'll get to that in this. But, if you're making games, one thing you would use, for example, are sprites. And I think nowadays people don't use the word sprite. They use what's called pixel art, right? And if you ever seen kind of like those older games and they're kind of blocky, like the artwork, but there's certain kind of like an appeal to that art. Those are sprites. That's sprite art. And C80 also supports sprites. You can even do like sprite animations and stuff like that. That would allow you to like maybe you have like I don't know, what games would you guys know from that era? Mega Man, Ninja Gaiden, Super Mario Brothers. Like I don't know if you guys know these games, but you could have the sprites for that, and you can just like put it there. And if you hook this up to controls, you can have the character run around, jump on things, shoot things, et cetera, et cetera. But when you do this first, right? Like the first thing you want to do is because there's stuff there beforehand for the previous image, you would clear the screen, right? Essentially dye it, right? Because what does it mean to clear it? You give it all one color. So maybe it's black, or it depends. Like maybe you're outdoors, so it's a sky color, so it's sky blue or something. And then you might have a map, and C80 has maps where you have here's like a floor, here's some trees, here's some clouds, here's underground parts. You draw all that there, and then you have your character somewhere. Maybe there's enemies and bullets and all that, and you would do all that. But the first step is you would die, right? And like I said, before you can run, it helps to walk. Before you can walk, it helps to crawl. So we're trying to go step by step. But yeah, absolutely, you could draw more complex things. You just can't do it with die. Of course, like there's the C80 documentation. You could go like look at stuff and figure it out, right? Like for example, there's map, pixel, sprite, right, et cetera, et cetera. So there is that stuff there. It's just we're taking it step by step. Cool.
Also, there seems to be a question ish in Zoom from Janith related to whether Go supports OOP.
It depends what you mean by OOP. So people mean different things. If you mean there's things like objects and you can pass messages to them like kind of like with methods, yes, there is. Yes, there is. And we'll get a bit into that near the end of the course. It's a bit of a more advanced thing, but we will get to that near the end of this course. It doesn't do class hierarchies. So if you're used to like the way C++ and like C++ did OOP in a certain way, it's not how OOP was initially, but C++ did a little in a certain way, and then that influenced Java, and Java influenced C#. So they all kind of do these kind of class hierarchies in a certain way. It doesn't do that. You can't force it. Like you can make Go do it that way. I wouldn't recommend it because you'll probably find the way it does it a little better. It does something sort of like duck typing. Now, if you're familiar with OOP and there's methods, and what you would do is you would have an interface, and it would have methods. Like for example, let's say a run puncher. So you have an interface, and it has one method called run, and then another method called punch, and punch takes an integer, like for how strong you punch. And you would kind of work with this interface, and like anything that has these two methods is this thing. It doesn't have to say it implements it like, in C++ and Java and C# does, right? It just, if it has that, it works, right? And I found it's a much more natural way for me, at least, to work. I also like long term, like the kind of like maintenance you have to deal with, like I just prefer this style. So yes, it does. You can force it to do what C++, Java, and C# does, but you'll probably find like the way it approaches objects, like in the classical way of saying object-oriented programming, you'll probably like the way Go does it better, I suspect. Okay, so hopefully that answered your question. Let's move on. Okay, so we wanted to see, what other colors was the other one. So let's just try some of this. So actually, if anyone wants to like unmute themselves and like suggest the answer, please do. But I'm gonna just run through these. So if we did 3, we get yellow. Okay, so that's one of them, yellow. So yellow is 3. What's 4? Let's see what 4 is. By the way, if anyone's used to like ANSI color codes, like for the console, these ones actually follow the ANSI color codes. Okay, so blue was 4. That's pretty simple. These are in order. I wonder if the other one would be in order. And let's go from 4 to 5, and we'll run it. I think it's like downlighter. Okay, that's purple. That's not gray. Okay, so it's not that. Let's go 6. Okay, sky blue, light blue. It's not that. 7. Okay, there we go. There's gray. So gray is 7. Okay, so hopefully everyone was able to do that. So we have all that. Fantastic. Okay, so someone asked the question, like, can we kind of draw other stuff? It wasn't worded that way, but something like that. So one of the other things we can draw is a rectangle, right? So what we're going to do is draw a rectangle. So our code, what we have here, we have the die. So we died like before, and like I'll just change the code to kind of like this. So we have here die 4. So I'm going to write, where is it? Die 4. And I'll just run that. And we also have this other thing here. We have a rectangle, right? And I'm just going to copy these numbers, but I'll type the rest out because I don't want to copy the numbers each time. So we see here we have 2 lines that draw, and that's kind of like when we had 2 print line statements when we were printing stuff, right? So we're going to come here, and we're going to, because we have to draw it. We can't just write rectangle because rectangle doesn't do anything by itself. We got to draw the rectangle. So we're going to draw the rectangle. And we're going to type C80 rectangle, and then we're going to put these numbers in here. And what do these numbers mean? Well, we have the docs, right? We have the docs we can look at. So we're going to look at the docs for rectangle. There's rectangle. And what does that mean? It means there's an X and there's a Y, and there's a place wrong place. I was looking at the wrong one. There is an X and a Y, and there's a width and a height and an index, right? And what does this mean? Okay, so let me see if I can draw it. Actually, So you have the rectangle, and let me just run this. That's probably the easiest way to do it. We'll run it, and then we'll kind of explain it. Okay, so we'll run it. So I got the rectangle. So we've added this line here. This is the new thing. We had like the draw, and like what does that do? We're going to color it. We're coloring it blue because 4 was blue. And we're going to draw this rectangle after that. So we do that. Oops, sorry. Just zoomed too much. We do that, and like what happened? Okay, so this rectangle, so the first 2 coordinates are the X and the Y coordinate. And what's X and Y, right? So X tells us the horizontal axis. So hopefully you can see my mouse moving. So in the top left corner of that image, right, that kind of blue thing with the red thing inside, the top left corner, that is X equals 0, right? It's also Y equals 0, but it's X equals 0. And then as we move right, X increases, right? So I think with this, at the right, it's 255. And then in the middle, it's about 127, 128, something like that. And 70 70 is here, right? So 0, and we go all the way out to 70. You see it lines up with this edge, right? 70. And then what about this 50, right? Well, that's the vertical axis. And with these type of images, vertical axis goes down, right? Like the horizontal axis goes from left to right, like 0 to big numbers. With the y-axis, it goes from 0 to I think 287 or something like that, but it goes down. Now, if you took math classes, you'll probably see it the other way, where y goes up. In computer graphics, like this, y goes down, right? So that's a bit of a difference. And well, it's 50 here, like y is 50. So what does that mean? So we go down on this 50 units, and that's this corner. So this corner is, x 70, y 50, and that's there. Okay, so what about these numbers here? It's the width and height, 50 and 70. So what do these represent? Well, the width 50 is how wide this thing is. The height 80 is how tall this thing is, right? And then the color, this one, the index, the color is color 1, which is red, right? So for example, like what if we tweak this a bit? What happens if we change the color, right? Like let's say I changed it to 3. What would it do? So let's change that color. Oh, you see that? It changed, right? We made that one change. We changed this number here, and that's the color, right? Just like the docs said, right? We saw the docs. We saw the docs. You saw like had index there. That was the color. We made that one change, and the color of our rectangle changed, right? And we also have this stuff, right? Like what happens if we change this, right? So let's change x. So what we expect, like x is the horizontal. X would do this way. And if we made it less, it would move this way. If we made if we went from 70 to like say 30, it would bring it over here. If we went from 70 to say 100, it would bring it over this way, right? So let's, for example, you see here like it's a little on the left side of it. Let's say, for example, we made it, I don't know, let's say 180. So we'd expect that to move over. So it's not going to be kind of the left side. It's going to be on the kind of the right side. So let's run that. Fantastic. Look at that. It moved over there. That's what we wanted. Now what happens if we play with this number, the y, right? So the y is the vertical, right? So when we change that, it should move it down, right? So let's say we changed it to like, I don't know, 200, right? So let's change it to 200. And we run that, so we expect it to move down because, like when numbers go bigger for y, it goes down, right? So let's do that. And we run it. Glad this isn't giving us errors, by the way. Okay, and look at that, it's way down there. Okay, that's pretty cool. And so I'm just gonna move it back where it was. I'm gonna keep it as yellow. I'll keep it as yellow. But so let me just adjust that. And the reason I want to adjust that because I didn't want to run out of space. I want to change the width and height just so we can see what happens, right? So we have the width is 50, right? 50. So that's how wide it is. What happens if we like make that, I don't know, like 120? We expect to be like much wider, much thicker, right? So let's run that. And look at that, it's pretty damn wide, right? And let's just put that back the way it was. And I'll make it yellow still. I like that mix of blue and yellow, by the way. I think it looks nice. Okay, so we put it back. And now what if we change the height? So before we change the width, and that was this number, and now we're going to change the height. So let's make it thin. Let's make it really thin. So what happens if we made it 10, right? We expect it to be much thinner, right? So it wouldn't be this tall. It'd be much like shorter, I guess. Short is probably the right word for it. Okay, great. That's what we expected, right? And like I said, like, it's kind of it might be kind of confusing when we first see it's like, oh wow, 5 numbers, right? What do they do? Well, docs, right? We look at the docs. We look at the docs to see which one's which. So when we look at the docs, we see the first one's x, second one's y, right? So horizontal and vertical. Next one's width, next one's height, next one's color. And like if you're trying this out and you have something like the Go Playground, something, you can just play with these, right? Okay, so that's great. So I'm going to just change back to what was our example. Okay, great. And yeah, so we covered that. Just one thing. Here's something. It's not on my notes, but here's something. What would happen if we change the order of these? What happens if I would put this first? Like, what would it do? So I draw the rectangle, then I die the whole thing. And remember, dyeing the whole thing changes the color of the whole thing. So what do we expect? So let's run that and see what happens. So before the dye came first, because I wanted to give it all blue, and then I drew a yellow rectangle. And now I draw a yellow rectangle, then I dye the whole thing. So if I run that, it's all blue. What happened? Well, remember, dye colors the whole thing. So we drew a yellow rectangle, it's there, and then we drew over it. We color the whole thing, right? So order matters. Order matters in like terms of how you draw. Same thing with like, format print line. Order matters. So if you whatever came first was the first line, whatever came second is the third line. With drawing, it's there's no lines, but there's like depth, right? Like you put whatever you draw on top of the previous thing. Dye colors the whole thing. So if I had a rectangle there, it doesn't matter. I colored over it, right? But if I dye it, okay, there's blue, and I color over that, and I put just like a rectangle that's in part of it, not the whole thing. Well, it's on top of it, right? So just keep that in mind for this type of stuff. Okay, so that's awesome. So guess what? You can draw more than one rectangle, right? You can draw more than one rectangle, and that's awesome. And I'm just going to copy those numbers, and I'll come back here. Okay, so we had the dye. Okay, that's great. So we're going to do another draw. Okay, we can't do the rectangle by itself. We got to draw it. And I'm going to create another rectangle. And then what do I have here? So I have, okay, well, first thing, the last one, that's a color, right? So first one is color 1, right? And this one's going to be color 6. So before, like, I was doing yellow, but it's not yellow. Actually, let me make this less confusing. Let me just do this. Sorry, I should have ran that so you could see it. So we put it back so the dye is first and the rectangle's next. So we expect, a red rectangle over a blue background, right? Because we draw the blue background first, because we dye the whole thing, then we put the red rectangle on top of it, and you see it there. Okay, now we're going to do another one, and remember, order matters. Order matters for this, right? So the first thing we do is we color the whole thing blue, and then we draw a red rectangle, and then we draw another rectangle with color 6. And I don't remember what color 6 was. Yeah, I don't remember what color 6 is, but we're going to find out. We're going to find out what color 6 is. So, hang on. Yeah, we're going to figure out what color 6 is. But you can see, like, okay, well, X, Y, right? So 90 is going to be a little over here, 80 is going to be a little over here. So it kind of seems like it's in this, right? It has a width and height and color. Let's see what happens, right? Like, I mean, with drawing stuff, we can just run this to see whether the numbers make sense or not. So we run this. And look at that. Okay, so 6 was light blue, right? So color 6, and then X, Y, 90, 80, like I thought it was inside of it. And it has a width and a height, right? So it's wider than it is tall, right? So it goes that way rather than this way. And that's pretty cool, right? And remember, the order matters. So this on top, like, for example, like if we switch these, like right now the light blue is on top and the red is behind it. If we switch these, then we would expect the reds to be on top, right? Because like the blue would be drawn first, right? And the red would be drawn on top of it. And if we run that, and that's what we should see. That's what we expect to see. And great, it works, right? You see the blues behind it. But we'll switch that back because that's what we want to do. Okay, so there we go. So what do? We're using C80. This is a new package, right? So we're not using format anymore. We brought that in C80. And C80 is a package I wrote, but it allows you to draw stuff, right? And this thing down here, we just kind of always add it for the Go Playground. It allows us to kind of show up the image. And what we start off with do is we color the whole screen, the whole image, and we give it color 4, which is dark blue. And then we draw 2 rectangles. The first rectangle we draw is red, color 1. The second rectangle we draw is light blue, color 6. And with this XY coordinate for its top left corner, so the XY is the top left corner, right? And then this width and height. Okay, well that's great. Like we can draw images, right? That's pretty cool. So we've done that. And yeah, so let's do an exercise now. So what I'd like everyone to do is I'd like you to draw a face. I'd like you to draw a face out of rectangles. Now, it's not going to be a perfect, it's not going to be a perfect face because it's made out of a bunch of rectangles. But draw a face. So I'm gonna give you, let's say, 15 minutes for that. Something like that. And hopefully that's enough time. But like basically what you'll have to do, and like do ask questions. Basically what you'll have to do is, you have to, because I mean there's not enough for a face there. You need something for the face, you need something for the nose, maybe like one rectangle for the face, that'll be behind, and then another rectangle for one eye, one rectangle for the other eye, another rectangle for the nose, another rectangle for the mouth, right? And you'll have to fiddle with those numbers. So let's do, we'll go, let's say until like right now I have 239. So let's say maybe 254. Okay, so I'll give you guys some time. I'm here to answer questions. And I'll check to see if there's any on YouTube. So please do type this out, give it a try. That's how you learn. You learn by typing this out and trying it. It's actually the biggest thing, I think. Like, I went through the whole university process. I think like it was kind of odd. Like a lot of the stuff they taught, I didn't think it was that useful. I think the biggest usefulness is just spend time programming, right? Like, I mean, you go through the university process and you spend like 4 years programming, but you could do that otherwise. Like, they didn't have these like before, but like, I actually have a lot of respect for the boot camps out there. They actually teach you what you need on the job, and it doesn't take 4 years. But I think like one of the things is you just get the time to program. And sometimes it helps to have someone that maybe can help you out with the problems you have, or kind of point you in the direction like, hey, go program this, because this is useful for learning what you need to learn on the job, right? But take the time to program, take the time to write this out yourself, like code it yourself. If you have questions, ask. That's how you're going to learn. So I'm just going to remove my headphones just for a sec because I'm going to walk away, but I will be back. If you have questions, please ask when I get back, but I'll let you guys work for a bit. So another few minutes. About 3.
Charles, can you post your bootcamp URL?
Hello? Sorry.
I can't find your bootcamp URL.
The which URL?
Your bootcamp?
Oh, the boot camp. Oh, I'll bring that up. Just give me a sec. There we go. Can you see that?
Yeah,
It's-
but page not found is
Sorry?
page not found is. It's written page not found. But this
Page not
URL.
found. Should be found. Let me try it. So it'll take you to a form to fill out. I don't know if you can see that, but I mean, it works for me. Maybe something was mistyped. It's Reiver REIVER .github GITHUB.io. So .io, not .com. / go hyphen bootcamp BOOTCAMP. If you connect with me on any of the channels I listed, like GitHub or Twitter or wherever, and you can't find it, just let me know and I can send it to you. Although it should be on the video also. Actually, maybe I can post in the comments. Hang on a sec. Oh, someone already put it in there also. Okay. Yeah, it's in the comments also for the group video chat.
Yeah, found it. Thank you.
Great. Okay, so let's move on. So a lot of you probably played with these numbers to try to make something that looks like a face, and now you're going to see me do it. Okay, so let me close that, and I'm going to move the keyboard over to my lap so I can type. And I'm going to try to do the same struggling that you guys are going through. And keep in mind, like I've been programming for like 25 years or so, so I've done this quite a bit. I haven't drawn faces like this, but I'm kind of used to doing this stuff. So I make something that kind of looks like a face. And but I would just play with these numbers, right? I don't know exactly what it's going to be, but I would just try things out and let's see what happens. So I just increased the width of the red rectangle to see if like that helps. It's better, probably. Maybe I'll increase the height a bit too. Maybe I'll make the height, I don't know, 140. So this is the red one. And you can tell because it's in the back. Okay. And let's make this blue one an eye. And I think the width is way too wide. It's way, way too wide. What happens if I make it like, say, 10, 10? What would that do? That look good? I don't actually know. It's probably not going to be the best face because that's okay. Maybe a bit bigger. That's kind of an eye. Okay, let me remember I had that stuff. I said everything after the slashes doesn't count. So this is the face, and this is the left eye. So let me make a right eye. Okay, so C80 dot draw, and C80 dot rectangle. And then I'm gonna copy this because I'm gonna based off this. I'm gonna tweak it. So I want it like the same width and height because I want the eyes the same size, but I don't want it in the same place. And the head, it started at 70, and then the X, right? So like where it is on the horizontal, it's 70, and this is 80. So it's like it's 20 away from it, right? Okay, so the width of this is 100, and it starts at 70, right? So that means this is 170, so I want to go 20 back. So I want this at, I said it's 170, so 150, and that'd be like the right edge. But I measure from the corner, so that'd be 150, but like it's 20 wide, so 130, maybe? Let's try that. I'll do 130. It's doing, I might have got that wrong. Ah, crap, hang on. What did I do wrong? C80 draw, C80, oh, I spelled rectangle wrong. I spelled rectangle. So I had an N instead of a C, so let me run that again. I spelled rectangle wrong. Okay, so that looks okay for eyes. And so that was the right eye. Now I'm not gonna give it a mouth, or sorry, I'm not giving it a nose, but I'm gonna give it a mouth. So let me give it a mouth. So maybe the mouth. What's the distance between this and this? So this was 70. This is 90. This is 110. And I said this is 130. So there's 20 in between. So 70, 90. 110. So maybe I want that at 110 but lower. So I put C80 draw. Now I'll just put this mouth. And then C80. By the way, this thing after the slash is called a comment, if you're wondering. Rectangle. And then I said it was 110 for X. And then, okay, so it's not gonna be 80. So 80 was like it's the vertical, it's this. And then like here, because this is 20 high, this is 80, this is 100, but I want it a lot lower. So maybe I'll just guess. Maybe I'll just guess something. Maybe I'll guess, I don't know, 140? Oops, sorry, one place. 140? I'll just guess. We'll see if that works or not. And then I'll just keep it as 2020 for now. And I'll keep it at 6, so the same color. So it's still like the light blue. It's still the same 2020, so look about the same. I'm just trying to like move it down. So let's see what that looks like. Cool. I got a face. Excellent. I don't know if your faces looked as compelling as this, but I'm pretty impressed. Sort of. So anyways, I got that face. If anyone wants to share their face, feel free. But I'll go on. Okay, so what we want to do is move this face. We want to move this face. And what do we want to do? Let's say like, oh, we put this in the wrong spot. We really want the face like over this side, right? Like what's that like, right? Okay, so what I'm going to do first, I'm going to kind of save this, right? So I'm going to duplicate this. What I'm going to do is I'm gonna like remember what we did before? I had that stuff where like the Go kind of compiler ignores it. I'm gonna comment this stuff out. And what does that mean? Like it's like it doesn't exist. It's like it's not there. when like this Go playground goes to run this code, it doesn't run this. It's like this isn't here. But the reason I want this here is I want to compare it to what we do, right? Okay. So I want to move this face over. So if we just run this, let's just run this, and we'll just show it's the exact same thing we have now. If I just run this, okay, you see it's the same place, right? I want to move everything over, and I want it to look like this, right? And what I want to do is I want to move all this over. So let's say if I want to move over like 20. Well, what would it mean to move over 20? Well, I might, for example, okay, let's move plus 20. Or sorry, I put 21. Plus, let's do 30. Plus 30. Plus 30. Plus 30. Plus 30. Plus 30. Okay, I'll just shift that over because it's easier to read. You see this column here? I added 30 to all these x's, right? And what do I expect? I expect it to move over 30 pixels, right? Like 30. And by the way, I said pixel. What is a pixel? If you zoom in on this image really, really close, you'll see it's made of tiny little squares, right? And like when I say 0, this is pixel number 0. And when I move over here, it's pixel, I think, 255, right? It doesn't look like it, like necessarily like it's made up of tiny squares, but it is. It was more obvious when we had the computers back in the 70s and 80s and stuff like that it was made up of little squares. You could actually see them. Nowadays, the monitors are so, advanced. You have to get in really close, like sometimes with a magnifying glass to actually see the little squares. You can do it on your TV or monitor if you want, but like it's really hard to see now. But it's still made up of those little squares. We'll say squares. Technically, it's a little more complex, but I'm going to ignore that for now. It's made up of these tiny little squares, right? And when I move these, I'm basically shifting over like those squares, right? Okay, so I want to move over 30. So it's here. You can see it looks centered. Like to me, it looks pretty centered, right? And it should move over, to the right. So let's run this, and you can kind of see at the top of the head, like will that move? It's going to disappear briefly, but it was like about here was I think the left edge. Yeah, you see it moved. It's over to the right. Fantastic. Now what if we move it again, right? Can you imagine I go like, okay, fuck. Sorry, I swore. Let's say I wanted to move it down a bit, right? Like I don't know, 40, and then 40, and then 40, and then 40, and then that's kind of tedious, isn't it? Like every time I want to shift this around, I should move down. So we can see it before. You see like it's much, much lower, right? That's just tedious. Okay, so what we're going to introduce is a variable. We're going to introduce variables. And what's a variable? We kind of saw it in the example before, but a variable is this, right? We're going to have something, and I'm going to do dx. So how much I want to move it horizontally. Dx equals 30, right? And then dy equals 40. So this is how much I moved it left and right. And the reason I'm doing this, because like imagine, for example, let's comment that out for now. Imagine, for example, I wanted it up higher. I was like, oh, that's too low. What do I do? Well, I have to go 10, 10, 10, 10. I got to change all that, all 5 lines. Imagine like, like I drew something pretty simple, like a face. Imagine it was really complex. Imagine like a video game, right? Like those things, those things are made of like a bunch of these things placed around. Like it's tons and tons of lines, like conceptually, right? Imagine having to go to each of these and change it. That's so tedious. That's not the way most people do it. Because like it's the same 10, it's the same 30, it's the same whatever you're changing. So what you would do is you would create a variable. And like I changed that to 10, so let me change that to 10. And instead of writing 30 here, right, I would write dx, right? Because like dx is 30, right? I assigned it 30. And the way you can think of these variables are like boxes you put something in, right? I have a box I put something in. And right now, in the box, I have 30, right? And in the dx box, right? And then in the box I call dy, I have 10, and I can use that. Now, if I run this again, I should get the exact same thing. Right, let's run it. Let's make sure it works. And I do, right? It's right there. And that's pretty cool, right? That's awesome, right? Let's move this around. Like it makes it easy. I don't have to go here and change it. Let's say I want to move this to like the top left corner, right? Like I'll make this 0. Actually, I guess it wouldn't be top left corner, it'd be where it was originally. But I'll make it so it doesn't move it from the original position. Right? I just changed 2 things, right? That was easy. What happens if I want to move it a bit? Like maybe I'll put minus, I don't know, minus 50. What if I do that? I should move it to the edge, I think. The left edge. Or closer to it anyways. Yeah, see, you moved it over. So I can like, I'll move maybe this, move it up a bit. So like negative is this way top with the vertical. And that's pretty cool. Like I was able to, like, I didn't have to go to all of these and change it. I just changed these two things, right? And that's variables, right? Like it's like a box. You put something in, I can put other stuff, and I can even like do it later. Like here it's 50. What if I want to change it? Well, I could say, oh, someone burped. I can say, I don't know who that was. I can say, is someone okay? That's a dog. I hear a dog. Someone's got a dog. What if I change dx to like 10, right? I can run that. That's kind of funny. Someone's dog's talking. And, you know, it moved it, right? So even though I started off and I said it's 50 here, I can change it. It's a box. Remember, it's a box. And at first I put minus 50 in the box. I put minus 50 in this box, and then I put 10 in the box. So that by the time we get here, it's not minus 50, it's 10, right? Because order matters, right? Order matters. Just like when we did the print line, just like when we draw, order matters. So lower down, like further in the code, I put 10 in it. So this all changes. And if I put, say for example, I put 30, 30 is like positive, and I expect it to go to the right. I expect that face to move to the right, and I run that. And it does, right? It moves to the right. I can move it even further. Let's say I put 60. Should move further even, maybe even like clip a bit. Yep, see, it's a lot further over there. Okay, excellent. So, so we have variables. So what does that mean? You guys have faces. You guys and gals have faces. I want you to do something like this too with your face. Now, your face is going to be different than my face. I'm going to leave my face up, this face, the digital one. I'm going to leave this face up. And what I like you to do is to adjust the code for your face to make it so you can move it around. And I want you to put variables. And I want you to do the same thing with yours. So we'll just pause for 10 minutes. So we'll go until 3:20. Or I guess it's 3:09, so 3:19. And we'll just wait while you guys do that. And yeah, so change the code. Change the code for your face to use variables so you can move it around. And so first you want to put like, you know, like you don't have to call it dx, right? Like I could call it like, I don't know. I call it anything I want, goat. But then I would have to change all these to goat, right? I have to use the same thing. I have to be consistent. I'll just put dx for now. But you want to have your own dx, your own dy, and you want to make it so you can move it around, right? So spend some time doing that now. You have some code for a face. If you don't have it, you can copy mine. And remember, like what you want to do is you want to write out the code. You want to write out the code yourself. That's how you learn this. Like seriously, like it's like the big thing that, you know, like impacts like how well you do as a software developer is the time you put in writing code. So don't just look at it, don't just read it, write it out. Write it out and run it. And if there's a mistake, fix it, right? That process of going through this is how you get good. So if you don't have your own face, you can use the face I have. If you do have your own face, fantastic. Add the dx and dy variables and make it so you can move it around. So you got now 9 minutes to do that. So I'll just give you guys a bit of time, and I'll just step away from the computer for a bit.
I got a question.
Oh, yep.
This is a little bit more advanced. Are variables and collections by default mutable? Immutable collections and variables?
Yeah, good question. It's a bit of a mix. So from the point of view of a variable, if it's a variable, it is mutable. Go has constants, right? So if you want something that's immutable, you would use a constant. Like you would declare it a bit differently. Just give me a sec. So I try to keep, you know, like because there's some people you know, I try to orient this class so that you know, someone who's never programmed before could feel comfortable learning this. I didn't write the variables, for example, like this, and you often wouldn't, right? So for example, you could do this to create a variable instead of just like this notation I have here with a colon equals. If you change this to const, it's immutable, right? And like you don't even have to include this a lot of times. So a constant is immutable, a variable is mutable. Immutable for everyone else. Mutable means you can change it. And like, for example, like when I later on I did, and notice that I don't have a colon here, right? You can only do that when you first create it, when you first use it. I can do dx equals 0. That's mutable. You can't do that with a const. There is a limit of what can and can't be a const. Like you can't have const structs. I think that's unfortunate. I really wish Go would include const structs and even const maps. It doesn't. I'm hoping maybe in the future, at least for the structs, especially like when the structs are made up of things that themselves could have a const of. I'm hoping it will add at some points, but it doesn't yet. Does that answer your question?
Yeah, and because you said there's no classes, there's no OOP, I'm guessing there's also no static variables as well, right?
So you can do OOP in Go. So I can show you a bit, just while we kind of wait. So what you would do, it doesn't say class, it calls them all structs. So you would have, for example, like type, I don't know, dog. I'll probably use this as an example later on. And say you're trying to model a dog, right? So maybe it has a name, oops. It has a name, age, int. And if you want people to be able to access these like public, variables, you would put the first letter capital. If you want to be private, you put lowercase. So Go does scoping based on like whether the first thing is uppercase or lowercase. And you'll notice like all the functions in a package that you'd use all start with a capital letter. So it doesn't say public or private or protect or anything like that. It just does it with the capitalization of the first letter. And then you can create methods. And like some languages, the methods would go inside of this. Go doesn't do it that way. What Go does is it has a method like dog, and I might have bark, right? And then so like you could create something like this. Now you can do something like class hierarchy, like you can embed another type within it. Like say you had animal, and you would inherit all the methods of that. People tend not to do that. You kind of like it does OOP, but it like think like the original style of OOP, or like what was it called, small talk or whatever, right? It was message passing. It wasn't like class hierarchies. That was kind of like a more kind of a thing that was popularized around C++, and then Java and C# kind of like adopted that too, and now everything's copying Java. So like things like PHP and other things and JavaScript are copying it. But that wasn't the original OP. You can do that, but what you tend to do, like if you had a function, like you might, for example, like you'd have an interface like Barker. What does Barker do? Well, Barker is anything that goes, oh, I typed that wrong, sorry. Bark, not bank. Is anything that goes bark, right? Like has a method. And then you had a function, and then you would have a variable, and then here's the interface I'm using, a Barker, and then you would, I guess this should be here, pet, and then I would pet the Barker, right? So this is how you would go about doing OOP like stuff.
You have your type defined as a banker, not a Barker.
Do I? Thank you. Good catch. Yeah, so this is how I do it. You do it as structs, right? And it's like the C structs, right? Like there's no extra overhead there. There's nothing hidden. Unlike C++, when you use a class, it puts a lot of stuff in that memory, right? So like a string is going to have a certain byte count, an int's going to have a certain byte count, and then this method exists, and the method has a like if you've done C++ or some other ones, they have you're maybe used to this. But you can call it whatever you want here. You don't have to call it this. And then this is like a secret method that accesses all this stuff if you needed it. Like if I wanted to, I could put, woof, I am, comma, receiver.name. And then that would give me access to the dog's name, right? And then it has that method, and then you usually, and this is where the kind of like the duck typing comes in. You declare what you want the thing to look like, and then you run your function on that. But that's the style you see within Go. I like this a lot. I've done both styles. I've done the kind of C++ style that you see in lots of different languages. I found there's certain problems you get when you do that. Like the managing of the class hierarchy is just a pain. I find this is easier. In terms of, I should say not easier. This has a better developer user experience. This makes it so that as the code progresses and it changes over time, it's much easier to work with it. But that's my preference. Does that help? Does that answer your question?
Yeah, that does answer my question.
Yeah.
Thank you.
No problem. Cool. Okay, I'm just gonna step away. I'll be back. I'm usually going get a drink or something. Usually water. Okay, so I'm just gonna, there's some questions on YouTube I'm noticing from, I think, Yudi. Sorry if I'm mispronouncing your name. Question, if a string stored in memory like this, 12 \n, so \n is the new line, which we haven't introduced. Format print line does not print the trailing \n, example prints 12, which makes difficult to debug. Okay, so Yudi, if you're on the Go playground, it's going to do something a bit different. It kind of, you don't see like really the real output. It kind of like tweaks things a bit. If you were doing this in a more traditional development environment, for example, if you were doing this, you were working on the command line, maybe in Bash, and you had an editor and you were building it there and compiling it there, and you put a \n in, within print line, you would get an extra line. You just don't see it on the Go playground. So let's take a look. So Henry Chan answered that. He says it works for him. Okay, good. Oh yeah. Okay, so you're doing a bunch of stuff. You've gone like beyond what a bunch of people would do. But yeah, that's great. That's great. Yeah, you should see that on the command line. Like if you are using the \n, which is a special code that gives you a new line in a lot of environments, you should get an extra line. I'd be surprised if you're not, unless something weird's going on. Okay. Hopefully everyone had enough time to make progress on that. So we're gonna move on. Okay. So So what we're going to do now is, you know, let's say we're like making a video game, right? We're probably not going to have one character there. Like maybe this is the bad guy, maybe, or not the bad guy. Maybe it's like one of our adversaries. Actually, I never liked that idea of like good guys and bad guys. I think it's a story you tell children. I don't think it's actually real. Everyone thinks they're the good guy, or at least neutral. Nobody ever thinks they're the bad guy. But anyways, let's say you had two characters, right? How would we deal with that? Okay, well maybe what I would do is, you know, I could do it this way. I could go and I could copy this code, right? Maybe I paste, and of course, like, okay, before I had dx, so maybe I'll call this something else, like dx2, right? And then I gotta change all these to 2 because I don't want them to use my other code. Because the other dx controls the first face. So I'm trying to create 2 faces. So dx2, and then I want to move these. And maybe I change these to 0, 0. Now remember, like, order matters. So this face, like if they happen to overlap, I don't know if they overlap. If they happen to overlap, this face should be drawn on top of the one that's currently there. So let's run that, see what happens. Okay, well it does overlap. Let me move this one over. So let's just move it over there. And I'll move this one over a bit. Maybe minus 40. See what happens. Okay, maybe a bit more. So I'll move this one over a bit to maybe 70. See what happens. A lot of trial and error with this. So this is like normal programming. So I mean, if you were doing this, like, don't think it's not normal. Okay, so we got 2 faces. So you can see like the dx here is 70, so that's, you know, over here. Actually, I guess not 70, but it's over. Because I remember it was kind of centered before, and this dx represents how much we move it from where it was initially. So the 70 shifts it over this way. This minus 40 shifts it over this way. So this one that's minus 40 is this. This one that's 70 is this. Okay. What happens when we add 3 faces? It's like, wow, I gotta like copy and paste this again, change these variable names. Okay, so that's annoying, right? If I have to do that all the time, I don't want to do it that way. So we're going to choose something else. Go has something called functions, right? And what functions let us do is it lets us kind of like group code together that we can kind of like, it's kind of like copying and pasting like I did, except I don't have to copy and paste. Okay, so let's do this. What I'm going to do is I'm going to grab this code, right? And I'm just going to write a function. So we're going to go down here and write func. I'm going to call it draw face. Excellent, draw face. And this is just notation, like func, and there's a name, and I put these round parentheses, right? And I'm going to put something in there in a bit, but I'm just going to leave it like that. And then I have this left curly brace, right curly brace, just the way we write functions, just the notation. And then I'm going to copy that code I had before, right? And what I'm going to do is, instead of having this dx dy here, what I'm going to do is dx, I'm going to say it's an int. So we haven't seen any of that yet, but dy is an int. So these are both integers, right? Integers, like we talked before, Go shortens that to int. Technically, Go has different types of integers. There's different types. We're not going to go into that, at least not right now, because we want to keep this simple, but we're just going to write that. So instead of having dx and dy here, right, instead of that, I put it between the round parentheses. And you see before, like the dx and dy, it had numbers, right? Like you see, like here it was 70, 20, here was minus 40, 0. Here, we're not telling it what it is, right? We're not telling it what it is. And what does that mean? Well, we can just, well, I'll show you what it means. So what I'm going to do is, instead of having this code, what I'm going to do is I'm going to say, actually, I'll do this first. We'll keep the dx dy there. Oops. And I'll do draw face, and then I'll just put dx dy in there. And I'm going to delete that. And then I'll do another draw face. And I'll put dx2, dy2, right? And like what have I done? Like I've made that draw face, it replaces all this code, right? So I placed all that code, and I'm also going to delete this one. We're going to delete this. Okay, so all those draw statements, right? Like they're here, they're in this function. And instead of copying and paste that each time, I'm just gonna like call that, right? Okay, so let's run that. Let's see what happens. We expect, like, by the way, we expect the same thing. I expect to see the same thing. Unless I screwed something up, I should see the same thing. So let's run this. It's running. You know, the image disappeared. Cool. That's pretty cool, isn't it? Like, what does that mean? Like, what if I want to add another face, right? And first, like, I'm just going to simplify it a bit. Instead of having these variables here, I'm just going to put, you know, it's a box. We learned what variables are, which is great. And like, we're still using variables, right? Like, we're still using variables. We're using them here, right? We're using them here because we have the dx, dy still. But for here, what I'm going to do is I'm going to simplify it a bit. I'm going to put 70 here. I'm going to put 20 here, which is the values we have for dx, dy. I'm just going to like remove that, just to keep it a bit simple. And here I'm going to put minus 40. I'm going to put 0, which is the dx2, dxy2. And I'm going to delete that. Let's just run that to make sure it's the same. Oops. Like, get these again. And fantastic. Okay, so what if we want to draw another face, right? Okay, we can do that. Let's draw another face. Like, isn't this easier than copying and pasting? Okay, so I don't know, like, where should I put it? Let's say minus 70 minus 50. That should be the top left corner, I think. Yeah, there it is. It's drawn on top, so it's hard to see, but like, that's pretty cool, isn't it? And you know, like, actually, we won't do that, but like, you know, that's pretty cool, right? So I can draw as many faces as I want. That's awesome. That is functions, right? So what I'd like you to do, and this is the exercise, and like, let's see. Yeah, okay. So what I'd like you to do is I'd like you to edit your code, your face, so that you have a function, right? So that you have a function and you can draw, like, say, 2 of them, right? So don't copy and paste like I did initially. Create a function, right? And like, if you have a different face, your function is going to look different. Create a function and edit your code for that. So we'll give 10 minutes for that. And just so you know, we will take another break soon, because I know, like, probably people have to go to the washroom or they want to grab a snack or something like that. So we'll do that soon. But I'll give you 10 minutes and just kind of work on this. But if anyone has any questions for me, feel free to ask. If there's no questions, I'll just go get up and stretch a bit. And just check. Yeah, I don't see any questions there. Okay, so take your time, work on this. You got now 9 minutes. I'm just going to get up and stretch a bit. I'll be right back. think actually I set my alarm when I take these breaks. I think I set it to the wrong time. I noticed I set it to 3:29, and it was just 3:39. So I think I meant 3:39, but I didn't set it properly. So I hopefully give enough time and everyone had a chance to kind of try that out. I'm just going to check YouTube really quick. Okay, I don't see any new questions there. Okay, so let me just get set up and we can move on. So, like when a lot of people teach these courses, they often do stuff that's, I think, less interesting than like drawing. I mean, like learning the text thing, like, like printline, I think is quite useful. You need to see something to kind of learn this stuff. You need to know that I made a change and it had an effect. And that's how you kind of figure this out. But I think like images are much more interesting. And I think they help learn. Most people don't, I don't think I've seen really anyone else do these. But I find, I think these are helpful, and I hope you think so too. I mean, like, I think like with some of these, like, there's a lot of there's a lot of stuff you have to learn when you learn how to do software development. And, sometimes if you can do it in an enjoyable way, it just makes it easier. And, we're not going to make a whole game like with this workshop. We've got a day, right? Like, not even a full day. But for the boot camp, for example, like we go through and we learn some of the stuff by making a game, which is pretty cool, right? Like, I mean, even if you don't go into game development, it's still kind of interesting to learn it this way. So you learn all the fundamentals, all the core principles that you need to learn, but you learn it through something interesting, right? And of course, like, you do also learn the other stuff, right? Like, you do learn how to output stuff to the console. You do learn how to do web development. Like a lot of the software development that's done today, you could consider web developments. This could be in the form, like, even if you're using a mobile app, hits an HTTP-based API. And what is that? Well, it's communicating over the web. So that means you probably have a web server, you probably have APIs, you're probably outputting something like JSON or maybe XML or some other format. And, there's different ways you can learn it, but some are more interesting, some are more fun, some are easy to learn, right, than others. Like, there's no reason to torture people necessarily, just to kind of go through this stuff. And some it's more fun than others. Okay. So, so we're going to do a bit more with coloring, right? We're going to do a bit more of the face, and after we do this, we're going to take a break. We're going to take a break after this. And after we come back from the break, we're going to use a slightly different development environment. The reason is because we want to get inputs, right? So far we've been outputting, but we want to get inputs. We want to get input from the user, right? And that's going to require us to use something other than the Go Playground, because the Go Playground does not allow us to get input from the user. Okay, so we have this function. I'm going to just remove this last one. I think it's a little too cluttered with it. So I think it's okay with two faces. And we have the two faces there. That's pretty cool. And like right now what we do is, the inputs, like the variables that we kind of pass into this, we have dx and dy, and dx, dy kind of tells us, where it is relative to the center. Because when we had it initially, like imagine, for example, like, we'll just comment these out. And we want to put it where it is initially, right? And to see where it was initially, we'll just do draw face. We'll just put it 0, 0, right? Now, of course, this isn't the 0, 0 that we have at top left corner of this image, right? Like that kind of like top left corner of the blue part. It's not that. It's the 0, 0. It's where we put the image initially. If you don't remember, the top left corner of that rectangle for the face was at 70, 50. So this should move it to 70, 50. So let's run that. And you see there, this top left corner here is 70, 50, right? So 70 is from this side, 70 over, and then 50 down. Or, 50 down, 70 over, same thing. Okay, so we have that, fantastic. Let's just tweak this. I mean, like I might say, for example, like, the faces always has a red background and a blue eyes and mouth. What if I want to change that? So what happens if we tweak this function a bit, right? So maybe what I have is like, I change the function, right? I change how it looks. Like right now we have like two inputs, dx, dy. So what happens if I add something else? What happens if I added like face color? And I'm introducing something new here, uint8. There's a reason it's that, but ignore it. It's like an int, just ignore it for now. It's just a detail. It's not the important part. And face color, okay, so what's face color? It's this. So instead of one, I'm going to replace 1 with face color, right? Okay, well, interesting. It was 1, now it's face color. Now, if I try to run this, right, it doesn't work, right? It doesn't work because like this has X, Y, there's no face color, I just put face color. So if I then go here and I put 1, okay, now it works. Great. And what happens if I change that? Maybe if I change it to 2? What happens? Well, I expect the face color to change. I don't remember what 2 was, but whatever color 2 is, it's going to change to that. It's green. Okay. So there we go. Green face. Maybe if you remember Spider-Man, it's the Green Goblin. Okay, cool. So we have that. That's great. What if we want to change the eye colors? Could we do something for that? Yeah, we could. So it's not just the eye color, it's the eye color and mouth color, although we could separate those. So let's put, I'll just call it color. And again, uint8, ignore that. We're just going to like, just going to call it that. And you're going to pretend you're just going to like ignore that for now. It's important, but we're going to ignore that for now, because it's not important for what we're trying to do. So you see I replaced like the left eye color, the right eye color. Do I have 2? Huh, interesting. I have 2 right eyes. I don't need that. So it drew the right eye over itself. So that was, I mean, it's not a bug, but it's not ideal because we're doing all this extra work and it's running slower. So I removed that. So we have face color, so that's, this part here. And then we have left eye color, right eye color, and mouth. Okay, so let's run that. And if I run it, it shouldn't work because I added a new parameter, a new input, a new variable to this function. I didn't put it here. Okay. So now, like what was it? Was it 5? Was it 6? I think it was 6. Let's put 5. Maybe it's 5. Okay, that's purple. Let's leave it like this. Kind of reminds me of Incredible Hulk. So I have a green face and blue eyes and mouth. Excellent. So what happens if I wanted to adjust this? Like okay, well let's make this also. So face color 2, eye mouth color 5, and I'm going to delete that. And I want this to work, so I just run it. So we'll run that. And this is still commented out, so it's not going to work. It's like it's not there. And put it to the right. Excellent. And let's say I do the same with this. I'm just going to use the same colors for now. And maybe I'll just, okay, I'll do this. I'm going to do that. The last face was on the right, so now we have one on the left. Excellent. And what happens if I want to change the face color and eye color? I can do that too, right? So maybe here I want I'll put this one. It was yellow. I don't remember. So maybe I'll do that. So with the face on the left, which is this one, right? The face on the left, it's the face color is yellow, 3, and the eye color, mouth color is black, 0. And these numbers, there's a long history of why each of these numbers equal to those colors. For people that maybe programmed for a while or familiar with some of this stuff, these are the ANSI color codes that you're maybe familiar with on like Unix and Linux type systems. But if you're not, I just pick stuff. So that's pretty cool. So I modify the function. So that's an important point. You can modify these functions. I'm not going to make you do this. I was initially, but I'm not going to make you do this. So what we're going to do now is, just because we've been doing this for a while, we're going to take another 15-minute break. That'll give people a chance to go to the washroom, a chance to eat, a chance to stretch. I mean, like, it's like, by the way, it's not healthy to just sit like for long periods of time. And we're going to take that 15-minute break, and then we're going to come back and we're going to continue with this. So I'm just going to set my alarm, and this time I'm going to try to set to the right time because it's 2:50 now. I'm going to set it to 4 p.m. my time. Oh, that's actually not 4 p.m. 4:05 p.m. And that'll give everyone 15 minutes. So take a break. If you have any questions, let me know. I'll hang out a bit for questions, and then after that, I'll just get up and stretch myself. Yeah. So yeah, take a break. If anyone has any questions, let me know. I'll be here, but we're gonna come back and continue it in 15 minutes at 4:05. Right now it's 3:50, so I'll just hang out a bit, just in case anyone wants to ask some questions. Okay, so Ari wrote, I got lost along the line. Can you send me your code so I can review? Okay. So I can show you this. It's hard for me to... Actually, no, I can send it. I can send it. Oops, sorry. Let me...
Yeah, you can actually just use the share function of the playground and copy paste.
Yeah, I just remembered that. I remembered you telling me that. So let's share that. Now the challenge is Ari's on somewhere else.
On YouTube.
Yeah, but I don't have access to YouTube from this computer.
Okay, just paste it into the chat here, and I'll copy it over to YouTube.
Okay, awesome, thank you. That is awesome, thank you very much. Oops. There we go.
All right, perfect. Yeah, so Ari had said he kind of got lost along the lines of when we added the draw face function, which I could see because we didn't really introduce, like that was the introduction of a function, right? Here's a function with a bunch of arguments, and so if that's your first introduction to a function, then it might feel a little bit overwhelming.
Yeah, I think maybe what I should have done is introduced a function without introducing the variables first, like the inputs. But yeah, I mean, Ari, so I mean, what a function does is it's effectively like copying and pasting the code, right? It just makes it so you don't have to copy and paste. So like, for example, if I had one face, right, I would have code, and then say I want another face, I can copy and paste it, right? And I would have to go and adjust all these numbers each time. Right, if I wanted two faces, because remember, like I have two faces here, right? And I have to go and adjust all these numbers and the colors. And what a function does is it makes it so that you don't have to copy and paste. Like it's as if, like when you see this, like when you have draw face, it's as if all that code here, it's as if it's here when you see the draw face. It's right in there. I just don't have to write everything. And sometimes that's nice. Sometimes it's nice because, you know, you don't have to like make it as bulky, right? It's like I know what I'm trying to accomplish, like with all those lines of code, I'm trying to draw a face, but I don't have to put that in my main code. I don't have to look at that. It's like, you know, I gave it a nice name, draw face, and I can go look at draw face and I see all the commands, right? And it makes it a little easier to read. Like I can see, okay, there's two draw faces. Where if I had like a bunch of this, like say I had that twice, like, you know, like that. Do I know those are faces? Like it's not obvious, right? But if I name it draw face, it's more obvious to me. Now I could of course lie with a name. I could say like, you know, draw bird, but it's not really draw bird, right? It's a face. I could lie about that in a sense, but you're lying to yourself. But it could make it easier to read. But a function is basically just copying and pasting. Like what's here is effectively here, right? I don't know if that helps. Hopefully it helps. We are available. Like if you want to chat afterwards, we can chat about this. So if you get my contact information, just reach out, and we can go over some of the stuff. Yeah, just reach out and we can go over this stuff, and we can go over like kind of what a function is and stuff like that. The code we're doing next, it doesn't make really. We use functions in the same way we use format, print line, and we use like C80 draw and all that. but it's we're not doing in this function style. But like knowing there's functions, knowing you can simplify this stuff, knowing you don't have to copy and paste code is quite useful. In practice, when you do software development, you will write lots of functions. But in terms of learning this stuff, we don't have to do this really function heavy yet, in terms of like making our own. But do know, like in the same way you have format print line, you can make your own version of print line, and that's kind of what we did. But hopefully that helps. Okay, if nobody else has any questions right now, I'm just going to get up and stretch a bit. But we'll be back here at 4:05, so now it's 3:55. So we'll be back here in 10 minutes, and we'll start up again. Okay, so I'll see you guys in a bit. See you guys shortly. So maybe another minute or two and we'll get started again.
I just noticed there was a question. Somebody asked about the X and Y coordinates and whether they're relative to other shapes, like the head, for example.
It depends which X and Y coordinate you mean. For the image, just let me move my keyboard so I can do this. So the image has an absolute coordinate system. So the top left corner is x equals 0 and y equals 0. And as x gets bigger, it goes to the right. As y gets bigger, it goes down, right? Now, when I came up with the face, like the face is this line of code. And I kind of set the rectangle for like the overall face. So like what's, in this case, you can see in the images, it's the yellow or the green. When I did that, I put it at x equals 70, y equals 50. And then for the function, right, like what I did is I defined like a difference, right, like dx dy, like move, like you're basically moving everything from kind of like these coordinates, right? And I put the face at 70, 30, like for the top left corner. And if you put like minus 20, will it, like for dx, then instead of being, x equals 70, it shifts over to the left. And it's now at, x equals 70 minus 20, which is 50. And same thing with dy. It starts at, y equals 50. And if I put dy at, like, instead of, like I said, minus 20 for the other one, if I put, let's do something positive. If I put 10, then it's 50 plus 10, which is 60. So the dx dy are relative to the initial place I put the face, and I just made something up, right? I just made it up, and it's maybe not the best way to do it, but it's the way I did it. I think if I would have done this again, I would have put the face in the top left corner, so that the top left corner of the face was initially 0, 0, the same as the coordinate system. I would have moved it from there, but it's not what I did.
I actually just spent the last couple of minutes refactoring mine to do that.
Oh, did you? Okay, awesome.
Yeah, I just thought, rather than something arbitrary.
Yeah, and this is something that happens when you program. Like you program it one way at first, and it's like, this wasn't the best idea, and you change it, right? So if I was to change this, I would adjust all these things, but I'm just not going to do that right now because we're going to move on to something else. Okay, so hopefully everyone's back now. Just let me check YouTube just to see if there's any questions there. Okay. I think we addressed these questions. Okay, so we're going to go on to another section now. And we're going to go over to the CLI. Now, so far, what we've done for our development environment, we've used the Go Playground. And the Go Playground is, it's pretty convenient. It's not that similar to like what most people would develop it with, right? But it lets us get up going quickly. It lets us, we can learn a bit of Go, we can try a bit of stuff, we can see it working, which is fantastic. We don't have to struggle with setting up a development environment. And still, like, we're not going to struggle with setting up a development environment, but what we're going to do is we're going to use something that's a bit more like what we would use if we were doing software development for this. So over here, I hope you can see this. So before we're using the Go Playground, now we're going to use this. So there's one service online called Repl.it, repl.it. .it is actually for Italy, but I guess it sounds good, .repl.it. It's hard to find good domain names now. So if you can see it, it's repl.it repl.it/languages. So plural, languages, not language, languages, and then another slash and then Go. So we're gonna go to that, and we're gonna do some coding there. And if we go here, it's just loading up right now. Hopefully everyone can see that. Let me try to make that bigger because I think that's too small. I hope that's big enough for everyone. Just like the Go Playground, this also has some code there, and it calls it hello worlds. I write my hello world a little differently, but it has hello worlds. And like when we start with the Go Playground, we just wanted to run something. We just want to see something working, right? And we're going to do that here too. And in Repl.it, you have this green button. Now, like it looks a bit different in mine because I've kind of like made it bigger. I made the font bigger, but if you were to like not do that, you would have a run button that looks like this, where it actually says run. But because I've tried to make my font bigger, so you guys can see it, it's like that. So what we're going to do is just click that. We're going to click the run, and over here to the right, and hopefully everyone can see that. Over here to the right, and I know like we're covering it up a bit. We're going to see the output. So remember with the Go Playground when we ran stuff, the output was at the bottom, right? It was at the bottom. In the Replit environment, it's to the right. Okay, so we're going to run this. We're going to see what happens. Now, you're going to see a bit more happen here because Replit doesn't hide some of the stuff that Go Playground does. So, you know, actually, it might not show it for this, but we'll see it later. So it ran it. Okay, so what happened? We ran this code and we saw Hello World, right? And Hello World is here. Now, it showed us this Go builds, right? Like, remember when I said, like, you know, when you have source code, the computer doesn't understand source code, right? Like generally, like it has to turn it into a program, and in the program contains instructions the computer will understand. This Go build creates the program. And for various reasons, which we won't go into right now, the program is called main, right? It's just called main. And this right here is just, it's running it, right? So this is creating the program, and this is running the program. And then we see the output right after that. So the third line is the output in this case, right? And it's the only one without this kind of like orange thing to the left of it. And you can see again, like, you know, it's hello world. And it's the same thing we saw in the string, right? It's just, it has a different string here than the other one. And, you know, if we go here, I can make it more obvious, like, you know, there's the run button, you can see the arrow, and then the output's there, right? Just like I just showed you. Okay, fantastic. So I want to make sure you guys know how to use this, right? Like if you don't know how to use this, then it's going to be hard for you to do the exercises we're going to do. So what we're going to do right now, I just want you to do something simple. You already know this. You've already done this before. I just want you to edit this code, right? And I want you to add some more print lines, right? Just whatever you want. Print line. You can put anything you want here. And just put like 3 or 4 of them and then click run. And make sure what you put here get outputted. If you get that output, that means it's working for you. If you don't, it's not, right? So please do that. And I'm gonna change to this screen because I want you to be able to see this URL. Hopefully you can see that URL. Where'd it go? Yeah. So hopefully you can see that URL. Just go to that URL and put a bunch of print lines and click run and make sure it works for you. If it does, great. If it doesn't, speak up. So please go try that now. I'll give you 5 minutes for that.
It might actually be nice to maybe copy and paste the link into chat and then show the screen with the example.
Right. I'll do that. Good idea. Give me a chat. There you go. Hopefully you got that. And then let's replicate. There we go. So it's 4:12 now. We'll go until it's 4:17. And remember, you do want to type this out. This is how you learn. You learn by programming. The more you program, the better you get. You know, like I've done this for a while, so I've done a lot of interviewing, and one thing I found is that like a lot of times, like it's not a perfect correlation, but like especially like when someone's say first getting out of school or first starting software developments, like the level of the skill they have seems to be a function of how much time they spent programming. And you know, it doesn't always matter like what source it is. Like it could be like when you're studying, or it could be just on your own for fun, right? The more you program, the better you get. So like do type this stuff out. Don't just look at it. Like type it out, run it. This will build memory. You'll get used to doing this stuff. You won't like eventually like you get to a point where like you don't even think. You don't even have to think how to do it. It just happens automatically. Like for example, like you know when you're young, very young, you don't know how to walk yet. And like when you start to learn how to walk, you have to, and you might not remember this, but you have to like concentrate and think about each step. It's very deliberate. That's not true when you're adults. You don't even think how to walk. It just happens automatically. Programming eventually gets like that. You don't even have to think. It's just automatic. But before that can happen, you have to have lots of time where you program like over and over and over again. The more you do that, the better you get. So do type this out, do run it. That's how you get good at it.
I got a quick question.
Yep.
Compared to other languages, would you say Go is a lot easier to pick up if you are already experienced?
Sorry, can you repeat that? Is Go what?
Compared to other languages, is it a lot easier to pick up?
It depends on which language you're comparing it to. Like I think Go can be a good like first language if you restrict what you know to certain things. I think Python's also like a good first language too. I would not do Java, C#, C++, like anything like that. I don't have experience with Ruby, but I've heard that's also a good first language. So I would say like, Python, Ruby, Go are probably like good first languages to do if you've never programmed before. All these languages do have complex parts, right? And like eventually you get to them, but you want to do this stuff in a way that it's most easy to make sense of it, right? And I've tried to do some of that with this. Like, we first started printing, and then, like even when we introduced variables, like you don't just introduce variables, like there has to be a reason why you're using it, right? And like for us, it was that we had to adjust it and move things around. But like, yeah, I think like I wouldn't do Java as the first language, for example. Like, I mean, you can do it. It's just, there's a lot of complexity built into Java that's all of a sudden like right at the beginning, right in your face, like no kind of like easy kind of learning curve. It's just like learn all this hard stuff now before you can even do the most basic thing, right? So yeah, I would say, like I said, I would say Go, Python, or Ruby probably is a good first language. Not JavaScript either. Like that has complexity that, because that JavaScript's also a popular language. That has complexity that I think is probably too much if you've never programmed before. Now, once you've done one of these languages, like by all means, like try those other ones. Like, once you you can output stuff, you've been exposed to variables, you've been exposed to functions, if statements, looping, like et cetera, et cetera. Once you've been exposed to all that, then doing any other languages is pretty straightforward. It's because it's just the syntax difference, like largely. I mean, you have to learn the libraries, like the same way we had formats and C80. It'll have different libraries. You need to learn those, and they're going to be a bit different. But the language parts will probably be pretty straightforward once you know one language, because you're just like figuring out the syntax. Like, what does an if statement look in this? How do you declare functions in this? Like, maybe the notation's a bit different, like how you write it. Does that answer your question?
Yeah, thanks.
Yeah, cool.
I think something that a lot of people often kind of struggle with, I think, when learning a language, especially if it's the first programming language, is you might have a question like, oh, okay, well, what can I do with this? And the answer might be anything. But it's just too broad and too vast of an answer. So getting familiar with a few things that you can do, and that often comes through actually building out things on your own. But once you're able to do a few things, then you could pick up another language, but you already have the concept of what it is that you're trying to do, so it becomes much easier to pick up the other language. I would say that Go is a nice it opens up the power of the computer, I guess. Like you're able to open up the hood when you want to and need to, but you're not forced to.
Yeah. I mean, one of the things, exactly what Drew's saying. One of the things is that there's different levels you can kind of work at, and that makes more sense as you program more. But you can get really close to the way the computer actually works, or like go far away from that, and maybe get close to how like people talk, like more in that direction. But you can decide where you want to be, and I find that powerful. I find that for me it's necessary. Like I want to be able to choose where I want to work from. Other languages don't necessarily do that. Some of them force you to be very close to the computer, or don't ever allow you to get close to the computer, and I find that frustrating. So like Drew was saying, like, yeah, I mean that's like a powerful thing with Go that's nice. That's pretty cool.
I think another thing about it is the sort of culture, which you don't necessarily have to follow and don't necessarily have to identify as part of the Go community. For example, use Go, but it seems that with a lot of other programming languages, especially like high level and web, and for whatever reason, interpreted languages, it and not necessarily just them, but with a lot of languages, the sort of first instinct is to not try to write things yourself, but just go and grab somebody else's package or library because they've done it for you. And even if you're only trying to do one thing, you end up with this entire library as a dependency, and that's something that's somewhat frowned upon almost in the Go ecosystem in general.
Yeah, I mean, I think the one that people often refer to an example of, like, you pull in libraries for things that others might consider simple, is like the Node.js environment or the ecosystem. And it's not saying you have to do it that way. It's just, it seems like a lot of people do that way. Once you've programmed for a while and you become comfortable writing this yourself, you tend to write a lot of these packages or libraries, as Drew was calling them. You tend to write them yourself, right? Like, why use this when I can write it exactly how I want it and get it the way I want it? And I can also, like, if you use someone else's package, you might not feel comfortable editing it or adding stuff to it. But if you write yourself, you can make it exactly as you want. Now, it's great to say that if you've been coding for decades, and it's not fair to expect someone who's just kind of starting off to do that. But once you get to that point, that's certainly quite appealing.
And one other thing I think that is somewhat of a beginner-friendly feature, I would say, of Go, is that the standard libraries packages are all written in Go, so you can actually look at that. If you're wondering, like, how does the format print line work? How exactly does that work? Well, you can just look at the source code and look at the function in the FMT package for print line and see how it works, and that can even help to give you ideas for how you might want to program something or how you might want to arrange a package. Whereas with some other languages, like with Node in particular, a lot of its they call them modules are written in C.
Yeah, that's a good point.
That's very interesting.
Yeah, when I was kind of starting off programming, I would spend time reading other people's code because I was curious how it worked, right? This dates me, but there's an operating system, like a lot of people might use like Mac OS or Windows. There's another operating system called Linux, which is it's not a clone, but it's something similar to Unix. I've been using it for a long time, I think since 1996. And one of the things I thought was pretty cool about it was I could look at the source code. I could see how it actually worked, and I was somewhat familiar with how operating systems were created, but it'd be cool to see the one that I'm actually using, and I could go in there and take a look. And I spent time looking at that. I also spent time looking at the desktop environment I was using at the time, which is GNOME, so GNOME. And I think like back then that kind of affected me and had an impact on like what my preferences are and what my tastes were in programming and technologies I was use. I think that kind of set me. I mean, like I was using C before that, but it kind of set me to like kind of have a preference for C type style of programming. For example, like handling errors when they happen. And we haven't really gone to that yet, but handling errors where it happens, rather than like, you know, the Java or C# style where you throw an exception and, you know, you can be in the part of the code and it's like, what is this? Where did this come from? Like, how do I deal with this? But I like that handling in place, and Go very much does it that style. It does a lot of stuff that to me feels a lot like C, but just a modern C, right? With a lot of things kind of cleaned up. So yeah, I mean, right now Go is my preferred language. When I start a new company, I pick Go. So yeah.
And I would say it's also not particularly surprising that Go would or should feel like a modern C, as some of the people on the core Golang team were indeed some of the same people who originally produced Unix and also C.
Yeah, cool. Okay, so hopefully everyone's got a chance to get that going. So this is our new development environment. So we're going to use this instead of Go Playground. Okay. So, okay, that's fantastic. Now, we want to get some inputs, right? We want to get some inputs. And technically, like you know, remember before when we had, or you can even see in this code, we have the format print line. Oh, that's cool. Okay, so it has a pop-up that gives you docs. We don't even have to go to the docs. We can just look here. Technically, format print line does have stuff for getting inputs. It's just not very good, at least not for the stuff we want. So what I've done is I wrote a package to kind of replace one of the functions, and we're going to use that. So we're going to use this function here, and I'm just going to copy that. I'm going to go into repl it. And you know, like one thing it did, like if you looked at the other code, it kind of did it had this style. This one, for example, repl kind of changed it for some reason. I'm not sure why. But I'm just going to switch it back. And what we're going to do is we're going to put that in there. So this is github.com/Reiver, R-E-I-V-E-R, and that's just the handle I go by in a lot of places. And then go hyphen and then RCV. And RCV is short for receive. In the same way FMT and you know, FMT dot print line, right? Format print line. It got shortened to FMT. I've shortened mine to receive, to RCV, receive. And what this does is it's going to take some input. It's going to take a line. So in this, we're going to have a new function. So this is one we haven't seen yet. And it's called readline. So in the same way we had print line for format, in this we're going to have readline. Now, just for anyone who's ever looked in the Go format package, it does actually have something called scanline. You might think scanline reads in a line. It does not. And that's why I've replaced it with this, because it's a headache to do all that. Okay, so what I'm going to do first is, you know, first thing we want to, actually, I'm just going to copy and paste this and we'll kind of go over it. So this is my code that I wrote. So I don't, like, you know, if I was learning, I'd want to type this out, but, you know, I kind of wrote the code, so I'm not going to bother. But you should type this out. Why does it show me an error here? I don't understand that. Oh, whatever. So actually, let me adjust this so you can see it. Just move this over. If you can see the kind of like environment I had to like do this coding, you'd see why it's so awkward for me to like move that mouse over. Okay, so you've seen some of this before, right? So I have a format print line, right? And it says, and inside here it says enter something, right? So what do you expect? Okay, we've seen format print line. It's going to output a line, and that line is going to say enter something. And then after that, I have another print line. Okay, that's good. And it has something else in here. It has in round parentheses, says press the enter key when you're done. Okay, so I do have an enter key on my keyboard. I know what that is. And okay, so I'm going to enter something. I'm going to press enter. It's giving me instructions. And then, okay, well, stuff here, let's skip that. Let's jump to the end. Then what does it say afterwards? It says, okay, you entered, and then it's going to output this variable, right? Because we did variables before, right? The variables are boxes we put stuff in. And it's going to output whatever's in line. Okay, well, what's in line? Okay, well, here's some code here. Here's the second section. And remember when I said, like, with print line, prints a line, and with read line we get a line. And who do we get it from? Us, right? Like the user. I mean, we're kind of like making the program for ourselves right now, so we're going to be both the software developer and the user. But typically, you would create this program and you would give it to someone else, right? And possibly like hundreds of thousands of someone else's, and they use this, right? So you're making this for other people. We're not going to make anything as sophisticated as like a mobile app or a web app or anything like that, because before we can run, we need to at least crawl. So we're going to do this. And what this has is that RCV receive read line, and it's going to get a line and it's going to put in this variable, right? And for this, I'm introducing something here, but we've used variables a bit before, but we never had that at. So without going in too much detail right now, just take it on faith that because we want to put something into this, right? Because we want to put something into this, we got to put that at in front of it here, okay? And this here, right? Before, when we created a variable, we did it, maybe we did numbers. We actually did like dx equals 4. Another way we could have done that is var dx int equals 4. The reason I kind of wanted to avoid that because it adds int, and I didn't want to complicate it. In this case, we kind of have to do it. So here we are creating a variable. This is just how you create a variable. You start with var, and then it's the name of the variable. We're just calling it line, but I could call it anything. I could call it goat. Of course, I'd have to change that to goat. I could call it goat. And then it's a string. And what's a string? It's these things we put quotes in, right? And why are we doing a string? Well, what comes from the command line is often a string. People are going to type stuff. Okay. So we're going to run this, right? We're going to run this, but I'm going to move this over so you can see actually what we run, or else you won't be able to see it. Okay, so I'm going to click run, and it's going to run that code. So that it's pulling in some packages. So that RCV one I did has that. So let me just kill that really quick. You don't know what that means, but I'm going to run it again in a way that you can actually see what's going on. Okay, so enter something, press the enter key when it's done. And I can just sit here, right? Unless this website kills it, but I can sit here and wait. It's just waiting for us. It's going to wait for us to enter. So I'm going to enter something. I'm going to enter I am Charles, because that's my name. I'm going to press enter. And that's the enter key. I don't know if you could hear that. So I press the enter key. And it says, you entered, and then it put what I entered, right? I put, I am Charles. I am Charles. Okay, excellent. So that's what we expect, right? So what's the key lesson here, right? Now, we've seen most of this before. Like we've used the format package before, and we've seen these print lines, so we know what they do, right? This, we've brought in a different package before, like we brought in the C80 package, but this is a different one. This is receive, RCV. This is the receive package. And now we're using it, right? And when the receive package, we're using the read line function within the receive package. Now, like we saw before when we looked at formats, we looked at math, those packages potentially contain a lot of other stuff. Receive might contain a lot of other stuff. We don't care right now. We're just going to use it like this, right? We read in this line. So we got input. That's fantastic, right? I mean, our program before couldn't take input. Like imagine, for example, when we had the face there, and we like moved it to one place, move it to another. What happens if we had a program that could ask the person, like the user, hey, where do you want this face? Or what color do you want the face, right? Do you want the face to be purple, green, yellow, orange, like whatever? Do you want that? That'd be pretty cool. Now, the Go Playground doesn't support that, so we didn't do that there. I kind of wish it did. But we can do this here. We can do this in Replit. So that's what we're doing. Okay. And why we bring this in? Because most programs or applications, right? Most programs or applications are going to interact with the user, right? Because they're made for the user. They're going to ask the user something, like somehow. Like if you go on Twitter, you're going to like tweet something probably, right? So you're going to type in some stuff, right? And enter it. And like this is a bit different because like we're typing and it's like text and all that. It's not graphical and a GUI, but it's the same ideas, right? Like the user is entering a tweet and you're going to post it, right? So you're going to take some input. So most programs that are applications that you would write are going to get input from the user. So that's a big deal. Now, you might get input a bit different, but once you learn the basic concept here, it'll be much easier to write programs that get inputs in different ways. Okay, so that's good. So we went over that. Okay, so we need to pick some application to write, right? We're gonna pick something that's I think is useful, It's not too complex, right? It's useful, and it'll let us learn this stuff. So what we're going to do is we're going to create a calculator. Okay? So we're going to create a calculator, and hopefully, like, as I'm doing this, like, you have Replit in front of you, and you're typing this out with me, right? So we're going to create a calculator, and we're gonna create a calculator that adds two numbers. So the code's here, but let's just kind of type this out, right? So so you can see like I have the code. This is code I wrote before. So please provide the first number, and it gets the first number. Please provide the second number, it gets the second number, and then it adds them together. Okay. So let's do that, right? Let's do that. Now I'm gonna like move this over so you can see it. And as I write this code, it might look a little different than I have before. I'll just change it up a bit. What is the first number? Okay, so that's the first thing it's going to enter. And then I want to get the first number, right? Oops. First number. Now here's an interesting thing. At least I hope this works. If I put int, is it int? No, int 64. Okay, so ignore why I'm doing that, but just trust me, it's int 64. If I put int 64 here, and we're gonna call that first number, because that's what I got here. If I put first number, then it's gonna do that. Now I want to do a calculator, but what I'm gonna do is I'm just gonna I just want to see if it works, like this much works. All right, so first number, I just want to see before I try to turn the calculator, I just want to see if I can get this to work, right? And hopefully it does. Hopefully I wrote this library in such a way that it works fine, because I don't remember off the top of my head. Okay, so it asked me what's the first number, and I'll put 14. First number is 14. Okay, fantastic. So that worked. And I'm going to need a second number, right? Because I want to add two numbers together. Okay. So it's similar to this code, actually, right? So I can kind of copy and paste that. Now, of course, I could write a function for this, right? Like remember, like if I start repeating code, I can make it so I just set up a function, but I'm not going to do in this case. I don't want to like confuse things. So what is the second number? And then I need another variable, right? Because I want to have two boxes. These variables like boxes. I want two boxes where I can put these numbers that I get. So what is the second number? And then I have that. And then what I want to do, so maybe I'll do this. Okay, formats, prints line, first number, first number, formats, prints line. Hopefully everyone can see that. Format, print line, second number, and actually let's just test it there. I test this quite a bit. So let me I'm gonna move that. Oh no, I'll do it like that. So this code here gets the first number. So I ask for the first number, I just output some text, I print a line, and then I get that first number. And then I output some text, I ask what is the second number, and then I get that second number. And then here, I'm just going to output the first number and second number. So let's see if that works. Let's see if the code works. If it does, we can move on the next step of like making it add together. So I move that over. I'm going to run this. Okay, good. So let's say the first number is 3. And let's say the second number is 2. Okay, first number 3, second number 2. Excellent. So it's doing what we expect. That's great. And now what I want to do is I want to add them together, right? And remember, remember before I was saying it's you have to be, you want to keep it as int when it's int and string when it's string. Like if I had string here, for example, I couldn't add these numbers together. So this part that I have, int 64 is important. Okay, so I have the two numbers, and I might do something like, okay, let's do this. Result, right? This is a variable. Result equals first number plus second number. Okay, result equals first number plus second number. But now I want to output that, right? I want to show it. So I might do result and then results, right? So I'm just typing, like, you're going to see the text result. Now this is a box. When I put the box, like the variable in here, it's going to show what's in it, right? Okay, so let's run that. So it's going to work exactly the same, except it's going to add those two numbers together, because you can see I add them. So we run it. Okay, so I put 3 is the first number. I put 2 as the second number. The first number is 3. The second number is 2. The result is 5, because 3 plus 2 equals 5. Exactly as we expect. Interestingly, I got the sun in my eyes right now, so it's a little awkward. Okay, that's great. That's great. So we've added, right? Like it's a very simple calculator, but it's a calculator nonetheless. Just give me a sec. Okay, great. So I mean, we can run this again. For example, let me run this program again. So you know, I did it with 3 and 2 for like I could do whatever I want, right? I could do 20 plus 50 equals 70, right? That's what you expect. I could do, you know, -3 plus 10 should be 7. 7, right? So I mean, you could run this calculator over and over again. Most calculators don't stop working, you know, like you don't have to run the program over and over again, but like we're trying to walk before we run. Okay. Now, I have an exercise for you. What I want you to do, right? What I want you to do is to make this subtract rather than add. I want you to make it subtract rather than add. So I mean, this is the key line, right? And you've already seen how to subtract before. If you don't, ask and we can go over it. So let me put this. To do, make this calculator subtract rather than add. Okay, so I'll give you 10 minutes. Let's say 10 minutes for that, and then we'll come back. So you got 10 minutes for that. Okay. If anyone has any questions, feel free to ask. I'll check YouTube if anyone has any questions. No, not yet. Okay, yeah, if anyone has any questions, let me know. I'll just kind of hang out a bit, and if nobody asks questions, I'm just going to get up and stretch. But make that calculator subtract rather than add, right? And the key line is this. So what we're doing is like we're going to make the subtract, and then you know we're going to turn this into a fully functional calculator. And in doing that, we're going to learn a lot. Okay, I don't see any questions, so I'm just gonna step away. I'll be back. So another couple minutes. And if anyone does have questions, please unmute yourself and ask. And remember, you can unmute yourself by holding down the space bar. And the sun is still in my eyes.
I have a question about the with read line. Is what you're setting up there,
Like this?
is that something that's the actual input, the standard input throughout Go?
Yeah, so readline does get it from the standard input. Yeah, so I mean, like, if you're familiar with standard input, standard outputs, format print line will send the outputs to the standard output. Receive readline will take it from the standard inputs. There is also a version of, I think, of readline, F readline, where you can, you can pass in whatever like file you want. I'm not going to introduce that because it's more complex than I want to make things. But yeah, it is coming from the standard input.
Thank you. So in order to, so you have to import a package in order to use any type of input commands, correct?
Correct. So there's Go is it uses packages heavily. Like it doesn't, it has basics, like it has strings in, so you can add, subtract, and all that. But if you want any input or output, there's packages, right? But Go comes with a lot of built-in packages. This particular one I created, and I created it mostly because the inputs you have with format I don't think is very good, at least for reading lines. It has scan, scanf, and scan line, and you might think scan line is going to read in a whole line, except it doesn't. So that's incredibly confusing and not useful for at least what we're doing. So I created receive, and this kind of works the way I expected scanline to work, but I called it readline.
Thank you.
Yeah. Okay, so hopefully everyone had a chance to do that. So this is our first time getting input, right? And like I said, we introduced a new package, receive, and of course because it's not a Go built-in package and we're bringing it in from GitHub, there's like a URL in here, and the convention is you have the URL, but at the last part of the URL you have Go hyphen, and that's just part of the convention, and then you usually call this whatever the package name is, and you can see like elsewhere in the code. You see like over here with the package is RCV, receive, and the functions also start with receive, right? RCV. And that's convention. I could technically name this URL whatever I wanted and call the package something different, but the convention, people typically do that. So, the code starts off and it prints something, right? We've seen print line before. We've seen print line. It's just going to output something, and it asks us a question. What is the first number? And then what we need to do is we need to get that first number. And it takes 2 lines of code to do that, but we have somewhere we store it. We have a variable, right? This is like a box we put something in. We need to put that inputs, that line that we get, the number in this case, we need to get that input. We need to put that input somewhere, and we put it in this variable first number. And this, receive.readline gets that for us. And then we do something like pretty much exactly the same, except the message difference. I'm saying what is the first line, it says what is the second line, and then we call receive again, but we have a new box. Like the first box is called first number, and this box is called second number, and it puts it in there. And then just to make sure our code's working, we output each of those because it helps us to see what's going on. Like, is the first number what we expect? Is the second number we expect? And then we add it, right? Now, what we wanted to do here is we wanted to subtract, right? So what does it mean to do that? We need to change that, right? So it was a plus first, now we change it to a minus, right? And we're gonna get the result. So I'm gonna run that just to make sure it works, right? We need to make sure it works, we gotta run it. So I'm gonna run that. So I'm gonna click this button, it's gonna build it. Then what is the first number? Okay, well let's do like 5 minus 2, right? So I'm gonna type in 5, first number is 5, second number is 2, 5 minus 2 is 3, and that's our results, right? And that's what we expect. Fantastic. So our program works the way we expect it. That is awesome. And we can run it again, right? And I'm just gonna, you guys know this, if you type clear, it kind of gets rid of all that stuff. And then I'm not gonna click that button, but it if you saw before, it kind of does this to run it. The // then main.
You can also use Control L instead of clear.
Oh yeah, good point. Control L. Yeah, so you could do that. Oh, I guess it didn't work.
And it's Control on Windows and Mac as well.
Okay. So I'm running this. Was the first number? I'll pick something else. I'll pick 50, and I'll subtract 1 from it. If I subtract 1 from it, I expect 49. Excellent. So it's 49. Okay. So that's great. Let's see what we want to do next. Okay. So you know, like most calculators that we have, you know, it's not just an adding calculator. It's not just a subtracting calculator. It does both, right? It does both. And what we're going to do is we're going to make it so we can switch between these. We can switch between adding and subtracting. So what we're going to do also is, okay, so first thing, I'm just going to remove the, actually I'll comment them out. No, I'll remove them. I want the code to be easier to read. So we have this part where we get the first number. We have this part where we get the second number. I've removed the part where we output those numbers because we kind of seen it works. And then what we want to do is we want to ask the user that's using this, right? We want to ask them what they want to do, right? And it's going to be a string. It's not a number. If I want the user to type in like a plus sign or a minus sign. If I type that, if I get that in, that's a string, right? Because it's not a number. So I'm going to go receive.readline. And then, you know, to get inputs, like we said, we just put the @ there, or the ampersand there, operation. And then, okay, I'm going to remove this. And then, okay, well, we're not going to keep.
You have a typo on line 21.
Do I? What's the typo?
Operation instead of operation.
Oh, thanks.
And you need to swap.
Thanks.
The other one's fine.
Okay, excellent. Thanks, Drew. So I have that, and well, let's just output this first. Actually, I should probably kept those things I deleted. No, okay. So prints line. So first num. Oops. And then formats to print line second. Actually, I'll do it like this. Second first num. And then operation. Okay. So we get the first number. Same code as before. We get the first number. Same code as before. We get the second number, right? We didn't change any of that. Now we have some new code. We get an operation, right? And we're going to type in either plus or minus or whatever. We can actually, at this point, we can type anything. It's not going to matter, but it's going to matter later on. And then we output it. And we just want to output just to make sure things are working. And that's common. Like as you build these programs, you just kind of output, see if things are working. So we're going to run that. Okay, so first number, let's say, I don't know, 55. Second number, 22. Now what do you want to, and then, oops. Oh, I made a mistake. There's no message here. What is the operation? Okay, so let me just stop that. Okay, that was good to see. I had a bug. Actually, I don't know if it's a bug. I didn't do it properly. So I got to add that message in. That's good. Okay, so let's add that. Oops, let's add that in. Format. What operation do you want to do? Okay, so let's move that out again so we can see it. And run it. Okay, what is the first number? 55. Second number, 22. What operation do I want to do? I want to add, so I use a plus symbol. And it outputted it. Fantastic. So first number 55, second number 22, operation plus. So that's the way we expected. Okay, let's just run that again. Let's try it again. First number 100, second number 30, operation subtract. Okay, again, it worked. Fantastic. Okay, so it seems like we're on the right track. Okay, so how can we make this so it switches between adding and subtracting? How can we make it so it switches? So very useful to us, Go has something called switch. So it allows us to switch between this. And I'm going to show you that. So we're going to write this. We have switch. And what we want to do is we want to switch on operation, right? So depending on what the operation is, we want to do something different, right? We're going to do something different depending on the operation. So we're going to have a case, right? If, like if the operation is plus, we're going to do something. If the operation is minus, we're going to do something. And if it's none of the things we listed, we're going to do something else, right? Okay, so let's just kind of see what happens when we do this. I'm just gonna put a bunch of prints in here, right? Because this is an easy way to kind of see where the code goes, right? So, I'll put just plus here. I'll put minus, within the minus case, if I could spell minus. And then default, I'm gonna put, and this is what runs if none of that works. It's like, uh-oh. And then maybe what I'll do is I'll include the operation here, right? Like so I can see what it is. Okay, so I've introduced something new. I've introduced switch, right? And this is the syntax, the way you write it. What does switch do? Well, you want to switch on something, right? I want to switch depending on the operation. And when the operation that we got, when the person typed it in, if it was a plus, we do this. If it's a minus, right, we do what's underneath. So if it's a plus, we do what's here until we get to the next case. And if it's a minus, we do this. And if it's none of those, then it does this. Okay, that's pretty powerful. Now we can make decisions, right? Before, we weren't really making decisions. We were just doing one step at a time. Now there's a bit of intelligence here, right? Like it makes a decision. Okay, let's run this. Let's run this and see what happens. Okay, so first number, 100. Second number, 33. What do you want to do? I want to subtract. Okay, so first num 100, second number 33 operation. That's what we have for, and then minus, right? Minus. The capital word's minus. So that's what we expected, right? Because that minus comes from this line. And why? Because operation, what we have in that box, because operation is a variable, it's like a box, we put something in, is minus. And why? Because where did the value of operation come from? Well, operation came from reading the line. And it's what we typed in. And what we type in? We typed in minus. So because we typed in minus, it went in this part of the code. Okay, what happens if we would type a plus sign, right? We would write the word plus, right? So let's run that. Let's see what happens, right? So similar thing, I'll just clear it to get rid of that. And then 100, I'm just letting someone in. Okay, 100, second number is 33, and then I type plus. A plus, right? Just like as we expected. Okay, that's awesome. And okay, what happens if we just type in something besides plus and minus? Because like the only things we have in that switch, right? The only things we have in the switch are like we handle the plus, we handle the minus, and everything else goes here. So we expect like this uh-oh thing to happen if we type in anything else, right? So let's see. Okay. First number 100, and these numbers don't matter. Like they do matter, but like I can type in whatever. Operation, I don't know. Let's put an @ symbol, right? Like for email, @. Okay, there's that uh-oh, and then it typed it. That's awesome. Okay, so it's doing what we expected. Okay, so what do we really want to do? We're creating a calculator. And what are we going to do? Well, we need to calculate something, right? And if we put a plus here, like if we typed in plus rather than @, it would add them. If we type in minus, we would subtract them. And then, anything else, we might just put the error, right? Okay, that's awesome. So let's do that, right? Let's do that. What we're gonna do here, right? Instead of typing plus, we're gonna type in, so we're gonna do this, result, right? And then we're just gonna add them. First number, actually, let me move this out of the way so you can see what I'm typing. First number plus second number, right? And then what about here? Well, similar. Result, first number minus second number. Okay? So instead of just typing, plus and minus, it's going to actually do the calculation, right? Okay, so that seems like we got a calculator here. It's an adding subtracting calculator, but it's a calculator nonetheless. So let's run it and see what happens. And this is how you program, right? You try something, you run it, you see if it works. You try something, you run it, see if it works. And remember when I forgot to put the message I forgot to put that message, and I went back and changed it. Now, remember when I was telling you before, like, you know, back in the day, like say like 20 or so years ago, if you changed like a header file in a C++ program, it could take 45 minutes to compile your program if it was big enough. Like, imagine doing this, and every time you made a change, you had to wait 45 minutes. That would be insane. It's not like that anymore, but at least not for Go. So that's good. Okay, so we're gonna do two numbers. So let's do 10, and we're gonna add. Or sorry, the second number is 5. So it asks me, what's the first number? 10. The second number is 5. And then what operation do I want to do? I want to add, so I'm going to put a plus. Result equals 15. Look at that. That's awesome. Now, we could obviously like get rid of this, but we'll test this out first. We always want to test it and see what's going on. So I'm going to just clear that so we have some room. And we added the first time. Now we're going to subtract. So we'll do 10 is the first number, 5 is the second number, so same numbers, but I'm changing the operation. It's not going to be adding anymore, it's going to be subtracting. So I write minus, boom, look at this. So 10 minus 5 is 5, right? And that's exactly respect. And like if, you know, I could do different numbers here too. I could do like, I don't know, 50 and 7, and then add them, and 57, which is what you expect. I could subtract other things. I could do like, I don't know, whatever, 77, 7 minus 70, right? So I mean, it does what we expect. Now let's just make sure that when we put an operation we don't expect, it also like doesn't do anything, right? Because we had that uh-oh case. Okay, so it doesn't matter. I'll put a number, and then we'll put, I don't know, question mark. Uh-oh. Okay, so it doesn't understand question mark. And it handled it, right? Like, it didn't just, like, pass through it. It did something with it. Okay, that's fantastic. Okay. So we have this calculator now that does this stuff, right? And, like, the key thing, the new thing we introduced is the switch, right? This allows us to make decisions. This is powerful, right? Because one of the things computer programs, one of the things software, one of the things applications do is they make decisions, right? And they often make decisions based on input from users. Not always, right? Like if you have a drone, like a flying drone, like I don't know if you guys have ever had one of those. You have a flying drone, and it's maybe choosing like, you know, how quickly to move the propellers because it wants to like, you know, maybe turn or adjust or like avoid something. It's making decisions, and you know, it's not coming from the user per se, but it might be, for example, like it has a sensor in it that's detecting maybe something close to it so it doesn't run into it or something, but it's making decisions. There's switch statements in it, or something like a switch statement that's doing things in it, right? Like doing these things. And this is the powerfulness of it. This is the powerfulness of the computer. This is why it can do different things under different conditions. Having stuff like switch statements, and also other things like an if statement that we'll see later on. Okay, that's fantastic. Right. So we're going to do an exercise. What I want you to do is I want you to like, so right now we can do addition, we can do subtraction, right? We can add and we can plus. I want you to do it so we can multiply, right? So what does that mean? You're going to add something here, right? So there's going to be another case, right? You're going to add something here. So I'm going to put to do make it multiply. And remember, multiplication in Go is a star, right? There's no time symbol on your keyboard, although some people use an X, but the X actually isn't a time symbol, and Go won't understand as a time symbol. You gotta use a star, and then the star is, you know, shift plus the 8 character, the number 8, right? And that'll give you a star. So I want you to make this also multiply, right? So you're going to have to add another case and add another print line. It's basically like if you copy and paste one of these and you change this and change this, you should be able to get it work. So I'm going to give you 10 minutes to work on that. So it's 5:08 by my clock now, so we'll go until 5:18, and then we'll come back. So make your calculator also also multiply. If anyone has any questions, do ask.
There was one question a little bit earlier that didn't get answered.
Okay.
Maybe we could look at that. which was why would that take 10 minutes?
Why would this part? So this doesn't necessarily take 10 minutes, but if people didn't like type this out as I was talking about it, it might take them a bit of time. So I usually try to give more time than is necessary, just in case. But if everyone's done,
And there's another good question as well, which is about the ampersand.
Yeah.
Is that pass by pointer?
Yes. Yeah. So if you know what a pointer is, yes, that's a pointer. Yeah. So if you're familiar with C or any language that kind of got influenced by C, and there's a lot of them, you'll notice a lot of the similar notations to C. So yes, I'm passing a pointer, and that's why I can put stuff into this, right? In the sense of like when you pass as a parameter. But yes, absolutely. For those that don't know, just memorize for now that if I want to put something into a variable, if it appears between the parentheses, the round parentheses, I got to put an ampersand in front of it. For those that understand pointers, I'm passing a pointer to the variable.
And I'd say for those who maybe don't understand pointers, then simply what that's saying is it's passing in basically the address in memory where that variable exists, rather than the value that it holds.
Yeah, but then you'd have to understand what memory is and all that stuff. But yeah.
You do.
Okay, so I don't know if anyone else has questions. Let me open up the chat.
I know Ari. Ari says he was just asking about the 10 minutes when it was just changing the plus sign to minus sign. I just added that in for comedic relief.
Yeah. It's mainly just to give people a chance because maybe someone has kids and they had to like tend to them or whatever, or go to the washroom. It just gives people a chance to catch up. So we're getting to the point where it's starting to get powerful. Like once you get to this ability to make decisions, to do one thing versus another, based on something, like based on user inputs or based on sensor information or whatever, this is when programs get really powerful. So learning this switch, this is a big deal.
And I guess we haven't really covered a lot of the flow control, but this is one of the rare cases, I guess, in Go, where it's sort of a syntactic sugar type thing, where this is, as far as the compiler is concerned, it ends up becoming the same thing as an if-else, if-else,
Yep.
if.
Yeah, I mean,
else.
like very low level, like even ifs don't really exist. You have kind of like a go-to or a jump, like depending on what you want to call it. Mm-hmm. And all these like higher level like constructs are made out of those. But yeah, I mean, like a switch is equivalent to a bunch of if else,
And so it's kind of a matter of human readable preference.
Yeah. I mean, there's a lot of cases. Like there is another way of using a switch, where you for example, like you wouldn't put operation up here, and then you would put like your expression within here rather than just the value. I don't want to go into that right now because I think it would confuse people at this point if they've never seen this before. So I'm just I'm just trying to make it understandable, like as I introduce this stuff. So one thing, I don't know if everyone knows, I removed the code that wrote first number, second number operation. It seems to work, so I don't think we needed that. And I did it mostly because I want to be able to people to see what's here. And if anyone has any questions, feel free to unmute yourself and ask, or if you just want to chat, we can do that too.
Hello.
Hi.
Hi. I got a question. It's a little subjective, but in your opinion, is the beauty of Go the simplicity of the language?
There are a lot of people that say that. There's a lot of stuff that Go could have that it doesn't. I don't know. Like, I'm not, to be honest, like, I don't know if that's why I like it. I think like the biggest thing I like is probably the kind of like near duck typing. I wish it was full duck typing, but the near duck typing, the kind of interface oriented programming. I like that it feels like C. I like that, error handling tends to be happen in place, like et cetera, et cetera. I guess you could consider some of that simplicity, right? And like there are things you can build on top of it, like like Go has consts. Like if you want to do immutable stuff, someone asked about immutable stuff before. If you wanted to create more complex structures, right, like structs or whatever to be immutable, I mean you can do that. The compiler maybe doesn't optimize it the way some languages might, although like the languages that claim to optimize it actually don't do it either. I mean, like Scala, for example, like claims to do like conceptually like some optimizations. It does not do it, as far as I know, unless they changed it recently. But I mean, if you want to make a bunch of immutable stuff, like you can build up all this complexity. In some languages, they have something like this called pattern matching. It can be nice in sometimes. Go has something like that. Like there's a way of using a switch where you can look for, we haven't really covered this yet, look for types. And so it works kind of like pattern matching, except that you can't look into the value of the type to match on that also. I mean, like, I think some of it would be nice if they added it. Like for the longest time, like, Go didn't have, well, it has generics in that it has like arrays and also something they call slices, which is kind of like an array, and maps. And, there are generics in the sense that I can have an array of strings, I can have an array of integers, et cetera, et cetera. I can make my own type and have an array of that. But I couldn't create my own generic thing like that. I couldn't create something like an array, like maybe like an AVL tree or something like that, and make it, of string, of int, et cetera, et cetera. So some people consider that a type of simplicity. But what happened is people just did code generation, or they did, runtime things that were kind of like generics, but instead of doing it compile time, did it runtime. What I understand though, like for example, for that, one of the things that was important to the people who made Go, the compiler, is it needed to be fast. And like I mean, that was one of the things that attracted me to it. It was so fast. It was so fast. I don't want to go back to the days of like what I experienced, with C++ in the late 1990s and early 2000s. So I liked that goal. It was aligned with what I wanted. Like the compiler's got to be fast. And they didn't want to add generics in, right? Like, create your own AVL tree type of whatever you want. They didn't want to add that in unless they could do it quick. Lately, like I haven't been following it closely, but they've been talking about adding in generics. I'm hoping the syntax is what I like. The syntax I kind of want is I want it to look like, I mean, okay, with arrays and slices and maps, you use square brackets. Like, don't use something else. Make it look like that, right? Like, make it look like all the other stuff. Don't like, I mean, like in languages like C++.
They can't do that with Go because it would conflict with some other design decisions. So they're strongly considering using angle bracket.
God, that's the one.
Oh,
I
sorry.
hate.
It's the opposite actually. They can't use angle brackets, so they are considering using square brackets.
Oh, fantastic! Because I hate angle brackets. I hate it when every single language uses that. I don't like it. Like it's like everything else is using square brackets. Like make it look like everything else. Like keep it consistent. Mm-hmm. So if they're using square brackets, I'm ecstatic. Right? I'll love it.
Well, the other thing seems to be that the people who kind of have tried to establish themselves and their identity as Golang gurus.
Yeah, I know
seem to also write blogs and kind of try and give reasons for and against these types of decisions.
Yeah.
One of the ones, Bill Kennedy, I think he's pretty well known.
Yeah, I met him.
So I was reading up some of his thoughts on generics over the weekend.
Yeah.
And it seems like the most compelling sort of argument or plea for acceptance for those who wouldn't necessarily accept it is that it can be somewhat easier to read for people new to Go than if you sort of build your own like option types and stuff.
Right. Yeah. I mean, if I understood what you're saying, and like as you describe his argument, like if it fits seamlessly with the way Go does it, I think that's awesome, right? You don't introduce some new thing that's completely orthogonal and different from this. It fits. It's seamless. To me, it feels simpler, right? If you use square brackets, it's just like it's consistent. Like, you know, like I did this and I expect it to be kind of like that, right? And it is.
Yeah. Sorry. Ari's just asked a question about seeing the OK statement. So it's actually under the default. So with the switch case, then the default case will be anything that's not explicitly specified. So we currently have case plus, case minus, and then the default. So anything else.
Yeah. So the way case works, it's kind of like if you ever seen if. So it's like if operation equals plus, do this. Else if operation equals minus, do this. Else, do this, right? So this is the, like if none of these get done, and it's only going to do one of these. It's only going to do one. It's not going to do more than one. If none of these get done, then it'll do this. That's what default is. So it's kind of like your final thing that you try. Okay, so I hope everyone got a chance to do that. I'm gonna implement this now. So we wanted to add multiplication. So what's multiplication? Okay, so we're gonna stick with, like, we could pick any symbol. Like I could pick, like, I don't know, $sign if I wanted to, but I'm not gonna do that. I'm gonna just use the star, the asterisk. So I do that, and then what I want to do is format print line, and then I'm gonna make it look like the other ones because they have results, and I'm gonna put first number, and then times, and then second number, right? So it looks just like these, and what I changed was that what the user types in and what operation we do. Now these two just happen to match each other. I can make them different, but I think that might be confusing for us. I'm gonna keep the same. So let's run this. Let's see if this works. So what we expect is that adding's gonna work, subtracting's gonna work, and then with the asterisk, the multiplication is gonna work, and anything else is gonna give us Okay, so 3, 2, and let's add. Let's see what happens. 5. Okay, that's good. So we'll just clear and we'll run it again. 3, 2, minus, right? So it's going to subtract, and that's 1. Okay, that's what we expect. And let's run it again. 3, 2, times, right? Start the asterisk. 6. 3 times 2 is 6. Okay, excellent work. And oh yeah, we should also check that putting something we don't expect works. Okay, 3, 2, I don't know, percent. Okay, it doesn't understand percent. Excellent. Okay, so we made progress. We have a calculator that adds, subtracts, and multiplies. That is awesome. That is awesome. Okay. So I'm gonna also do one other thing. I'm gonna add another case to this, right? So I'm just gonna move this up so it's up with them, and I'm gonna add another case. So what I'm gonna do is I'm gonna handle the division, right? I'm gonna handle division a bit differently. So if you put a slash, what I'm gonna do is it's gonna do first number, second number, right, for the division. But also remember, like, division in this case is like long division. So I'm gonna put I'll just put R. We'll just put R there for remainder because it's going to run out of space, just so you won't be able to read it. And then I'll put, percent, the mod symbol, percent, and then second number. And I'm just going to run this really quick, and we're going to see it work. Where did my mouse go? There's my mouse. So we're going to move this over. I'm just going to add that for completeness, right? Because I want it to be complete. I want this to be a pretty sophisticated calculator. Okay, so let's just try that. We'll do 5, 2, divide. Okay, so 2, remainder 1, right? And that's awesome. That works. I'm not going to check the other ones for now. We're just going to trust it works. Normally you would check them all, but I'm not going to check them right now. Okay, so most calculators, when we build this, we don't just run them and then get a result, and then, like, imagine like you had a calculator, like you ran it, and then once it's done, it turns off. I was like, okay, I want to turn it back on. I want to do another number. And then I do a calculation, it turns off. Like, it doesn't do that. Like, it lets us, it like asks us over and over again, right? So what I'm going to do is we're going to make it so this keeps on running. It just like, it'll keep on asking us like for numbers, like forever, basically, until we get to stop. And what I'm going to introduce to you is there's another concept. There's a way of kind of like making it loop over and over again. And in Go, what you use is called for, right? So for. So I'm gonna put this stuff. I'm gonna put all this stuff. Hopefully that doesn't delete it. Okay, good. I'm gonna put it in a for. So this is the end of the for. Like this curly braces right there. So I put all of this in the for, and what does that do? It just keeps on repeating this over and over and over again, right? Like really, like when you code this, you would probably have a way of getting out of this, and we're gonna get to that, right? We're gonna get to that, like how do you get out of this? But we're gonna make this loop over and over again. Okay, so it's the same code, it's just gonna loop over and over again. And like this is useful because I don't have to keep on clearing and like rerunning this program and all that stuff. Okay, so let's run that. Okay, first number 5, second number 2. And then what operation do you want? I'm gonna add. Okay, result 7. What's your first number? Okay, we'll do 5 again. I'm just gonna keep the same one because I can, but it could be anything. Second number 2, what am I gonna do? Subtract. Okay, 3. Okay, 5 minus 2 is 3, that's correct. First number 5, second number 2. What am I gonna do? Multiply. Do the asterisk. Okay, great. Result 10. Okay, first number 5, second number 2. What am I gonna do? Divide. Okay, 2 remainder 1. Great. First number. Okay, I want to stop doing this now, right? We didn't program this in a way where you can like stop it like gracefully. So there's a secret when you use kind of these when you're on the console like this, when you're on the command line in the shell to stop a program. What it is Control C on your keyboard, and hopefully it works here. Control C. Yeah, it does. Great. So I Control C'd it. I got out of it. That's really unfriendly, right? Like imagine like you have your phone, you have an application and it's doing something and you're like, okay, well, if you want to like stop doing this, just shut off your phone, right? And then turn it back on. It's like, okay, that's really inconvenient, right? So what we want to do is we want a way of kind of getting out of this. And what I'm going to do is I'm going to introduce another concept. Now, we could do this another way, but I want to introduce this concept, right? So we're going to do it in a way that's maybe not the way you might do it, but I think it'll help, right? What we want to do is we want to make it so that, you know, we get this operation. Should we do it that way? Yeah, we'll do it like this. We'll get this operation, and what we're going to say is if. So we're going to have an if, right? And if is like a switch, except it doesn't have a whole bunch of cases, it just has one. We're going to have if. So if operation equals, and we're going to have exit, right? If operation has exit, then we're just going to end the program. And we end the program by just typing return. There are other ways of ending the program. We're just going to do that, right? So I've now introduced 2 things. One of them, I've introduced the if statement, right? And then I introduced the return to end. So the if statements, you know, I just check for something. And okay, well, actually I introduced 3 things, right? Operation, I'm checking what is the value of operation, right? And one thing to note, it's like it's double equals, not single equals, not assignment. So if operation equals exit, so I'm seeing like, is what's in the box, is it exit? If it is, then I stop the program, right? Okay, so I'm also going to change this message a bit. So what operation do you want to do? And then I'll also put type, I'll do it like this. Exit to ends the program, or end the app. Okay. So I've changed the message. It's going to say type exit to end the app. If the user actually types exit, I'm going to end the program. I do that with return, or else it's just going to like continue doing what I was doing before. Okay, let's see what happens. Let's see what happens for this. Okay, what was the first number? 5. What was the second number? 2. What operation do you want to do? In brackets, type exit to end the program. I want to subtract. Okay, so 3. Great. What was the first number? 5. What was the second number? 2. What operation do we do? Type exit. Well, I'm just going to exit. I'm going to type exit. Oh, okay, it exit. That's fantastic, right? It's not, you know, the prettiest, right? you would probably like do this in other ways, in other cases, but we're going to work up to that. Okay, great. So I've introduced the for. I've introduced, you've already seen switch. I've introduced the if, right? The exit. Okay, so these are new things you haven't seen before. That's fine. Now, what we're gonna do is we're gonna introduce something else, and what we're gonna introduce is a slice. Okay, and I'm gonna open a new tab because I don't want to mess that one up. So I'm gonna open up another of these things, and what I want to do is I want this thing to load. Oh God, this is just annoying. I hate CAPTCHA so much. Or reCAPTCHA. I wonder if it recognizes the ones in the parking lot. No, it doesn't. Okay, good. Like it's not only I have to like notice which ones are actual like vehicles, I have to figure out what it probably wants. Okay. So I wanna keep it simple right here. So what I'm gonna do is I'm gonna keep this really simple. We're not gonna like have all that complex. We're gonna go back to that, but we're not gonna deal with it right now. We are gonna like still bring in that package we have, the go receiver, or sorry, receive. So github.com/reverse/go-receive. That's the same package we have with the read line. And what we want to do is, well, I want to show you something. Okay, so what I'm going to do is I'm going to enter some things. Okay, it's going to say enter. Let me adjust that so you can see it. Sorry. Enter some things, and then I'm gonna get some things, right? So var line string, right? So I'm gonna put that somewhere, and then I'm gonna do receive dot read line, and then I'm gonna get input. So I put the ampersand in front. For those that know it, I'm getting a pointer to the variable. And then let's just make sure this works. So I'll do formats.print line, and I'll do line, comma line. Okay. So let's just make sure that works. See what happens. Why is it complaining? I have an error. So I have an error on line 12. So that's normal when you code. Sometimes you have errors. Oh, I see. I spelled it wrong. So it's read ln. It kind of matches println, right? Print line. I spelled it out, and I should have just shortened it. Okay, let's try that again. Enter some things. Okay, well, apple, banana, cherry. Okay, that's cool. You know, one thing that might be useful, like when I output that, right, like that whole thing, apple, banana, cherry, like it's a string. It comes in as a unit. Oh wait, how do I separate these? Oh, there we go. What if I want to separate that out, right? Like what if I want those pieces, right? What if I want the pieces of all that stuff? Can I separate out apple, banana, and cherry from itself? As it turns out, I can. And in doing this, we're introducing two concepts, okay? So first thing is what we're going to do is we're going to look at a Go package. So I'm going to just go to Google for now. And I'm going to type in Golang, and there's a package called strings. So not string, right? Not singular, strings. Just because, you know, the type name is string, and we couldn't use that for the package name, so we called it strings. And there's a function here called split, and that's what we want. So split basically it'll take your string, like that line, as the first input, and then what it says is, do you want me to split this by something? And in our case, when you look at the line we typed, we had apple, banana, cherry. We had spaces in between, right? Like we typed that out, but like we had space in between. So what happens if we were to split this by the space, right? What would we get? Well, what split would do is that it would say, okay, well, here's a string. I see these spaces. And these things, like, you know, we have this and then a space, this, then a space, this. All those thises, those get separated out, and it's going to give it to us. And when it gives you, like, a bunch of those things in a row like that, usually you put in what's called a slice. Now, some people might know arrays. Go has arrays. There's a subtle difference between slices and arrays. I'm not going to go into it right now, but we'll just like talk about slices. So it's going to give it to us as a slice. Okay, so we have this new package that we have. We have this function from here. Okay, so we want to use this. Okay, that's great. So how are we going to do this? What we're going to do, because we have a new package, we gotta say we're going to bring it in, right? We got to bring it in. So we go under imports and we type strings, plural, and then okay, we got that line. So let's split it, right? So we're going to do strings dot split. And hopefully everyone can see that. Strings dot split, and then we want to split, you know, the line. And we want to split it on a space. We're telling it what we want to split it on. Now we need to put that somewhere. We need a box, right? We need a box to put that in. And what we're going to put it in, let's say, let's call it things, right? We're going to call it things. And with this things, you know, it's going to have three things, right? But it's going to have three things. So the way we would get at each thing, we could do it like this. We could do, like, you know, things 0, things 1, things 2, things 3. So one thing you keep in mind, the first thing that we have isn't number 1, it's number 0. The second thing isn't number 2, it's number 1. So it starts counting at 0. In our case, we typed 3 things, so there wouldn't be one of these, right? But let's just output something. So we're gonna get rid of these 2, and we're going to format print line, and then we'll put thing 0, and then we'll output that, right? And we'll see what happens. Oops, sorry, I gotta stretch this over. Enter some things. Okay, apple, banana, cherry. Okay, thing 0 is apple. So it was able to separate that out. That's pretty cool, right? You know, maybe I want to get, you know, banana and cherry, right? Okay, let me print out some more stuff. Okay, so basically I'll just copy and paste this, and I want thing 1 and thing 2. Oops, thing 1, thing 2. So I just changed these numbers, and let's run that. So apple, banana, cherry. Okay, so I separated all this out. What happens if, you know, like I would write this text in a way that, okay, let's just clear that. What happens if I would put more, right? Apple, banana, cherry, and then maybe date. Well, no date, because like when we coded it, right, we only put 3. Right, we only put 3. So like the thing is, like we don't know how many things people are going to type in. So how do we write the code in a way that, you know, just based on based on like how many things get into that box, that things box, we can handle that, right? Go has a way of dealing with that, and we did see this already. We just didn't see it this way. So Go has, you know, the for loop. The for is what's lets us loop, right? So, you know, for, and in this case, if we wrote it like this, it's forever, right? Because there's nothing that stops it. But what we do in this case, like this things is a slice. We have a special syntax for that, right? So I'm going to type this out. I'll just show you what it looks like. And I'll show you in a sec what I'm doing. So I'm just going to leave these here for now. Okay. So what did I do? We had the for loop, and before the for loop just looked like this, right? It was just this. And now what we've done is we put stuff, between the for and the curly braces. And what we did is, what this says basically is, okay, this, things, right, which is a slice. And this works on slices. This works on some other stuff too, but it works on slices. And if it's a slice and we say, range of things, what does that mean? That means we're going to basically we're going to go through the slice. We're going to start at 0, then 1, then 2, then, however long it is. And if it's empty, well, it gives us nothing. If it has one thing in it, it just gives us 0. If it has, 50 things in it, it gives us 0, 1, 2, 3, 4, 5, all the way up to 49, right? And remember, because we start counting at 0, something that's as length 50 would go from 0 to 49, not 0 to 50. And we just type this range things, and then we assign some things. And what is index? What is this first thing, right? And we can call this anything we want. Again, we call it goats, but I'm just going to call it something that's meaningful. So I'll call it index. What is index? Index is that number. Remember we had 0, 1, 2, right? So index is that number. So, here, I'm using that number index, right? Because I want it, 0, 1, 2, so I want to get the proper thing. But also here, right? Now, actually, I don't actually need this, but I'm just going to keep it for now. And then also value. Well, what's value? Well, value is things, things 0, things 1, things of index. So what we can actually do is we can replace this with value, right? Because it's already kind of looked that up. Because why? Because value equals things of index. Because it kind of assumes that we're going to want that. So it kind of sets it up for us. Okay. So this code would let us, do this based on the length of the slices, and that's based on what we type in. So let's now run this. Okay, so we're running it, and I'm just going to move it over so we can actually see it. Enter some things. So I'm going to enter first just Apple. Okay, that worked. And what happens if I rerun it again? And I enter Apple, banana, cherry. Okay, apple, banana, cherry, that's great. And what happens if we run it again and I add something else? Because last time when I entered date, we didn't see date. Oops. Great, it did it all. So that's the idea of slices and that for loop that we use the range, that allows us flexibility, right? That allows us flexibility to deal with variable length inputs like that, right? And that's powerful. That's powerful. Like we have two powerful things right now. One, we have the switch, we have the if, and that allows us to make decisions. And two, we can adapt to the size of the inputs, right? And that's pretty powerful. Okay, that's great. So the reason I introduced that is I want to go back to our calculator. And if you remember for your calculator, let me just run this again so we can kind of take a look at it. If you remember for our calculator, it says what is the first number? 5. What is the second number? 2. What is the operation we want to do? Subtract. Most people when they write calculators, they don't do it this way, right? They're used to writing something like this: 5 minus 2. Right? They don't write 5, then 2, then minus. They write 5 minus 2 all in the same line. We want our calculator to be friendly like this. We want to allow this, right? And the reason I introduced the the strings split and slices. I mean, partly it's so you have a chance to learn about slices, but partly it's also so we can do this, right? This style, 5, 5 plus 2 or whatever. This is called infix notation. Why infix? Because this is the plus, the symbol, the operation is inside, in between, right? So we're going to do that. Okay. So what I'm going to do first, we're going to do that as an exercise. Actually, no, I'll just do it. I think it'll be a bit too complex. So I'll just do it. And what I'm going to do is I'm just going to get all this code. And we're going to start simple and we're going to build it out again. We're going to delete all that code. That's okay. We can write it again. So what's the first thing we want to do? Well, okay, we want to loop forever. I think what I'll do is I'll just put a message. Do you want to exit? Then I'll put formats, prints, line, type, exit to end the program. And then we're gonna have do exit. Oh, I guess commands. And then string receive dot readline if exits equal commands, then I return. So this we've seen before. We already went over this. So, I output a message. Do you want to exit? Type exit to end the program, and then I have this command, right? So I'm getting something user types. And if they type exit, then I want to exit. If they don't, they don't. And then I actually do that. Like if command was exit, then I return. So let's just run that and make sure that works. I click the run button and it's building now. Do you want to exit? I'll just type no. Doesn't actually matter what it is. Do you want to exit? No. Do you want to exit? No. Exit. Okay, to exit. Great. Okay, so what I want to do next. Now what I want to do is I want to get something. I want to get what do you want to calculate? Formats, prints, line. What do you want to calculate? Okay, that's great. So I'm gonna calculate something now, right? So I want to, like, what the calculate is an expression, right? Like, where they're gonna give us like 5 plus 2 or whatever. So it's gonna be expression. And then what I'm going to do is I'm going to receive that, and we're going to get readline, and I'm going to store that in expression. And what I'm going to do, we just want to like make sure this works so far. So I'm just going to, like, for now, I'm going to output the expression. Oops. We're just going to output the expression, and we're going to run that. Let's make sure that works. And it's a good idea to, like, as you code stuff, you want to just run it to make sure it works. Okay, do you want to exit? No. What do you want to calculate? 5 plus 3. Expression 5 plus 3. Okay, if you can see that, it's right there. Great. Do you want to exit? So let's keep on looping. Do you want to exit? Exit. I guess I could have made it say, like, yes for the exit if I want to exit, but I didn't do that, so I'll just leave this exit. Okay, that's great. So, we have this code up here, and this allows us to exit. And then here we get the expression. And then we don't actually want to output the expression. What we want to do is we want to split it up, right? And that's where that string split comes into. That's why we introduced that. So we bring in strings. And what we want to do is separate that out. So we're going to assign it to a box called tokens, right? And we're going to strings.split. And we're going to call this on expression. And we're going to separate it based on a space, right? And let's see what happens when we print that. So, before we kind of introduced that loop that we could see it. So we're just going to loop through this. And this is kind of like, we just want to see what's in tokens. And this is just like a way of doing that, right? So we can say, index, comma, value, assignment equal range over tokens, right? And what we're going to do, well, for each of those, we're going to print line. And we're going to say, token, and then index, colon, and then value, right? So, token 0, colon, is whatever the value is, and token 1 is whatever the value, and token 2 is whatever the value, et cetera, et cetera. So we're just using this for loop just to kind of like make sure our code's working, because we want to make sure it works at every step. So I'm gonna click the run, and I'm gonna adjust that window so we can see it. And what do you want to? Do you want to exit? No. And then what do you want to calculate? Okay, I want to calculate 5 plus 2. Now, some people might be used to writing just this. Our calculator is not sophisticated enough to do that. Like, it's something we can add, but for now we're always going to put like a single space between these, right? Like, before you can run, we're going to crawl first. So 5 plus 2, and we hit enter. And look at this. Okay, so token 0 is 5, token 1 is 1, token 2 is 2. So that's what we expect, like 0, 1, 2. Remember, we start counting at 0, so 0, 1, 2, right? So exactly what we expect. Do you want to exit? I could type no. I can do this again. So I can do 5 divided by 2. And again, it does it. And that's fantastic. Okay, so let's exit. Oops, I spelled exit wrong. That's great. So we have that now. And what we want to do is we want to we want to basically get the first number, get the operation, and get the second number, just like we were kind of doing like quite a while ago, except each of those things is in tokens, right? And like, what are we doing? Like, this is more complex for our code now, but it's easier for you to use for a normal person. And like, generally what you want to do is you want the good user experience to be for the user, right? You want them to have a good experience. And what does that mean sometimes? That means sometimes we got to handle that complexity in the program, right? But this is why software, or part of the reason software developers get paid quite a bit, and not just software developers, but it's part of the reason they get paid quite a bit, is to deal with this complexity, right? Okay, so we're gonna have to get the first number, we're gonna have to get the second number, we're gonna have the third number. Okay, so we're gonna have to tweak this a bit, but first number, tokens 0, right? Operation, right? And remember, like, we had operation before. Operation, tokens 1, and then second number, tokens 2. Okay, so let's just make sure this works. So print line first, comma first number, formats, print line, op, operation, formats, print line, second number. Oops, sorry. Okay, so what have we changed? Well, we took tokens, and we're basically splitting it up. Like, token 0 goes to first number, the operation goes, token 1 is the operation, token 2 is the second number. Why? Because it's like, 5 plus 3, right? This is the 0, 1, 0. This is number 1, this is number 2, right? So that's why we did that. Okay, so let's run this to make sure it works, right? We want, at every step, we run it to make sure it works. And that's how we know we're on the right track, and we don't spend hours, dealing with this, or as many hours. Okay, do you want to exit? No. What do you want to calculate? 5 plus 2. Okay, so the first token, or the first number is 5, that's right. The second number, okay, we're skipping over operation. The second number is 2, that's right, and the operation is plus. Awesome. We'll just try it again. We don't want to exit, and we'll do 1001 minus 23. Okay, it seems to work, right? So first number is 101, the operation is minus, second number is 23. Okay, so we've got it, so we can kind of write this. Now we're not calculating yet, so we'll have to calculate it, but we're pretty close. So that's pretty cool. Okay. So I'm just gonna remove this, and we're gonna kind of like write what we did before. Like, and what did we do? Like, before we had the operation, and we did a switch to do the different things, right? So we want to keep that. We want to do that again. So we want to switch on operation. So we're going to do a different thing depending on what operation is. And how do we deal with that? Well, okay. So when it's adding, we want to do something, right? So I'm just going to put to do for now. When it's subtracting, we want to do something. And again, I'm just going to put to do, because we're going to fill out this code in a sec. Let me just move that up. Oh, actually, oh, sorry. I should move this forward. This is not indented correctly. Okay, there we go. Sorry. When it's an asterisk, when it's multiplying, we're going to do something. When it's dividing, we're going to do something. And when it's something we don't recognize, we're going to do something else. And we'll just fill out the unrecognized part right now. Print line, uh-oh, and then operation. Okay. So for now, let's just run this and see what happens. Actually, let's do this. Let's do this. We're gonna put just temporarily. I'm just gonna put add subtract multiply. We're not actually doing it yet. We just want to make sure the code kind of goes into this, and using print statements to see where the code goes into is useful. Okay. And oh, I misspelled something. That's why it's squiggly. I misspelled print. Okay. So, all we've added now is a switch. We're just kind of like adding bit by bit, getting this to work. So based on what operation is, we're going to do something different. If we get a plus symbol, we're gonna outputs. We're gonna print out just the word, capital letters add. If we get subtract, if we put the minus symbol, we're gonna print out capital letters subtract. Same thing with multiply. Same thing with divide. And if it's something we don't recognize, we write out uh-oh. So we'll do that, and we'll come here, and we'll just run this program. We'll build it and run it. Okay. Oh, it's declare not use. I'm gonna do something. I want you to ignore this, but I just want the program to run. So I'm just gonna do this to stop it from complaining. So just ignore that, and we're just gonna run that. Okay. Do you want to exit? No. What do you want to calculate? I want to calculate 1 plus 2. Add. Well, that's pretty cool. Do you want to exit? No. I think like to make it more easier to use, I don't want to have it ask me, do I want to exit all the time? But I'm going to deal with that later. Let's do 1 minus 2. Okay, subtract. That's good. Do you want to exit? No. What do you want to do? 1 divided by 2. Okay, divide. Do you want to exit? No. Okay, 1 times 2. Okay, I do want to exit. Okay, excellent. So that's good. That is fantastic. So what I want to do now is I want to make these math operations happen. And like last time when I did this, all I did was I came here and I did results, and then I did something like first number plus second number. And then I came here and I did, first number. So I'll move that up. I did first number minus second number. But I also had this text difference, results. And same thing with here. It was, result, and then first number times second number. And then again, result, first number, second number, and then because it's long division, I put remainder, and then first number, mod, second number. So this won't compile, and like I'll go into like why it won't compile. Like if we try running it, it'll actually complain, give us an error, and I'll tell you why it won't in a sec. Yeah, you see a bunch of errors. So there was something that we had different before that we don't have in this case, so we'll have to deal with this, right? And this is normal for programming, right? What changed this time, like first when we did this, when we read it in, like the numbers we read in not as strings, but int64s, right? So they're int64, they were a type of integer. They were numbers, right? And you can add, you can subtract, you can multiply, you can divide numbers. These are strings. These aren't numbers. They look like numbers, but they're strings containing the symbols for numbers. Because of that, Go doesn't understand what they are, right? And because of that, it's complaining it can't compile. So what we need to do is we need to convert these strings. We need to convert these strings to numbers. Go does have a way of doing this, so we're gonna deal with that. But that's what we need to do. So let's do that. So what we're going to do is we're going to look at another Go package. We go to Google, and we're going to go golang and strconv. So this strconv is string convert, and it has some stuff to convert from strings to numbers. So if you have a number, like numeric symbols within a string, you can parse it. So here's the one we want. We want parse int. And so what we're going to do is we're going to use this. And we're going to go, was it here? No, it's not here. It was here. And we're going to go up, and we're going to bring in that package. And then we're going to go here. And we're going to use parseInt. So parseInt, it takes the string, and then it has two other things here. We're just gonna like put something there, and we're not gonna worry about what it really means, but we're just gonna like make use of this. Okay. So I'm gonna put. So first number is a string, so I need to have something else being an int. So first, we'll call it int, and then it's gonna be str. Assuming I remember this, I might get this wrong. Parse int, and then I'm gonna put first number. So that's the string, and then I'm just gonna put 0 here, and I'm gonna put 64 here. And I'm not gonna explain the 0 and 64. It does mean something, but we're just not going to go into it right now. It's something you could read if you need to. So I'm going to have another one, and it's going to call second int, right? And then what I'm going to do is, I want to change that second line, right? Did I type that right? strcon, yeah, okay. Why is it complaining? Oh, cannot. What's it complaining about? Oh, returns an error. Okay, so I'm gonna do something. Just because this is kind of an introductory course, we're not gonna go into this detail right now. But just trust me when I say you'll do that. We'll do this for now. Normally you wouldn't do that, but we're just gonna do that for the sake of like learning this stuff, because it's not the thing I want to focus on right now. So first int and second int should contain those numbers, but as integers, not strings. And that means we can add them, subtract them, divide them, right, and multiply them. So let's do that. So it can't be first number here anymore. It has to be first int. And it can't be second number again. It needs to be second int. And so I'll just change all these. And we'll see if this works. If it does, that's pretty powerful. Okay, I think I got all of them. So let's run that, and let's see what happens. Let's see if that even compiles. Okay. That looks weird. Do you want to exit? No. What do you want to calculate? 5 plus 2. Hey, it worked. 7. Okay. Do you want to exit? No. What do you want to calculate? 5 minus 2. 3. That's awesome. Do you want to exit? No. What do you want to calculate? 5 times 2. 10. Excellent. Do you want to exit? No. What do you want to calculate? 5 divided by 2. 2 remainder 1. Excellent. That's awesome. So do you want to exit? Yes, I want to exit. Okay, so now I exit. You know what? That whole exit thing is starting to annoy me. I'm just going to change that really quick. So what I'm going to do is, instead of asking, do you want to exit? I'm going to do this. I'm going to delete all that. I'm going to take this exit thing, and I'm going to do this. So here I ask, what do you want to calculate? And it gets that. What I'm going to do is, if the person just types exit for the expression rather than like 5 plus 2, I'm just going to exit. I think that'll be nicer. So it's not command anymore, it's expression. Okay. So I think that's a bit more natural. So let's just run that and see what happens. So, oh, why is it doing that? So we're running the program. Okay, what do you want to calculate? 5 plus 2, 7, 5 minus 2, 3, 5 at 2, so it shouldn't recognize it, should uh-oh. And if I just type exit, it exits. Fantastic. That's pretty sophisticated, right? There's a lot of programs that don't do that much. Okay, that's great. So we've actually done quite a lot, right? We've done quite a bit. So we've gone a little longer than we expected. There's more stuff we could cover, or we could just end here if anyone wanted to. How is everyone for time? Do you wanna keep on going? Just check on YouTube. How's everyone feel about continuing? I think like what I'd want to cover more is maps and structs, which is kind of like the object stuff, right? Is everyone okay with continuing, or do you want to just kind of like stop here? I'll take a look at chat.
Paul's okay to continue.
Okay.
So is everyone else.
Okay, looks like it. Okay, great. So let's get into other stuff. So just to make it easier, I'm gonna go back to probably the Go playground while I do this. And I'm just going to kind of type this stuff out. So we've actually covered quite a bit. Like we actually made a pretty sophisticated calculator. It can take expressions, it can add and subtract, multiply, it can exit. We kind of like, in the same way like when we're typing in the commands to get the outputs, like over here, let me just get that up. Over here to the right, we were sitting here and we were typing commands like this and this and all that. In the same way we do this, we actually made a program that does this. We made something, what you might call a REPL, which is what this site gets its name from. The read, evaluate, print, loop, right? We made something like that, but instead of like, commands like this, it was a calculator, but you could exit from it also. And that's pretty cool that we could do that. Though, like most programs were like that one time. Well, not completely, but like a lot of programs were like that one time. And it's pretty powerful that we made that. So we've also seen slices, and what we're also going to take a look at is maps, right? And so this starts to get into stuff that maybe that people programmed before. So if this is your first time programming, this might be a little more difficult to follow along because I'm not putting in context to something. So I'm adding this, and I put it at the end for the people who have programmed before and they're trying to just learn, what's the equivalent of this in Go. I'm showing, this basically, these maps and structs like that because of this. If this is your first time programming, you'll get a bit out of this, but I think the people who have programmed before will get more of this. But I wanted to make the class be accessible to both types of people who have never programmed before and people who know another language. So I kind of try to order it this way. Okay. So if you use other languages, you might have had something like what they call maybe maps or associative arrays or something like that. And Go has something like that too. And we'll do one example, for example. I might say, I'll just call it data, var data, and I'll have a map. And hopefully everyone can see that. I'll have a map from string to string. And what does that mean? Well, it means that I have key value pairs that are both string. And what might I put in this, right? And there's different ways of doing this, but I'm gonna do it this way because I think it'll make more sense. I might have something like, okay, well, given name equals Joe. It's not my name. I'm just putting someone else's. Data family name equals Blow. I think this is from my dad's generation. Like, if you had to make up a name for someone, like Joe Blow was a common one. Like other ones like John Doe and Jane Doe, but I always heard my father saying this one, so I'm going to use that. And you basically because I said it's from string to string, I can store like these key value pairs in there, right? And there's different ways you can kind of like output this. Like, you could output it just using a print line. So if I ran that, you would see it. I can also loop through it if I wanted to. Oh, sorry, I need to do something. So these are technically a pointer type, so you need to initialize it. This is one way of initializing it. You just add it. Like it's the same as a type, and then put these squiggly brackets at the end. So I run that, and then I get this, right? And this is one notation I can do. You know, family name, colon, blow, given name, comma, Joe. If you wanted to, you could also do the loop, right? So that's another way to do it. So I'm gonna just comment this out, and you can also loop over this. And it looks a lot like, you know, the other loop that you saw for the slice. So it'd be key value range of data, right? And I called you know, the box that I have this map, I call it data. And then I would do format dot print line, and I would say something like maybe just write key, and then I put a colon, and then value, and then I run that. And in Go, unless they change something, the order will, I think, technically change every time you run it. Oh no, maybe they changed it. It used to be like every time you ran, you kind of did a range over, you know, this map. It would put these things in it would output these things in different order, but it seems to be the same every time.
I think it's that it's not guaranteed order, but it's also not guaranteed to change.
Oh, okay. So that's interesting. Anyways, yeah, so you have that. So I can add as many things in there. If I wanted to be, you know, different, like I don't have to have string to string. I can change this, right? And same thing with a slice. I can have it from int. Of course, I have to change two of them. So maybe like age, I don't know, 14. It's a young person or younger person. Height. Oh, I don't know. If it's in inches, shit, I don't know. Let's say 72 inches. I don't know what that is. And then I can just run through that. Okay, that's pretty cool. What happens if I wanted to, you know, put different stuff, like a mix of, say, strings and ints? The way you would do this, and like if you've ever used actually, it's usually a lot of the interpreted languages do this. Like let's say PHP or Ruby or JavaScript. There's a type that allows you to assign anything to it. It could be int, could be a float, could be a string. Go has something like that if you want to use it. It's interface of nothing, right? So you have this, and I'll replace the ints with that. And of course, like, because interface, right? It's not just interface, it's interface with these squigglies after it. You need to have that plus this other squiggly at the end. Like, it always has that other squiggly at the end. And then here, like, this would work still, right? Like if I ran that, I would get the same thing, right? But I could also switch it up, right? I could also do this. Age, given name, Joe, data, family name, blow, and then that'll work. And I assign strings and age to it. And, you know, like even this can change, right? Like this could be other stuff too. It doesn't have to be string. So that's a map, right? And you could use this in different situations. Let's say, for example, maybe you have Java that's come in, you know, these kind of like these nested key value pairs, and you want to bring data into this. You might use it for that. You could use it for all sorts of things. Like I said, this probably is more useful to people who have programmed before. This information that I'm talking about right now, not the stuff before necessarily, but like this stuff especially. You've probably used associative arrays or maps before, and you have a pretty good idea what to do with it. But this is how you do maps. Okay. The other thing you have in Go that's quite useful, and this is kind of like when you do the object-oriented stuff, and I kind of showed this a bit before when someone asked the question. You have structs, and you would use these if you want to construct objects or something else. So let's say, for example, we want a dog. And this is the example I actually had before. Your dog's going to have a name, right? And we'll just make a string. And your dog's maybe going to have an age, and we'll give it an int. It's a very simple model of a dog, just like our spherical cows in physics. And your dog can bark, so we're going to make a method. And just like if you've programmed in object-oriented languages, you have these type of stuff. So dog can bark, and I'm going to spell it bark rather than bank like I did last time. And print line woof. My name is okay. So if I was here, Actually, let me change this a bit. Let's do this. If I was here, I could, you know, use the notation I do to declare variables. And there's different ways of doing this, but I'm going to keep this simple. And I might...
You need to change the method call to the receiver name.
Sorry, where?
Line 13, receiver.name, should be capital N.
Oh, thank you very much. So I have pet, and I'll just call dog. And what I'll do is I'll say dog, or sorry, pet dot name equals Rover. And then what I'll do is dog dot bark, parentheses, round parentheses. So what have I done? I've defined a type, right, a struct. So this is a complex type. This is when you want to take the simple types you have, all the simple types, including, you know, kind of the simple generic types like slices and arrays and maps, the built-in generic ones, but also like all the basic types like strings and all the different types of ints, all the different types of floats. There's even a complex number type, you know, et cetera, et cetera. And I combine them to model something in the real world. So maybe I have a zoo and I'm modeling animals, and like one of my animals is a dog. And the dog can do something, and in this case it can bark. We can have it do other things. We can even have it like, you know, change its age. Like maybe it's your birthday and it updates the age. And then I go in the code and I use this. So I create a variable called dog. I tell it I set what the name is, and then I cause it to bark. I said I was going to call it bank. And let's run this. Let's see what happens. And what I expect to happen is this is going to run. It's going to say woof, and then space hyphen space my name is, and it's going to say its name. And it's over here, so it's going to change that. And I run that. Oops, because I said dog, not pet. I do that, and I run it, and I don't have an error. And excellent. So I have woof. My name is Rover. And that's how you would model stuff. This is how you do object-oriented like things, right? And one thing you can do, right? So we have dogs. So let's say we had something else. What else barks? Actually, some foxes bark, like domestic foxes. Let's create a fox. There were some foxes they domesticated, and I'm pretty sure I remember them being. I'm just gonna move that closer. I'm pretty sure I remember them barking after a while. So fox, I don't know, it doesn't have a name. Let's just say color. And then we're gonna like give it a method. Fox. It's gonna have this it's gonna look like the other one. Woof, I am a, comma, receiver dot color. I am a whatever fox. Okay, so you see what I did here is I have bark and I have bark, and these are for two different types. Like this is for fox and this is for dog, but they have a method that looks like the signature, right? Looks exactly the same. And we'll see in a sec like why that's important, but we'll get to that in a bit. So I'm just gonna move this closer to each other. And I'm gonna leave that there, and then I'm gonna like create, I don't know what I want to call this, other pet, fox, other pet dot color equals, let's call it silver. And then other pet dot bark. So we're gonna run that. So I expect this code to be there, and I expect this fox's code to be after it. So let's run that. Okay, there we go. So woof, my name is Rover, and the next one, woof woof, I am a silver fox. Awesome. So one of the powers of this when it comes is, you know, like in some languages, what you would do is you might have a class hierarchy where, like, maybe there's animal above that, and you have a function that runs an animal. You don't do anything like that in here. I mean, there are ways to kind of like fake that or like simulate that. I don't recommend it. I don't personally. I don't like that way of programming. I think what Go has is much more powerful. I wish, like I said, like they almost have duck typing. I wish it was full duck typing. There's a couple edge cases where it's not, and I really wish they'd fix it. But anyways, so let's do this. So I'm gonna create type Barker, and Barker is anything that has a bark method. And bark doesn't take inputs or outputs. Like we saw inputs and outputs before. And what I'll do is I'll write a function, and I'm gonna silence. It's called B and then Barker. And then what I'll do is I'll have format. I'll do B dot bark. And then what else? I'll put this after it. Print line. Hey, you be quiet. Right? So I'm gonna have this silence method, and it takes a barker. So barker is anything with a bark method, and it takes that barker and it calls its bark method. Then it prints after that, hey, you be quiet. So this is maybe like a human saying that. Human speaks. Human speaks. Hey, you be quiet. Okay, so we're gonna keep this. I'm not gonna make it bark here. So we have rover. We have this. If we just ran this, it won't output anything right now. We'll just see that. Oh, right, it's capital. It's the wrong case. It won't output anything. Okay, so now we're gonna call silence. So I can call silence on pet, and I expect the dog. Okay, so dog, woof, my name is Rover, and then human speaks, hey, you be quiet. And then I could call it again. I call him the fox. Silence, pet, and woof, my name is Rover, human speaks, hey, you be quiet, woof. Oh, wait, sorry, wrong pet. That was supposed to be other pet. It's supposed to be other pet. So let me run that again. I want the fox to have a chance too. Woof, woof, I am a silver fox, human speaks, hey, you be quiet. So that is, yeah, I mean, that's basically like structs. That's essentially how you use structs. Like a lot of Go is designed in like a way like this, where you can kind of use stuff like, for example, like if we go to Google, one package, it's an IO package. IO stands for input output. And like some of the ones that are quite popular, for example, are like reader. You know, what's a reader? Well, reader is anything with a read method that looks like this, right? So it's, and you haven't seen this yet, bytes. Bytes is a type of integer, but like it takes a slice of bytes and it returns an integer, then an error. An error is a special type in Go we haven't looked at yet. But this is used all over the place, like everywhere. And if you make something that's also a reader, it's so powerful, right? Because you can take advantage of all these other tools to do it. And like another one in here that's popular is writer. So you have anything with a write method, and it writes to this. And again, like if you can make stuff that's writers, you can use other stuff. Like for example, in Go, you have this package called bytes, and they have like a buffer type. It's not bad actually. Like you can write this yourself if you're used to it. But like, what do we see in the buffer type? Well, hey, look at this. There's that read method we saw elsewhere. So what does that mean? Any function, like you know how we had the silence function, it took a barker. Any function you have that accepts a reader, right? And this is a reader because it has that read method with the same inputs and outputs. By the way, the variable name like p, n, and those don't matter, but like the types do and the order matter. Any function that takes a reader takes this because it's a reader. And what else is here? Well, the write we saw for the writers here also, right? And any function that takes that, and there's a lot of them, right? And the thing that's interesting with this is that you kind of get emergent languages, like in a sense, arising. People, like there's either like, you know, like there's built-in interfaces, or maybe, you know, you create some at your company and other people kind of, you know, create stuff that kind of works with that. They mimic your methods, they use the same methods, and, you know, like everything just kind of like fits together and works in a sense. It's very organic. It has similarities to the way like languages and humans kind of evolve. It's something I like quite a bit. I found this very, very useful. I like this part quite a bit. I don't want to go back to class hierarchies. I like modeling it this way. Just give me a second. I'm gonna drink some water. My throat's getting a bit sore. I think I've been talking too much.
While you do that, I just wanted to maybe touch upon one thing. We talked, or you briefly mentioned arrays versus slices, but then said we won't get into that. And I think there's a very easy sort of explanation as to what the difference is in Go. It's not actually particularly complicated or anything like that. An array is simply a fixed length list, whereas a slice in Go is an abstraction over arrays that allow you to have variable length lists.
Yeah,
Such
yeah. I
as you
mean,
can append and delete from them, and then they'll change sizes.
yeah. I mean, like from the point of view of, someone using this, that's exactly correct. Your array is fixed in size, where your slice can vary, and it can even vary while you're using it. If you want to get a little deeper, like if you're more familiar with how computers work, an array is a specific size of memory, right? Like, so for example, let me just make that a little bigger. If I was, where's my cursor? If I was to write var data, so let's say 256 byte, like that's a chunk of memory. It's not a pointer to memory, it is memory, right? Where a slice like that, so a slice doesn't have a number between the square brackets, where an array does. A slice, and they actually work, when you use them, they look very similar when you use them. A slice is kind of a smart pointer. So if you're used to pointers, there would be a piece of memory, and you can think of that memory as being an array that this points to, right? And you can even like make that happen. Like, I could say, for example, like this. You haven't seen this notation yet, but like this basically would say that this slice, the memory it's kind of writing to, is like of that array, because it's data, right? The data that I have up here, and it's using that memory. So if I wrote p0 equals 33, well, data 0, right? Like data 0 would then be 33, right? That's a bit more advanced. You probably won't get into that for a bit, but this is how you deal with arrays and slices and stuff like that. But yeah, I mean, like this, we've covered most of it. This course is made to be kind of an introduction to all this stuff. Obviously, you're not going to be writing implementing machine learning programs just from kind of taking this, but like hopefully, if you've done this, you've got a feel for the basics of Go, right? And it takes time to become really good at this stuff. And like really, what it is just write programs in Go. Like spend time writing programs in Go, and you will get good at this. And that's true of programming any language. Just spend time programming in it too. But in seeing this, hopefully you've been introduced to the key concepts, so that you have some level of familiarity, maybe even some competence, and you can continue with your journey in learning Go. So are there any questions? Any questions anyone wants to kind of go over?
I got a quick question. When you explained that was duct typing, right? When you explained the bark.
Yeah, with the barking. Yeah, it's basically duct typing. There's some edge cases where it doesn't work, but it's basically duct typing.
I understand that part when you talked about the emergent language, but because you are using pseudo duct typing, does it make it difficult because you're no longer referencing the interface by its name, right? It's like how you would need to remember what that interface is to know that you could fit that into a function parameter. Does that make sense?
I'm not completely sure, but let me start talking, and you tell me if I've answered your question.
Yeah.
So in this case, right, like I have a function called silence, right? And in silence, I said it takes a barker, and a barker is anything that barks. And if maybe I had another interface, right? Like I could oops, where maybe I had another interface and I typed, I don't know, I'll just call it thing, right? Interface, but it also was a barker, bark. Like it looked exactly the same. Well, that's fine. Like, I mean, this could just as equally be this, right? Like thing, and it would still work. Like it'd all work the same way basically. I could even, for example, like inline this. I could put interface bark like that, right? I can give it a name. I don't have to. I can do anonymous. People often give it names because they think it looks a bit clearer. But when I'm in this function, right, I don't have the original type. Like I don't know whether it's a fox or a dog. And all I know is it has a bark method, so I just treat it that way. Now, you could kind of dig into this. You could look to see what type it is, and there's some different ways of doing it. Like one way I could do it is I could say, okay, dog, comma, casted, B is the barker, and then I try to say, okay, well, let me see if this is a dog, and then like I would do something like, because it might not be a dog. If not casted, and maybe I just I don't know, prints line not a dog. But if it is a dog, then I would do whatever dogs can do. Like maybe I want to print something. Format prints line dog. I think a dog had a name. Dog name. Dog dot name. Right. So I could get into it like that. Another way I could do this in Go is there's another syntax for switch. And this kind of gets into pattern matching that's similar to some languages, but I could go B, and that's the barker, type, and then these case statements, I would put the type name, right? So I could have like dog, case, fox, and then default, and then I do different things based on what it is, right? So those are the ways you can, I don't know if that answers your question or if I understood your question, but those are ways you can kind of like figure out what the type is. Does that answer your question? Like, did I cover it? I didn't misunderstand.
Kind of. Yeah, I understand what you're telling me. It kind of answers it. I do get it.
I think maybe if you also think about it's kind of similar, but at a different point. So like with some OOP languages where you say this class implements this interface, in Go, it's rather that this function accepts this interface. And that interface is anything that has whatever methods are defined in that interface.
Yeah.
Yeah. So in order to know whether this class or this struct implements that interface, you would have to know all the method signatures, right?
Yeah. So you never in Go you never say something implements something, like it doesn't have to declare it. If it has the methods of that interface, just coincidentally, it is that thing, right? So like for example, if you wanted something to have a run method and a punch method, you don't have to like say I'm a run puncher, right? Mm-hmm. You just have those methods, and if you have those methods, you are that thing. And that's the duck typing part. You never have to say you are that thing. You just are that thing.
So you don't really have to go and look at that class and see if it implements it or not. But on the other hand, I guess what your question is like, well, then you have to go and look at that class and see if it has that method or not.
Exactly.
Yeah,
but if you try and pass it in, it just won't compile, right?
Yeah, exactly. So it'll be a compile time error, usually, for probably the most cases that you use it.
Would there be a lot of time spending like looking through other people's code to see if something fits an interface?
So I think in practice, like as I've been using it, usually you have a sense of like what you want, right? Like for example, like say I want something that's a reader, and remember that special read method I have? I would just go look at the thing to see I have it. And not just that, like often like when you have these popular interfaces, right? Like a lot of stuff starts implementing. Like stuff that you might think, well, this should implement it. You go look at it like, oh, great, it actually does, right?
A good example of that, I think, would be Stringer.
Yeah, Stringer's another one. So we haven't gone to this, but okay, so when I stick stuff in here, actually, let's do this. Watch this. So I'm gonna, let's just remove this stuff for now. I'm just gonna get rid of this silent stuff. And Drew made a good point. So I'm gonna put formats, prints line, and then I'll put Fox, and then it's other pets, and I'm gonna just print that, and let's see what it prints. It's probably gonna print something nasty. Yeah, so squiggly bracket silver, it's not what I want. So let's say I want to adjust that. So I would go to Fox, and those print line methods, they if you implement something, if you fit the stringer interface. So actually, let's go look at stringer. So we're going to format package, and then we go type stringer. So stringer is anything that has a string method, right? So capital S string, and it returns a string. And stuff like print line, like if you don't have that, it gives some weird output. If you do have that, it just calls string. So you can put anything you want. So what we're going to do is we're going to implement, so we don't have this like, squiggly silver. Actually, it's even worse. Like let me show you if I put the dog. We'll just put dog. I'll show you the need for it even more. Oh, what'd I do? Syntax error 21. Did I start typing something? Probably stopped typing. Yeah, we did. Okay, so let's run that. Yeah, rover 0. So this is like the name. This is the age. So what we're going to do is we're going to implement the stringer method, right? The string method for dog, and that's going to change the output. So if we just go here, we do receiver dog, and it was the stringer method thing was like this, and then we can put anything we want. We just return the string, like I am the dog named. You haven't seen this yet, but you can use a plus to concatenate strings. The dog named receiver. I think I called it name. So let's see what that runs. Yeah, see. Dog, I am the dog named Rover. So, like a lot of stuff just starts using this organically, and you find that just very naturally, like there are times you kind of check, but in practice, it's more emergent. Like a lot of times, like people just start implementing these interfaces to make it work. And like this is an advanced topic, but if you were to create your own type, your own struct, you would probably like create a lot of these methods just to work with other things. Like you would probably create this one string. There's some stuff you would implement to make it work with the database libraries, or some stuff you would make it do to make it work with, like, say, the JSON libraries, and like, et cetera, et cetera. At your company, you might have like special interfaces that just people use, and like there's even people that create interfaces just kind of in the wild, like non-official ones, and people start using them. So hopefully that helps.
That's actually very, very interesting.
Yeah. Yeah, I like this. I like this way more than creating class hierarchies. It feels a lot more like language. Okay. Any other questions? I'm just going to check YouTube just to make sure there's none there.
There's none. It seems like the people who had stayed are starting to leave.
Yeah, we've gone quite late over time. Okay.
Yeah.
Well, thank you for everyone who joined us. If you want to connect, I'm on lots of places. I have a homepage. I've got GitHub. I got Twitter. I got a couple of Twitters. One's personal. One's just tech only, depending what you want. I have a LinkedIn. Also, as I mentioned, I'm involved with one school. This one, CompSci Academy, and we have a boot camp. So if you're interested in the boot camp, please join us. You can continue with the lessons that we've done today, and we'll go further. This is a 12-week boot camp, by the way. But other than that, thanks for your attention. Thanks for joining us. I guess until next time, see you. So I'm going to stop streaming.
Thanks, Charles.